If you haven't signed up for one yet and you want to do one or you want to host one, please do so. It should be really great. I'm quite excited about the one I'm going to. It'll be nice to see some new faces, so do enjoy. There is a feedback box on the box outside. Please leave us nice notes, not too nasty notes, things that we could do better and so on. It's been great to have the feedback in previous years. It's very helpful for us to continue to improve the conference. And I think one of the questions we've had asked over the last couple of days is, or rather yesterday, is what software are you using for this speech to text? It's really great. Well, it's not quite software. There are two lovely ladies sat up on the balcony with magical keyboards. Then they press weird combinations of weird-looking buttons and words appear. For those of you who've been to previous conferences, you'll recognize them. We ship them all around Europe now. If anyone's like in America or Australia, I think they'd quite like the trip, so please do talk to them. So I'm delighted to move on with our talks. So first talk is going to be from Jennifer. We've had a number of talks at Django conferences over the last few years from people who have bravely got up and spoken about their mental health problems and the battles that they've had. And we wanted to kind of take this idea and do a Django under the hood version of it. So we need to find an expert. Who's the expert? So we found someone who has a degree in psychology, 9 years of working in public health, in mental health, and also works with tech teams in her day job, day in, day out. So I'm delighted to welcome Jennifer Akullian.
Mark?
Yes. Hello.
I need to see that.
Yeah, it's bringing it over here.
Perfect. And then presenter view. Great.
Bingo.
Thank you. So hi. I just want to start by saying thank you to the Django organization for their attention to this topic. Mental health in tech has been gaining attention, gaining momentum in recent years, and it's because of people like this. So thank you very much. So my name is Jennifer Akullian. I work for a company in San Francisco called Keen.io. We're an API-based analytics platform, and there are about 53 of us right now. We also call ourselves a people development company. So that's what I do. I'm a people developer, concerned with all things development and continuous learning. I also work for a company called Open Sourcing Mental Illness. This is a nonprofit company in the States, a small group of people that are dedicated to reducing the mental health stigma by giving talks such as these, by producing resources for developers, and by doing research, which I'll talk a little bit more about. A quick content warning. I am going to be talking about mental health. I'm going to be talking about mental illness. I'm going to be talking about my experience. And this may trigger some adverse reactions for some of you. So know that it's okay to just feel those things and remain here. It's also okay to get up and leave if that works for you better. And also know that I will be here for the rest of the day to process any of this content and talk to you more if that support is something that you're interested in. So at Keen, we use this trust equation, and it basically shows that trust is equal to credibility plus reliability plus intimacy divided by self-orientation or self-interest. It's important for us to build trust over the next 20 to 30 minutes because you are going to have an opportunity to ask questions, and I want it to be a safe forum for you to ask what you're curious about. So the idea behind the trust equation is that you can increase trust with an individual or a group of individuals by either disclosing your credentials, by demonstrating reliability over time, by increasing your intimacy through self-disclosure, or by explaining your self-orientation and trying to reduce self-interest. So I'm going to try to do all four of these things over the next 20 minutes or so. Since demonstrating reliability over time is difficult to do in 20 to 30 minutes, I'm going to just share with you some resources from which the material, the content of this talk comes from. So you'll notice that they're all pretty scientifically sound, reliable resources. So here are just a few. So a little bit more about my self-orientation and my credentials. I'm here for 3 reasons. I want to get the conversation around mental health and tech started. I want to work to reduce the stigma around mental illness, and I want to help developers help each other and help yourselves. So a little bit more about me. I'm a doctoral level psychologist. I worked in public mental health for about 7 years before moving into the tech industry about 2 years ago. And I was hired by Keen.io to help develop an internal coaching program for their developers, which I'll talk a little bit more about later. I also have a mental illness. When I was 18 and for over 10 years, I was misdiagnosed and mistreated with depression. Show of hands, how many of you use glasses or contacts to help you see? Okay. And in regards to your vision, how many of you have been told to just try harder? So I tried really, really hard. I tried to pick myself up by my bootstraps. I tried to just be happy, to just focus on the positives, for which there were a lot. I saw countless doctors over those 10 years. I tried every medication that was put in front of me, and nothing seemed to help. I also went to therapy for about 8 years. I tried a variety of different therapists. I tried a variety of different therapeutic orientations. And again, nothing seemed to help. When I was in my late 20s, I saw a psychiatric specialist in mood disorders who diagnosed me with bipolar disorder. And I was put on a series of medications and have been relatively stable and feel like a normal person ever since. So just a few statistics about bipolar disorder, if you're not very familiar with it. It's found in about 2.6% of the population. The median age of onset is 25. It's genetic. It's found equally in both men and women. It's found in all races, ethnic groups, and social classes. There's a gender bias in misdiagnosis. Women tend to be misdiagnosed with unipolar depression, which is what happened with me. Men tend to be misdiagnosed with schizophrenia. And on average, it takes 7 years of seeing doctors before receiving an accurate diagnosis, which is really insane if you think about that. There are many medical conditions that take that long to diagnose. The suicide statistics for people with bipolar are very concerning. About half of all individuals with this diagnosis will attempt suicide at least once in their life, and about 1 in 5 or 20% will be successful. So this is what I think society thinks that I am based on having bipolar. These are the images that come up when you Google bipolar person and a depressed person, which makes me think most of you believe I either have multiple personalities or a bad migraine headache. What this is supposed to depict is a fluctuation between mania and depression. So manic episodes are characterized by sort of this euphoric feeling, rapid speech, grandiose thinking that you can solve problems others have not before you, impulsiveness, a second, and a number of other things, some problems with eating and sleeping, staying up all night. Weight loss is associated with the manic phase. Whereas depression is characterized by loss of interest in activities, hopelessness, fatigue, a pervasive sadness, isolation, and suicidal thoughts. I think this picture better depicts my experience with bipolar. So I feel like an exhausted, fire-breathing dragon, perpetually followed by a dark, stormy rain cloud, on an iceberg, out to sea by myself, completely isolated. So the fire-breathing dragon, I am diagnosed with what's called mixed episodes, which it's really fun. It's where you have both symptoms of mania and depression at the same time co-occurring. And the symptom of mania that I experience strongest is irritability. So if you think of those times when you are just so annoyed, so irritated with something that you just sort of snap at them and feel bad about it afterwards, that's what I feel like 100% of the time. It's strongest with people I'm closest with, but I basically just feel like an asshole all the time for how I behave. I'm exhausted because it is really difficult to maintain appearing like a normal person when I have these symptoms. The rain cloud, of course, is the depression, so this thick, heavy blanket of sadness that just doesn't go away and that there's no explanation for at all. Everything in life is going just fine, but just feeling extremely hopeless that anything is going to improve. And then the social isolation. No one wants to be around someone who's severely depressed or who's so agitated that they snap at people constantly. So it's just easier to isolate myself and exist sort of independently away from people. So these are the neurotransmitters that are not working properly in my brain. So neurotransmitters are the chemicals that hang out in the synapses between the neurons, and you essentially need there to be balance between these neurotransmitters in order for these different areas of functioning to be working properly. So you'll see that all three, dopamine, norepinephrine, and serotonin have an impact on mood and cognitive functioning. Dopamine impacts your ability to feel pleasure and reward, and also your motivation and drive. Norepinephrine impacts your alertness, concentration, and energy, and serotonin, your obsessions and compulsions and memory. And then, of course, the overlapping areas are where both neurotransmitters impact these areas. So norepinephrine and serotonin all impact anxiety, impulse, and irritability. Dopamine and norepinephrine impact attention, and dopamine and serotonin impact appetite, sex, and aggression. So to balance these, I take 4 medications. I take a selective serotonin norepinephrine reuptake inhibitor, which essentially blocks the reuptake of those 2 neurotransmitters from being sucked back up into the neurons so that more of them hangs out in the synapse. I take a 3rd-generation antipsychotic. This was developed originally for schizophrenia, but was shown to have some mood-stabilizing effects. I take lithium. Lithium gets a really bad rap in TV shows and movies. I find that it's stereotyped as this drug that makes you completely lethargic, turns you into a zombie, you can't talk, you can't stay awake. I take a pretty high dose of lithium, and I'm obviously functioning just fine, I hope. So it's just something interesting to be aware of when you see how it's depicted in the media. And I also take an anticonvulsant. So this is a medication that was made for epileptics that was also found to have a mood stabilizing effect. So surely some of you are wondering why I'm standing in front of you talking about the psychiatric medications that I take. I can tell you that if I were standing here telling you about the medication I take for my thyroid disorder, it wouldn't be as uncomfortable for me and maybe as weird for you. Why is it that it's so uncomfortable to talk about mental illness? I ran into a gentleman last week from the Netherlands and asked him if I flashed a picture of an elephant, if you guys would know what I'm trying to say. So in the event that you don't, the elephant is in the room. So this is the topic that we all know exists that no one's talking about, and this is mental illness. And the reason we're not talking about it is because of stigma. So these attitudes and beliefs that view symptoms of psychopathology as threatening, uncomfortable, violent, unpredictable, and this leads to discrimination. So throughout history, people with mental health problems have been treated differently. They've been excluded, they've even been brutalized. And stigma is something that's important to consider for a few different reasons. One, the social effects of discriminating behaviors include exclusion, poor social support, poor subjective quality of life, low self-esteem, the list goes on and on. Stigma actually hinders treatment outcomes for mental health problems, and in part because stigma and discrimination against patients with mental illnesses prevent them from seeking help. So how do we reduce the stigma? It's multifaceted, but one way is through education and disclosure. So I'm hoping by sharing my experience with mental illness, I was able to do these three things: improve attitudes towards people with mental health problems, increase future willingness to disclose mental health problems, and promote behaviors associated with anti-stigma engagement. So a little bit more about mental illness in general. It's a range of conditions that impact mood, thinking, and behavior. Approximately 1 in 5 individuals is diagnosed with a mental illness, and approximately 1 in 25 individuals is diagnosed with a serious mental illness, such as bipolar or schizophrenia, so about 4% of the population. This is where the symptoms have a significant impact on day-to-day life. And we've called mental illnesses different things over the years: mental disorders, diseases of the mind, behavioral disorders, but really what we're talking about are brain disorders. There are 100 billion neurons in the brain and 100 trillion neural synapses between those neurons. It's a complex interworking neural roadmap that we're just beginning to understand with advances in science. And what we're noticing are neural patterns between different diagnoses, different mental illnesses. So here are 4 of the more prevalent mental illnesses that are diagnosed. So anxiety, which includes generalized anxiety disorder, social anxiety disorder, panic disorder, phobic disorder, post-traumatic stress disorder, accounts for about 18% of the population being diagnosed with some sort of anxiety disorder. Depression, major depression, and bipolar are both mood disorders, and major depressive disorder is found in about 7% of the population, whereas, like I said, bipolar is found in about 2.6%. And schizophrenia, which is characterized by delusions and paranoia. There can be hallucinations that are auditory, visual, or tactile, although auditory hallucinations are the most common, is found in about 1 in 100 individuals. So these statistics come from the United States, but they are comparable to the rest of the world. So I want to talk now about the research that is out there about mental health in the tech community. So the research is very limited. What is out there was produced in 2014 by Open Sourcing Mental Illness. And it was a survey with about 1,200 respondents, which makes this the largest mental health survey in the tech industry thus far. It is being replicated right now, so the link there to the bottom is if you want to opt in. You can be a part of that research. So it is for across the world, but predominantly responders were from the United States. It is an opt-in survey, an open survey, so there is a degree of reporter bias. But the one piece that I think is most interesting from this research is the percentage of people that have sought treatment for a mental health condition. So to be clear, this does not mean there's a mental health diagnosis. Someone can seek treatment for a panic attack, but not necessarily have panic disorder. Someone can receive treatment for depression, but not necessarily have a major depressive disorder. But regardless, this is showing that about half of the people in tech that were surveyed have sought some sort of treatment for a mental health condition, which suggests that even more have been struggling and that haven't sought out treatment. Why is the impact of mental illness and mental health so significant? So if we're talking about this, let's frame it a little bit more positively. Mental health, mental wellness, when things are going well. What does this mean for you? It means that victories feel more rewarding, your concentration is improved, your motivation is improved, you have better working memory, you have faster processing speed, you're less irritable, less impulsive, and have less anxiety, you have higher energy, higher overall mood, and overall cognitive functioning, all of which leads to increased productivity, which means there's less absenteeism from work and less presenteeism, which is your when you're at work but you're not necessarily fully productive. So when those 50% of individuals that suggested they were receiving treatment for a mental health condition were asked if it interferes with their work, you'll see that about 80% of them suggest that it does, at least rarely, often, or sometimes. So we have, do you see the problem here? We have about half of the population that is saying at least sometimes or rarely they're being impacted by a mental health condition that impacts their work. So we can't talk about mental health and mental wellness without talking about burnout. So burnout is the state of emotional, mental, and physical exhaustion caused by excessive and prolonged stress. The big question is, why are developers burning out? So there are reasons that people burn out in general that you're probably familiar with, reasons such as feeling underappreciated, feeling that you're not having an impact at work, or that your work is unrewarding, taking work home with you. But developers have sort of a set of unique characteristics as well. The physical lifestyle of engineering, being in front of the computer all day, working long hours, taking breaks, or having personal hobbies that are also on the computer. The work is cognitively intensive, mental fatigue takes a toll, and there's a lot of sacrifice and effort put into high-risk problems that can often fail. But ultimately, if you ask me this question, why are developers burning out? It's pretty simple. You guys are working too hard. You're working too hard and you're not talking about it. So you've all heard, have a better balance between life and work, and I know this is not new information to you. So what I want to focus more is on the second piece, is why are you not talking about it? Why are you not talking about your feelings? Okay. So I want to bring this up once more. If you've ever burned out or approached burnout, you've probably noticed that many of these areas in your life were impacted. These neurotransmitters are also impacted when someone is experiencing burnout. Burnout can look an awful lot like a mental illness. So the things that we're doing to prevent mental illness, to support those among our community that do have mental illnesses, are also helping those who are experiencing burnout or who are approaching burnout. So ways to avoid burnout. The first thing I want to say is that if you are concerned about your mental health, see a doctor, see a professional. It's really easy. If your leg hurts, if your chest is pounding, and you're concerned about your physical health, we go and see doctors. But there's this reluctancy to see mental health professionals. This is a brain disorder, okay? So you need to see a doctor to get help to treat a brain disorder. It's just a different area of the body. And then, of course, the one that you've all heard a billion times is that you need to have mandatory unplug time, and you need to take time to recharge. So like I said, the one I want to talk more about is talking to someone else about what's going on for you. So introspection is a prerequisite for talking to someone else. You need to be able to think about your thoughts, your emotions, and your behaviors objectively and without judgment in order to then talk to someone else about it. So introspection is something that we practice at Keen, both individually and organizationally. We believe in the power of curiosity, of reflection, of thoughtfulness, and of self-awareness. And we have some activities that are kind of unique. So we have a weekly introspective happy hour that everyone in the company takes part in. So if they're in our San Francisco office, we get together at 5 o'clock on Thursday nights. We have a couple drinks, have some food, and we talk about our feelings. And our developers who are remote, which we have across the United States and a few internationally, do this earlier in the day over Google Hangout. So our introspective happy hour is called A&E. It's been going on for all 5 years that the company has existed. A&E stands for Anxious and Excited, historically, where you basically get together and you get in a circle and you go around and talk about what your anxieties are and what your excitements are. It's not a solutioning time, it's just a time to listen and express how you're feeling. So over time, this has evolved into what we now call alive and experiencing. And we use this feeling wheel, which we have around the office. Our remote engineers have them in their home offices because we feel a range of emotions. And so we like to put vocabulary to it because of the science behind this. So essentially, when you put a word to how you're feeling, like the emotion anger, the neural activity shifts from the amygdala, which is in the limbic system, the emotional center of the brain, into the prefrontal cortex, which is responsible for things like planning and reasoning and problem solving and advanced processing. So this is sort of a brain hack. And I do have to mention one other quick brain hack that my husband loves. If you're feeling really, really emotional, first of all, that's okay. But if it's getting in your way and you need to get back to work and you're really upset about something or angry about something, try doing a complex math problem. This kind of does the same thing is labeling your emotions. It moves the activity from the amygdala into the prefrontal cortex because you can't solve complex problems while you're super wrapped up in that part of your brain in the emotional center of the brain. This is great for kids too. If your kids are throwing a temper tantrum, give them a little task to do that shoots them up into the prefrontal cortex and out of the amygdala, out of the limbic system. So who can you talk to? You can talk to your peers, your colleagues, your partners, your friends, but I want to mention this other option for someone to talk to that we use at Keen, which is coaching. So coaching traditionally has been reserved for executives as a way to talk about reserved for executives, but we have built an internal coaching program for our engineers so that they can talk about what's going on for them. So this is not advice giving. The way that it differs from mentorship and therapy is that the coaches are not giving advice to the developers. It's just a chance to be introspective, to have a sounding board, to discuss professional or personal content. And it's nice because the coach can help gauge if someone's burning out. At Keen, it's 100% confidential, so nothing is shared with supervisors or managers or founders. It just stays between the coach and the developer. And it is an opt-in program, but 95% of the company has opted in, and 100% of our remote developers have opted in. So they're working with a coach every other week for an hour to be introspective and talk about their feelings. Another forum to talk about how you're doing is called DevPress. Is anyone familiar with DevPress? Have you heard of it? Okay, so it's a forum to basically talk about whatever's going on for you mental health related. So here are a few forum topics that I chose the other day that were trending. And it was recently taken over by open sourcing mental illness. So the current link is at the bottom, but if you just Google devpress.com, it'll take you to this forum as well. So A&E, coaching, talking to other developers, using DevPress, they all contribute to this discussion about mental health that isn't happening right now and that's contributing to burnout. And if you have a mental illness, is contributing to symptomatology. But this is just the beginning of the conversation. It needs to continue. If you work for an organization and want to get the conversation started there is a group of individuals in the United States who are in tech, who have mental illnesses, that go around to other companies and to conferences and give talks similar to these. They're called MH Prompt, so just another resource. So 1 in 5 individuals is diagnosed with a mental illness. That suggests that about 60 individuals in this room has a diagnosis of a mental illness. Approximately half of tech is receiving treatment for a mental health condition, so that's about 150 people in this room, which suggests that even more are either suffering in silence or are burning out or have burned out. So this is your chance to ask any questions about what I've covered in this short time or anything that I haven't covered. I'll do my best to answer the questions. Thank you again for having me, and thanks for your attention to this very important topic.
Thank you very much. We're going to do something slightly different with questions for this talk. If you do feel that you want to express yourself rather than have me reinterpret your words in the question, then I'll give you an opportunity in a minute to, I'll take a couple of questions from the floor if people want to do that. Otherwise, Jen is happy to speak to you individually after the talk if people don't feel confident talking about this in a public forum. So we'll start off with the A&E sessions that you do at work. Are they purely about sort of work-related anxiety or excitement, or is it more about open like anything that's going on in your life? And how do the staff feel about being asked to open up, about things that are happening in the rest of their life at work?
Yeah, that's a really good question. It's not limited to just their professional lives. So we talk about a whole range of what's going on in our lives, personally, professionally. It can be something really minor. It can be something, I've talked about my mother being terminally ill. An engineer has talked about almost hitting a turtle on his bike in the road. It can be, something really extreme that's going on at work. Something's not working. It can be something completely related to family or home. And people don't always join the company super excited about it, but it's something that we do as a whole community, and it's something that for those that are uncomfortable with it, have gotten used to it, and find it very valuable, and it's still really valued as one of our top activities at Keen. So people, it's uncomfortable because we don't like talking about our feelings, so we practice talking about our feelings, and it gets more comfortable.
So the coaches you have that you use with these systems, are they normally just other developers, other company employees? Are they people like yourself with professional experience?
Yeah, so we have 3 coaches. So myself, have a PhD in psychology. We have a master's level psychology and organizational development individual who is a coach as well and has a coaching background. And one of our founders is one of our coaches as well, and he has some coaching training in the United States.
Does anyone have a question from the floor? From that I can see, that's fine. What would your recommendations be about talking to someone? What's the sort of tips to get started with this if you are feeling very uncomfortable? Where do you go to start talking to someone?
Yeah, I mean, you can make it really simple and tell someone, whether it's a therapist or a friend or a colleague, that, like, hey, I just want to be more introspective. I want to talk about my feelings because I know from everything that science says that this is really valuable. So you can just start there. If you have bigger goals, like I want to problem solve through something, or I want to get a different perspective on this, you can ask for that as well. But it can be really simple, just as simple as I want to be more introspective. I want to talk about my feelings.
How can you tell the differences between sort of, I'm experiencing a bit of burnout, I've been working a bit too hard for a while, I need to just slow down and I'll be fine, and actually I'm developing something more serious, more like a disorder, and how can you sort of identify yourself, the difference between the two?
By seeing a professional that does that for a living.
Regarding the DevPress service that you mentioned, is the anonymity better or worse, do you think? Does it make it better for the community, better for the individual?
I think it's a valuable forum for people, to go in and talk about things that they're not going to talk about with their coworkers or maybe even their feelings. I think the anonymity does improve the likeliness that a big group of people are using that, and it provides sort of a safer forum to be listened to and to talk to other people with similar problems.
Is there any research showing the productivity benefits from running these sort of programs within the company that you could share with anyone who wants to share it with their employers?
Yeah, so this is a little tricky, rate of investment, trying to measure this over time is something that we're just partnering with Sigmund in Denver to start evaluating some of these programs. Right now what we're doing is we're looking at our retention rates, which are very, very low in the company, and the reasons why people are joining the company. So we're sort of documenting people. The coaching has been looked at as the #1 perk of working for Keen. So we're following some of that. And we're also doing self-reports. So developers feel that 90% of developers feel that the coaching program is contributing to their professional work at Keen. 95% are overall very satisfied with the program. So, not the strongest data right now. What our founders say when they're asked these same questions is that you really just have to believe it. The founders, the C-level executives have to believe that this is important. It's a cultural shift. And if you're asking like, I need the data, I need you to show me that this is going to make my engineers more successful, you're probably not in alignment with that kind of programming. So more data to come, but that's what we have for now.
For a long period of time, developers have been asked to sort of separate their private life from their work and concentrate. So is this kind of talking about your private feelings going against that way that we've been sort of trained to work?
Yeah, at Keen, we don't believe in that. We believe that it's important to talk about, what's going on at home, at work, what's going on at work, at home. We find that this balance works really well for our employees. So I guess it's an opinion. If you feel they really should remain separated or intertwined, one thing you can do individually is try both and see what feels better for you.
If you had a colleague or a friend or someone who you feel might be struggling with these sort of issues, do you have any tips for how to get started encouraging them to behave this way, other than say, go and watch this talk?
So it's tricky when you're talking to someone who is experiencing burnout or who has a mental illness. You really have to be careful in your efforts to empathize and give advice. Probably the best thing that you can do is say, I understand that's really hard, and I'm here for you. Let me know how I can help. Anything beyond that, any advice of specifically what someone should do can be very dangerous. So, if all else fails, recommend someone to a professional, and just be careful with your empathy in situations like that.
So there's a couple of questions relating to gender bias, as to whether you feel that is the propensity of more mental health problems in tech potentially linked to the higher proportion of men in tech, and that we're taught to be real men and not talk about our feelings, or and is the misdiagnosis higher in men than in women in this case? Or like for autism, it's higher in women than men. Many are not diagnosed because it's assumed to be a male problem.
I don't have a good answer for that. I'm not sure what the research says around the breaking down by gender. I think that open sourcing mental illness specifically didn't look into that as to avoid some of the sensitivity around that. So yeah, sorry, I don't have a good answer for that one.
Are there any studies relating to your diet and your impact on that, on your mental wellness and burnout and so on? Eating too much sugar, too much coffee, etc.?
There is. I'm not an expert, so I'm not going to stand here and pretend to spew off what that research is. But there's absolutely research that shows, a healthier diet has a more positive impact. Same thing with exercising. Same thing with being open and talking to other people about what's going on. So that's definitely out there if it's something you're looking for.
Okay, there's a few other questions, but we'll move on. Thank you very much.
Yeah, great.
Okay, so going slightly with a different sort of topic for the next talk. One of the things we like to do with Django under the hood is to pick an area of Django, a little bit of Django, and go, how far down the rabbit hole can we go here? So this is going to be one of those talks. So what I chose for this year was to look at validation. So it's an essential part of any website. You've got to check that if you're receiving data in, that it's valid data and that you're happy to accept that data. So to get us into the details, I'd like to welcome one of the Django committers who's contributed quite extensively to this area of Django, Loic.
Hi. So I'm Loic. We met briefly yesterday. I work at the World Food Program. I've been a core developer of Django since 2014. And you may know me for my work on forms and the ORM. Or maybe for breaking your project with some backward incompatible changes. So 2 days ago, I was talking with Matthias, who's the author of Faint CMS. And he was complaining about the most painful backwards incompatibility in Django over the years. And every single one of them was mine. So, so I apologize for that. I think it was for the greater good, but what do I know? Anyway, today we are going to be talking about validation. So what are the main concerns when it comes to validation? First, I would say enforcement. How can you ensure that your validation logic actually runs? Then comes user experience. How do you provide good feedback to your users about what went wrong? Performance, ensuring that the validation logic isn't wasteful and that it can handle the expected caseload. And finally, convenience. Is your validation logic easy to audit? Is it easy to change? Does it incur duplications all over the place that need to be kept in sync? So while some of those concerns go well together, others are really at odds. For example, enforcement goes well with user experience. Most users don't want to break your business logic and need issues to be brought to their attention. Also, if the system let through invalid data, it's almost guaranteed that it will start to behave in unpredictable ways, which ultimately leads to poor user experience. However, user experience and performance, those are often conflicting. For example, the database already enforces all the uniqueness constraints. So a model form or a model serializer from DRF could just try to save the object and let the database do its job. Except that Django doesn't quite understand database errors. So the user feedback would essentially amount to something went wrong. So instead of that, Django will perform one database query for each uniqueness constraint for the sole purpose of providing good user feedback for something that the database already does. And by the way, this introduced a race condition, because while Django is busy doing all those queries, the database may change, and when you try to set the object, you would get an integrity error. User experience and developer convenience, those are on the opposite end of the spectrum. So in this day and age, people expect native apps and great user experiences, and that means that you may have to write your validation logic multiple times over and in multiple languages. And since you cannot trust anything coming from the front end, then you have to do that all over again on your Django backend. And maybe for good measure, you should also have it in the database. So this actually brings the question, where should you validate data in a Django project? So first on the front end. This can be ad hoc JavaScript functions or through a framework like Angular. HTML5 can actually enforce most of the basic validation that is declared on Django fields. Present validation with the required attribute, type validation by using the relevant input type, bounds validation with min and max. You can even validate against a regex with the pattern attribute. Out of the box, Django supports some of these, but it's pretty easy to customize the HTML output using widget. Sadly, the UX provided by the browser is not always great when it comes to HTML validation, but a framework like Angular Material will be able to pick up those clues and provide a decent experience. And then, of course, with native apps, most native framework offer decent APIs, at least for the basic validation. So the upside of front-end validation is that it's great for the user experience. It provides immediate feedback as the user goes, instead of all at once the form is submitted. And of course, it's faster because it doesn't require a round trip to the server. It may work offline, which is great in many scenarios. But the downside is that it needs to be duplicated on the server side for obvious security reasons. Next up is Django View. So it's not the most elegant way of doing validation, but it ticks most of the boxes. It's on the server side. It has access to the requests, to the session, to the models, and it provides feedback by rendering. It can provide feedback by rendering a template or returning an HTTP error. The downside is that it's easy to circumvent, and we'll see why in a minute. So next up is Forms and DRF serializers. Those are the designated tool for handling and validating user submissions. They have dedicated APIs to describe and validate data and to handle errors. But just like the views, they're very easy to circumvent accidentally. Take this example. You have a model form. You're very confident about your validation logic. You have excellent test coverage for it. But then a few weeks later, one of your colleagues had a model admin for it. And it's quick and easy, just 3 lines of code, and then all your validation logic is bypassed. So of course you could use a custom form in the admin, but more often than not, that's not going to happen, because it's just too easy not to do it. And same story with direct model queries, or in the Django shell, or in the script. This is actually a cardinal rule of Django. All validation logic that lives on a form, on a serializer, or in a view, will be completely bypassed at one point or another. So serializer, to be fair, do a little bit better than forms, because you could consider using them in place of manipulating the model directly. But this requires a change of habit and discipline within the team. There is also an admin renderer, so you can still wrap up a quick admin interface without bypassing the serializer. But then you lose the Django admin, which is more fully featured. Also, unless you completely give up the Django admin, it's going to be a horrible user experience to have 2 different admin interfaces depending on the models. And now the model, which is an interesting place for validation. It's designed for the task. However, it doesn't run by default, because Django didn't get model validation until the 1.2 release. Frameworks such as Rails went the opposite direction. So it's only called by model form. Django REST framework purposely ignores it in model serializer, on the premise that it's more auditable to have all the validation in one place. And even with a model form, as we'll see later, it only runs partially on the fields that are exposed by the form. Now, if you want it, it's pretty easy to enforce it by calling full clean in the model save method. So you could also do it with the pre-save signals, but signals are evil. So now that we are calling the save method, we are calling it in the save method, it's much harder to circumvent. But unfortunately, it's still not guaranteed to run. queryset.update is an obvious culprit, but there are less obvious ones. For example, if you need to load 1 million records in the database and you don't have the whole day to do it, you should use bulk create. But then your custom save method is not going to run. Same with the fake ORM in run Python, in migrations. That will ignore your custom save method. And of course, there's always the risk of the DBA running queries behind your back. So another downside is that it's not always available. If you don't control the model, for example, when you live in a third-party app, when they live in a third-party app, you simply cannot customize their validation. Unless you're into monkey patching, but yeah, if you like to live dangerously, you might as well do without validation. So another downside, most of the time it's redundant. A lot of the validation will already happen on the form, and you'll be running it again. And if you use a model form or a model serializer, even this expensive unique validation is going to run again, and that will double your number of database queries. Also, the database enforces a lot of that validation, so that's yet another level of redundancy. And finally, it breaks expectations. Because Django doesn't run it by default, most third-party libraries don't expect the safe method to throw validation errors, and therefore they don't handle it. Now, the database. So it's designed for the task, and it's always enforced. So validation rules set in the database are carved in stone. So the whole situation with admin or ad hoc queries bypassing your validation, that's a thing of the past. And it's also very performant. For example, let's take this simple model. It's an article that blows up when the title is boom. If we loop 1,000,000 times over to create model instances and call their full clean method, on my laptop this takes about 7 minutes. By the way, if you don't do that within a transaction atomic block, that's going to take much, much longer. Now with bulk create, moving the validation logic to the database with a constraint, this takes about 45 seconds. So it's faster by almost 1 order of magnitude. Now the negatives. It's going to be backend specific. So the ORM gives you some database agnostic validation like type enforcement, unique together, and soon you should even be able to do simple check constraints in a somewhat portable way, thanks to the class-based indexes that landed in Django 1.11 and expressions from Django 1.9. So for example, we could implement something like this. That would generate the SQL from the previous example. But anything more advanced, like custom function or PL SQL or triggers, that's going to be backend specific. It's also harder to write. A lot of people use the ORM because they don't want to deal with SQL, and it's harder to audit. Because it's likely to live in a migration, it's completely out of sight, especially as migration are mostly historical data that you don't generally need to care about. So at the very least, if you have these kind of migrations, you should reference them with a comment in your models.py. And it's obviously much harder to maintain. Because it's stored in the database, so it's a state that needs to be managed and migrated. So those are pretty much all the places where it's reasonable enough to perform some validation. Of course, there are other places, like salary tasks, migrations, management command, where you may need to enforce your validation logic, but those shouldn't be where you implement them. They should trigger validation implemented either on a form, on a model, or on a serializer. All right, now we're going to focus on the validation APIs provided by Django. And we'll start with fields. Fields are the cornerstone of validation in Django that describe the data in a declarative way and contain most of the validation logic. So that logic is almost identical among fields from forms, models, and serializers, with only some small differences that I will point out as I go along. The first thing, and arguably the most important thing about a field, is its type. Each type has a corresponding data type for which it implements the validation logic. The actual type validation is performed by a method called toPython that is called during the cleaning cycle. Now, let's see the validation commonly found in a field definition. There is presence validation. There is a small inconsistency between forms that use a Boolean called required and models that use blank, which work reverse to required. But for their purpose, they're essentially the same thing. There is also bounds validation, min length, max length on a text field, min value, max value on a numeric field. There is choice validation. Form and serializers have dedicated choice fields. Models have that implemented in the base field, but it's pretty much the same. Format validations. Some fields like regex field or date field have explicit format validation. Others like slug field or email field have implied format validation. And then, of course, for models, there is uniqueness validation. So then come validators. A field can have some predefined validators declared with the default validators attribute, and it also accepts user-defined validators passed as argument to the constructor. It's worth noting that default validators is poorly named, and it should have been called required validators, because there is no way to opt out of these. DRF made default validators truly behave as default at the expense of consistency with Django. So if you supply the validators argument of a serializer field, its built-in validators will be ignored. A validator is a callable. It takes in a value and is expected to raise a validation error when it's not valid. And in its simplest form, it's just going to be a function. For example, this validate event validator. However, at times, you will want to parameterize your validators. And in that case, you can do so with a class-based validator, using the __call method. For instance, this multiple validator that takes in a base parameter. If you intend to use that validator on a model field, you need to ensure that it can be deconstructed by migrations. And that involves two steps. The first one is to add deconstructible, the class decorator, and ensure that two classes instantiated with the same parameters are equal to each other, which is actually something that we could have implemented in deconstructible. I don't know why we didn't do it. If you happen to be allergic to classes, you can use functools.partial, and you can achieve the same thing. And because migration know how to handle partials out of the box, you don't need to do anything special. And that's actually a technique that we might want to document. Once you're done enabling all the validation features of your field, you may be interested in customizing the error messages. And you can do that with the error messages argument. A field can declare a dictionary called default error messages. And the init method loops through all the base classes of that field in reverse order to collect all those error messages. And then it applies the user-supplied error messages given as argument. So for example, any subclass of field would have this required error message, plus any new one that it defines, and all of them could be overridden by the one given by the user. So now that we've declared a field, we can trigger its validation cycle, which is done by calling the field's clean method. Django REST framework serializer calls this method run validation, but it's essentially the same thing. Start by calling toPython, which is responsible to enforce the data type and performing any required conversion. Then it calls validate, which performs the presence validation by default, plus any validation that's specific to the field. And finally, it calls run validators, passing the value as argument. Run validators loop through every member of self.validators, calling them with a value as argument, and collecting all the resulting errors in an array to raise them all at once at the end. And here is where the error messages dictionary kicks in, by overriding the exceptions message if it finds an error code that is matching. Now, as a field author, why would you implement validate instead of specifying a default validator? And that's because validators don't have access to the field instance. So anything that was given to the field constructor, like required or max length, that cannot be enforced through a default validator. What can be done, though, is dynamically adding new validators to the field constructor. So the upside of validator is that it's reusable. So Django does that for most of its fields, so that the logic can be shared among models and forms. But if you don't need that reusability, validate is more straightforward and it's less verbose. Now let's talk about the other primitive that is central to Django validation, and that's the validation error class. Takes 3 arguments: message, code, and params. The message can be a simple error, a list of error, or a dictionary that maps field names to list of errors. That last example is how errors flow from the model layer to the form layers in case of model form. So an error can be a simple string or an instance of validation error that represent a single error. And when I say the list or dictionary of error, it can be an actual list or dict, or it can be an instance of validation error that represent a list or mapping of errors. So it's unlikely that you will want to declare multiple errors at once, like in this example, but instead you would build a list or a dictionary in a loop, then wrap the result in a validation error, and raise that. And we've seen that earlier in the implementation of run validators. So now let's see how this is implemented. So as you can see, the init manages either an internal dictionary called error_dict, or a list called error_list, or the attribute relevant to a single error, so message, code, and params. With the additional catch that a single error doubles as a list that contains itself. Now let's see how validation errors are commonly raised. So this has a number of issues. It's got no semantic meaning, so there is nothing clever that you can do with it other than displaying it. And even that you cannot do very well because it's not translatable. So the first thing we should do is to wrap it in getText. So even if you only care about one language, it's good to get into the habit of using getText, so that way you'll think of using it when you want to handle pluralization. So now the error has a meaning for our user. Oops, sorry. Yeah. So now the error has a meaning for our user, but it still has no meaning for the system. And we'll see why we add, and that's why we add an error code. So thanks to that error code, we can now easily recognize that error when it happens, which help to write more robust unit tests, to perform conditional logic, or to easily customize the error message. So we've already seen how field can customize error messages coming from validators, but it also works at the form level. So for example, if you're using a form from a third-party app, but you don't like the way the author wrote the messages, you can subclass it and specify new error messages. You can do that very easily and declaratively on a model form, or with a little bit of elbow grease on the regular forms. Another thing you can do to make your error more usable is to not interpolate the value into the message, but instead use the params argument. So Django built the final message using string interpolation with the %sign between the message and the params. So the last recommendation is to use a dictionary for params. That way, the message author can decide whether they want to include that parameter or if they want to leave it out from the final message. And this also enables you to pass around additional data that is not intended for display. So here is an example taken from Django unique together validation. It even includes the model instance that failed to validate. Now, do you really need to do all of that? Well, it depends. It's a must if you are writing a reusable component, like a third-party app. But if you are at the end of the chain, and you know that all you will ever want to do with that error is to display it in an HTML template, and you're not planning to writing a test for it, then you may skip providing code and params. But most of the time, you probably shouldn't skip them. All right, now let's talk about forms. The most common and explicit entry point to form validation is the isValid method, which internally will check if the form is bound and then access the errors attribute, which happen to be a property. And that property will check if validation has already run by inspecting the private _errors attribute. And if it doesn't, it will trigger the full clean method before finally returning the result. Alternatively, you can call full clean yourself, and that will start the validation process. So this is a slightly simplified full clean method. The real one has a couple of short circuits if you detect that the validation doesn't need to run. And the first thing to note is that full clean doesn't check if validation has already run. And it starts by resetting the validation state. So if you're not careful, you can run validation twice by accident, which is not so serious. But the worst case scenario is that you could lose some state. Because if the validation has already run and you modified it externally, for instance from the view, then that state will be discarded. Once the state is set, it calls the clean fields method, which iterates through all the fields, grabbing their value from the widget. Speaking of which, if you want, you can implement some validation at the widget level. Then it calls the fields clean method that we covered earlier. And then there is one additional check for fields. If there is a method called clean _ field name, it will call it. And should there be any validation error, it will catch it and pass it to the add error method, which we'll discuss in a minute. But one thing to note is that exceptions are caught within the loop, meaning that an error on a field doesn't abort the validation process, so every field is given a chance to provide feedback. Now it calls the clean form method. Clean form is a wrapper around the form's clean method, which by default doesn't do very much, it's just a stub. But that's a public API that you are expected to overload to handle validation that don't belong to one field in particular, or that relies on multiple fields, or that expect validation to happen once the field validation process is over. So this method is called even if field validation encountered errors. And because invalid fields are removed from clean data, you cannot assume that their value is available. So I'm sure you've encountered this before, where you get a key error when trying to fish out a value from clean data. And you should use a get function instead of the bracket notation, and you should handle missing values. And then there is post-clean, which by default doesn't do very much, but it's a hook that is used by model form to orchestrate model validation. So now let's talk about the add error method. It was introduced in Django 1.7, and before you had to field directly with _errors, which was far from trivial. It takes two arguments, field and error. So when an error represents a single error or list of errors, the field argument is the name of the field to which they belong. If the value is none, that will be treated as a non-field error, which are typically errors that you display at the top of the form. When error represents a dict, then the field argument is ignored. And actually, I think we have an assertion that blows up if field is anything else than none, if you provide a dictionary as an error. So we've seen earlier that the validation error constructor accepts just about anything. String, list, dict, even nested validation errors. So by wrapping the error argument with a validation error, we normalize its input. Then we turn error into a dict, either by getting the internal error dict from the validation error, or by creating a new dictionary with the field name as a key and the error list as value. And then we check if an error class already exists for that field. Error class is a list-like container for errors. So if the field doesn't have one yet, we instantiate a new one, and then we add the errors to it. And last but not least, we remove any invalid value from clean data. So prior to Django 1.7, you were expected to do all of that every time you wanted to manually add an error. And to this effect, we had almost 400 words of documentation to explain all the inner working of underscore errors and how to get this process right. But now, underscore error is a private API, and you don't need to worry about any of that. So when we introduced add error, a few people wondered if that replaced the pattern of raising a validation error. And well, there are places like validators where you don't have access to the form instance, so you cannot do that anyway. But there are places like clean underscore field name methods where you have both options and they work equally well. But I personally prefer to raise a validation error because it's less verbose, and it's less verbose because you don't need to specify the field. Django will be able to get it from the context, but it's just a matter of taste. Now let's take a minute to talk about the classes that make up that underscore errors attribute. First, error dict. It's a private API, so the class itself is private, but its methods are public. There is asUL and asText, which are the historical renderer, and asData and asJSON that were added in Django 1.7. So asData lets you retrieve the original instance of validation error, and asJSON, which obviously render them in the JSON format. Error dict maps fields to instances of error list. So let's see what an error list is. It used to be a simple subclass of list that added the asUL and asText methods. And to that list, we added the already interpolated error message. So that meant that as soon as the validation error made it into underscore errors, all the metadata about that error was lost. So in Django 1.7, we refactored it so that it could store the validation error instances in a backwards compatible way. And to do that, we inherited from Python's user list, which is a class that quacks like a list while maintaining its own internal list called data. And that lets you proxy any access to that internal list. So thanks to a bunch of magic methods, we could expose the interpolated message to the outside world while storing the original validation errors. So now that we still had to inherit from list for backwards compatibility, because some people reported that we broke the tests due to failing is-instance checks. So I don't know why anyone would do that in their test, but apparently some people do. So now, thanks to validation error being around, we were able to implement asJSON, which include the error message and the error code. At first, we also exposed params in the resulting JSON, but we decided to remove it for a couple of reasons. First, we cannot be sure that the values in params are JSON serializable. And then we were worried that people would accidentally expose more info than they were comfortable with. Also, since you can supply your own error list to a form through the error class argument, that's public API, we thought it would be trivial for anyone who needs it to overload gadgets on that data and add it back. Now, thanks to that refactor, we were able to implement the asError function that lets you check whether a given error has happened. And if you don't specify an error code, it will just tell you whether the form is the field is valid or not. So all in all, I'm pretty happy of the outcome of this refactor, but I do have some regrets. asData is a bit of a clunky API. It would have been a lot better if form.errors simply returned the list of validation errors. But the problem is that for that change to be backwards compatible, a validation error needed to automatically interpolate and return the error message when used as a string. But unfortunately, Django had already all the plans for the validation error string dunder method. It renders even a single error as a representation of a list of errors, which in itself is pretty useless. And it would be pretty trivial to fix that, except that when you do it, Django's own test suite has over 50 failing tests. So it's fair to assume that we would have broken thousands of tests in people's project. So yeah, I decided to stay away from it for once. So Django could have a nice validation API if people actually used the error code in tests. All right, let's talk about model validation. So it's very much inspired from form validation, to the point that even the release note said so. But there are a couple of differences. First, there is no isValid method. So if you want to check if a model is valid, you call the full clean method directly, and then you have to catch validation errors. You can exclude some fields from validations, whereas form validation is all or nothing. And models don't have an internal validation state. So where forms have an internal errors dictionary, the model's full clean consolidate errors in a local variable and raise that at the end. Where forms store validated data into a clean data dictionary, model validation directly manipulates the model instance. So just like form validation, the first step is to validate all the fields with the clean field method, which for some reason is a public API, where the form equivalent is private. Then just like forms, the clean method is called, even if some of the individual fields failed validation. And it's no-op by default. Then there is a final step to validate all the unique constraints. That includes unique together, and all the unique for date. So the date-based, unique for date, unique for months, unique for year. Speaking of unique for date, it's a prime example of something that you should enforce as a database with a constraint, if you can. So here is a unique for date implemented with a Postgres constraint. Unique for months is a little bit more work. And if you replace months by year, you get unique for year. So one thing to note is that any field that already failed validation is excluded from uniqueness validation, including all the unique together they play a part in. And that's pretty much it for model validation. So now model form, which is really the glue between the form and the model validation, and all of which is implemented in the post-clean method, so after all the form validation logic has already run. So the first step is to construct a model instance. Then it builds a list of fields that should be excluded from model validation. This includes fields that are not on the form, so model fields that are not on the form, any field that failed validation, and fields that were declared on the form but are either missing from meta.fields or excluded through meta.exclude. Then it calls the model's full clean method with uniqueness validation turned off. Update errors is a wrapper around add error that tries to override any error message coming from the model with those defined at the form level. So that's yet another place where error code will be useful. Validate unique simply calls the equivalent function on the model and catches its exceptions. That underscore validate unique attribute is actually a backwards compatibility artifact, which can easily trip you up because it's set to true in the default implementation of modelForm.clean, which is the only one that is not no-op. So if you forget to call super when overloading that method, then all your uniqueness validation is gone. And that's it for model validation. So now that we covered the various APIs, can we answer the question, where should you implement validation in your Django project? And my take is that when it comes to validation, the best approach is a layered one. So validate on the front end, if you can afford it. validating the database for anything mission critical. And in between, you just have to pick your poison, because at least currently there is no perfect solution in Django. So now I'm going to drift away a little bit from the topic of validation, but I think Django REST framework did something right with serializers and the surrounding concept of parsers and renderers. And I believe we should consider something like this in Django core. It improved over Django forms, which always had that weird duality of being both a model-like object that can handle data and a view-like object that can output HTML, but not being particularly great at either task. And it also improved over Django models by not being tied to the database. I often hear people advocating for the concept of fat models, and I completely agree that those are great. But very often, Django models cannot be those fat models for the simple reason that they are tied to a single database table, which is way too limiting. So, to me, the way a database is modeled is an implementation detail. Whether something requires one table or multiple tables, whether a database is needed at all, those are all implementation details. And I view my Django models just as a Pythonic version of the database. And therefore, I see the need for something that sits on top of them to act as a greater model. Of course, for the simple cases, if you already have a Django model, it's possible to generate that greater model from it. But at any time, you can cut the link and let it have a life of its own, independent from a specific database table. And now, once you have that greater model, it doesn't matter whether it's processing data from HTML forms, from an admin interface, from an API, or from a script. It would finally be in a position to enforce all the validation logic all the time. Thank you.
Thank you very much, Loic. So we've got a whole bunch of questions. I will admit now this is a topic that I'm particularly keen on and could probably talk to Loic for about, in fact, have talked to Loic for many, many hours about, so I'll try to not talk too much. Let's start off with some sort of detail questions. How can Django kind of improve to deal with some non-trivial validation, situations where this field has to be required if this field is required? There are common patterns that show up. An example would be you've got a state drop down and a country drop down, and the state's got to be in the country that you're choosing. Do you think we should have some more generic systems to handle that?
I think that would be very, very hard to abstract away. I think the current way right now, where you have a clean method that has access to the current validation state, is probably enough. All the conditional, you can just write code for it, I think.
Is there a way to return, or do you think there should be a way to return multiple errors for an individual field?
You can do that already. So if you are validating a field and you're raising a validation error that contains a list, they will all apply. And if you're in the clean underscore field name method and you call add error multiple times, they will all apply as well.
So the validation errors in the clean methods, they kind of have a bit of a mixed purpose. They do a level of coercion and a level of validation, and sometimes you have to do some coercion to validate it, and sometimes you have to do some validation to coerce it, and sometimes you need a bit of a string of it. Do you think that we've got the right design there, or could those things be separated out?
I mean, enforcement of the type and validation?
Well, it's sometimes like you might coerce it to a particular...
Yeah.
You receive a string and you coerce it to a native Python object, but you validate that the string, you can coerce it, and then once you've got that native Python object, like a model instance, for example, you might then check that that model instance is valid for the ones that for the particular rules you've got, and you can kind of get into a cycle of these where you're flipping between the various places.
I think the current design is not bad, with 2 Python to do the coercion, and given also a chance to modify the data, and then validators, I think, work really well. but then shouldn't be allowed to modify the data. So I think that works. Maybe having this field.validate in between those two tasks, maybe that's something we could remove. But yeah, no, I think coercion and validation are two separate concerns.
Slightly brutal question. Is there any reason to use model validation?
Well, the one reason to use it is that it can apply everywhere if you do the right thing. I think it's Josh was mentioning the other day that
It's Josh's question.
Fair enough. No, he went pretty extreme there. He implemented his validation in the model fields. So making a custom field, doing the validation there to ensure that there were absolutely no way to opt out of it. Right. And yeah, even migration won't be able to bypass that. So it's pretty efficient.
I think this is one of those questions because I've asked that question to various members of the core team and got different answers depending on who you speak to. So a couple of questions about sort of mirroring in both directions. So we have this, wherever your validation level sits, whether it's in the model or the form, and we'll leave that discussion for now. How do you think there should be more tools for mirroring down to the database? Could Django implement like an expression API for check constraints?
So we should, as soon as we, it's just a matter of doing it now. All the building blocks are already there, so we just have to put it together. But that's also something that you want to, like the user has to declare themselves on their model. It's not something that we should try to enforce automatically, yeah.
Yeah. And sort of going in the opposite direction, do you have any strategies? I mean, there are some packages that try and do it to sort of mirror your validation from your Django form to the front end. So
we already do some of that, right? With HTML output, now we added the required attribute. So that's, we could go all the way and support every single attribute from the HTML5 specs. There might be some backwards compatibility issue there as well. I know, like Baptiste was complaining the other day about required that's now enabled by default. So the same would apply to all the other ones. But yeah, I think we can go a little bit further by making it optional, but at least just having a flag to set, and then all that model, all that front-end validation is enabled by default.
I mean, if you want to go really crazy down these ideas, then you start looking at Batavia and porting your custom validator logic and running that on the front end. And
yeah, so, all right.
That's going a bit mental, maybe.
I don't think it's mental, but... so Batavia would allow you to do, to port your Python code, right? But what I find is that it's not really a matter of languages most of the time. If you're implementing a project in Node.js and you also want front-end validation, maybe it's going to be through Angular, you won't be able to reuse that code. You will not write that code the same way. The way you will access data will be different. So if even within the same language you can't really reuse your validation logic, then being able to just transpile your Python to JavaScript is not going to help.
So it's fine. Like if you're just dealing with an integer, it's fairly straightforward. But as soon as you've got the coercion logic in place, you need to run that coercion logic to make the validation work, and you don't have that on the front end. So,
and there's also like validation that you can do at the front end level, like all those type enforcement and all of those. But you cannot do uniqueness validation on the front end. You need the back end to talk to the database.
Not without quite a lot of work and an Ajax call.
Yeah.
Should we? So there are. I'm going to be careful here. You have a history of backwards incompatibilities in Django. There are a number of people who are suggesting that you make some bigger ones. For example, should full clean on model save be on all the time? Like, in your opinion, would you want to do
that? We need to have a pattern where that full clean method is always called. But to add full clean now to the model is just too late. So, yeah, no.
And with regards to all of the validation error and error dict and all those kind of things that, yes, it's going to break 50 tests in Django's test suite and so on.
So this one...
Do you think that one's worth making?
Yeah, this one in particular, I think it was worth doing it. It would be worth doing it. But yeah, at the time, my patch wouldn't have been accepted, I think, if it broke that many tests. So.
No, it wouldn't.
but I think now that if you look at the design, this as data, that's the result of not being able to do that change is really clunky. So if we do, so like, for instance, serializers from Django REST framework don't have all this clunkiness.
Yep.
And yeah.
And they have an advantage of having been created in a more data-specific, data-y world rather than a very HTML world. And Django's forms have some sort of warts that came from where it was originally written.
Yeah. One issue they had, though, is that validation error didn't have an error code until 2 weeks ago. So I'm glad to see that landed.
When you're building your forms or building your validation logic, are there any ways to sort of avoid your duplication if you're not just using a stock model form to sort of, I've got a form that it needs to talk to these models and these fields of this model and this field of this model, it's all in one form. How can I pull that validation logic, sort of infer that validation logic from the models?
So one form, multiple models, and you just have to iterate over them and yeah.
Do a lot
query,
of internal inspection of the fields?
Well, you can just run full clean on them, and it will tell you about any validation error due to uniqueness violations.
Yep. I suppose that works for that sense, but if you don't introspect it, then you're not going to get the max and min values and the data attributes you're going to write into your form, because you can only run full clean once you've got the data. I think the answer to this question is it's not easy.
There's a bit of manual work involved, yeah.
Yeah, the internals of model form that do that for an individual model aren't well exposed.
I think they're reasonably well exposed.
They're certainly not documented.
They're not documented, that's right, yeah. No, but I mean, they're pretty, how to put it, the argument is documented, right? The argument to the init method is documented, and pretty much every single time, that's just added to self.
Yeah. So this is where we then get into almost like creating models on the fly rather than hard coding them. Have you got any tips about how to do this? Where a certain field is required for, I'm an admin, therefore I can see this particular field. I'm not an admin, therefore I can't see it. That kind of situation. So
that's where I think this concept of a grader model, or basically what DRF does with serializers, by sitting on top of them, gives you this opportunity of having one flavor for admin, one flavor for normal users, for instance.
So then you can kind of use subclassing or something to get all the various different variants of it. Yeah. And sometimes you actually need to build these a little bit more at runtime. So I guess you can use a type, or you can use the init method, or none of these are very nice.
I'm not a big fan of generating them, on the fly. If you're building an admin, you don't have a choice. For user code, most of the time, you can get away with just having, multiple implementation that are more explicit and just dynamically picking the winner, basically.
Cool. So we'll wrap up there. I'm going to have some lunch because I'm hungry. So thank you very much, Loic.
Thank you. Thank you. Thank you.
Something for you.
Thanks.
Okay, so when you go outside for lunch, if you go to the right, you will find soup. And if you go to the left, you'll find sandwiches, or possibly the other way around. If you can't find one way or the other, I've forgotten. If you can't find food that works for you, please ask at the bar, and they will, if you've got special dietary requirements, they will be able to find you food. Please don't go hungry. And I will see you all in an hour. Hello, everyone. Hi, we're back again. Hope everyone enjoyed lunch. So in this session, we're going to start with a talk about JavaScript. Yay! Now, there's a reason why I had this talk on the schedule. I've had a number of conversations with many experienced Django people, particular several core contributors, which pretty much go, here's some JavaScript. Ugh. Some level of fear or disgust or something happens. In particular, finding people to review a patch for some JavaScript in the admin can be quite a challenge. And I'm one of these people who professes to know a bit about JavaScript. I write JavaScript in my day-to-day life as well as Python at work. And it's not as bad as you all think it is. So here to give you a more complete version of that is Idan.
Technology, will it work?
It's slow, you get it.
Hi. You kind of stole my opening monologue, but that's okay. I forgive you. So last spring I had the great fortune and pleasure of attending DjangoCon Europe. And it was my first DjangoCon in a while. I kind of dropped off the map. I've been writing a lot of JavaScript as my day job for the last year and a half, and not much Django at all. The talks were fantastic, but here and there I heard the sentiment of like JavaScript, right? Not so much in a derogatory fashion, right? It wasn't something like, oh, JavaScript is stupid. No, nobody was saying that. But this attitude that JavaScript is painful, that it's complex. Haha, JavaScript is hard, let's go shopping, right? And of course, hiding inside that sentiment is a deeper one, and one that I felt like I shared not too long ago. I love Python. It's comfortable, like warm, fuzzy slippers, so clean, so thoughtful. I'd brace myself like every time I had to dive into some JavaScript and hope that I didn't make too much of a mess along the way. And then bit by bit, I was forced to become comfortable with it and find the ways to make JavaScript feel like home. So my name is Idan, and I work on data at Heroku, mostly in JavaScript nowadays, even though the Python and Django community still feel like home to me. Like, coming back here feels like visiting my family. I love you all. Historically, most teams at Heroku are it's a Ruby shop, largely. So I convinced my team to meet me in the middle instead of doing Ruby, I got to do some JavaScript. Okay. So while my team isn't using a whole lot of Python, there actually is, by the way, an open position on a team that is explicitly a Python and Django gig, and they're super remote friendly, and they paid to send me here, so thank you, Heroku. And if you'd like to work somewhere that does that kind of thing, then reach out to me later. So today I want to talk with you about modern JavaScript. And by modern JavaScript, I mean JavaScript that's less messy, less confusing, less intimidating, a kinder, friendlier JavaScript. When I first started working with JavaScript, it struck me how much cognitive overhead it seemed like it added to my life. I longed for this feeling that I had when writing Python, this legibility, this practical beauty of the libraries and thought given to APIs, a culture of documentation, which I still really miss. JavaScript felt like a disjointed mess, right? I had all this visual noise cluttering up my text editor and distracting my eyes, and this unintuitively strange alternative to classical object-oriented inheritance. I missed syntactic sugar for common operations, like no list comprehensions. I found myself writing for loops like a caveman. Of course, JavaScript's infamous strength/weakness, which is asynchrony. And it lends itself to this highly nested, hard to read callback style. So there's a lot of reasons why JavaScript feels foreign and scary when you're coming from Python. And I haven't even touched on the cultural and ecosystem aspect yet. And there's just no escaping the fact that every browser ships with a JavaScript interpreter, right? Outside of some very clever work from tall, unnamed, prolific, bearded Australian core developers with a PhD. There's no way to run Python in a browser. Like, we call ourselves enlightened creators for the web, but how can we ignore the only runtime that ships with every browser? Like, we had this nice period of being able to largely ignore JavaScript outside of optional enhancements to making our forms look pretty. But I think it's a mistake to treat JavaScript as something to be avoided or laughed at or otherwise scared of in 2016. So like it or not, JavaScript the language and JavaScript the environment is something we're stuck with all of the warts that came from being designed in essentially 10 days. And all of the inertia that comes from having a huge install base of interpreters across browsers and servers and platforms. Let's leave us with two questions. First, how did we get to this current state of affairs, right? Not in a dry history sense, more understanding which pain points people care about, which will help put the solutions into context. And secondly, what's the current lay of the land when it comes to JavaScript? At the end of this, if you aren't already familiar with the current state of affairs in JavaScript, my hope is that you'll stop drawing dragons on that part of the map and feel like you have a sense for what's happening over there today and where it's headed. I'm not going to dive super deep on any projects. I'm not going to try and convince you that Framework A is the one you should use and it's better than Framework B. I'm not going to touch on how to integrate Django with front-end apps or anything in that direction. I will inject some of my own opinions and observations here and there based on my experience, but don't treat it as gospel. There's more than one way to JavaScript, so let's dive in. Once upon a time, when the grass was still green and the air was still clean, we all enhanced our forms with fancy JavaScript validation errors and maybe made some stuff move around on the page. I think Andrew said something about snow falling during Christmas time. There was one JavaScript, kind of. Roughly the same limited set of APIs were supported here, there, and everywhere. And then in a bid to massively improve the performance of JavaScript, Google built and opened V8, their JavaScript engine, for their super fast new browser, Chrome. Node is just V8 untethered to a browser with a standard library of stuff for doing things that don't usually happen in browsers, like file system access and other kinds of IOE things. So in a moment of inebriated glee, I considered titling this talk in a fashion that acknowledges the dual nature of JavaScript, but yeah, that's not a good idea. And it's even if I did, it'd still be a lie, because it's not even true that there's two JavaScripts. It's really like there's a dozen, because there's different JavaScript engines, right? Browser side, we've got the 4 major browsers, and Node side, there's Node. Packaging in browser land is also something that differs between the browser side and the Node side. Packaging in browser land used to be non-existent, leaving you to figure out how to deliver your code to your clients. Tools like Bower came and went as a registry for downloading front-end JavaScript libraries like jQuery or Backbone, but they left the dirty work of actually bundling them up and delivering them as static assets entirely on our shoulders. We had to figure out how to do that and put it in the right place and minify it and all this other stuff. On Node side, there's npm's registry. Unlike pip and PyPI, both the service and the CLI are named npm. More on this in a bit. And finally, there's the matter of stitching modular code together. In JavaScript, the browser has no concept of modules. There is no such thing, just an HTML page which includes one or more script tags, and those scripts can include more scripts, so you can have scriptception. Each tag can have its way with the global namespace. Literally, any script that you include can do whatever it wants. There's no isolation whatsoever. And people wrote a kind of client-side module system, actually a few of them, to make this process a little more formalized, but it always felt a little bit like a grafted-on solution. I'm talking about require.js. Node has a very basic module system, so you can modularize your code and import files into each other, but that's about it. And outside of the language itself, there isn't really much in common between browser JavaScript and server JavaScript. The language part that both browsers and Node had in common for a long, long time was ECMAScript version 5. ECMA is the European Computer Manufacturers Association, I think. Whatever, it's a standards body. And JavaScript is officially ECMAScript as far as the standards process is called. So for a long, long time, ECMAScript version 5 was the one that reigned supreme. It was published in 2009. So you can think of it as kind of the equivalent of Python 2. It's well supported, all the different browser engines and all the different backend engines that they all support ECMAScript 5 pretty much the same and fairly well. And nobody wanted to do anything about this for a long time because any changes would have to be made in like 15 different engines, and that's painful. But eventually the desire to improve the language won out over inertia. And the standards bodies kicked off version 6 of ECMAScript. It added a small amount of new features and a huge amount of syntactic sugar. And this version alone is responsible for many of the things that make JavaScript a much friendlier place to write code today. This full list is huge, so suffice it to say that this represented an even more dramatic upgrade to the language than Python 3 was for Python. This was finalized in 2015, so 6 years went by between ECMAScript 5 and ECMAScript 6. Unlike Python 3, ES6 was entirely additive, breaking nothing about older JavaScript. You could opt to use the new bells and whistles, but existing ES5 compatible JavaScript will continue to work in any engine that does ES6 as well. And thankfully, it wasn't like a one-shot and now we're gone for 6 years again. The standards body was like, you know what, 6 years was way too long for us to take between versions. We're going to do an annual release cycle. ES6 officially became known as ES 2015 when it was ratified. ES7 became ES 2016. ES8 is the proverbial ES next. It's the one that's coming up next always. And the standards process looks like this. There's different stages. You make proposals. This is the equivalent to the PEP process from Python or DEPS from Django. It's fairly transparent, happens largely on GitHub. You can see all the features that are in flight at this GitHub URL. Everything starts at stage 0, and as it proceeds to stage 4, anything that's in stage 4 when the year ends is part of the next version of JavaScript. This is the compatibility table. My apologies if you're colorblind. How many people in the room are red-green colorblind? I'm sorry, there was nothing I could do for you. It's like, this isn't my table, I didn't build it, it's not my image, so you'll have to take my word for it. Can I like mouse with my thing? Can I see my mouse? No, I can't. Oh well, I should have thought to get a laser pointer. Too late for that. So there's this, here we go, I can do this. There's this big green stripe right here. This represents late model browsers, right? Like late model Firefox, late model Chrome, whereas IE Edge, this is Edge right here. Okay, so this is like the safe space for ES6, right? The thing that was released in 2015. And then over here, this green stripe is late model Node, late model server-side JavaScript. ES6 is fairly well supported. Almost everything in these columns are green or very green or mostly green or just some flavor of green. Anything that is not in those columns ends up being a very mixed bag. So you can actually use all of this cool stuff. It's well supported all over the place. Like it's not this bleeding edge thing that you need to be scared of. You can actually go ahead and do stuff with it. If your targets include older browsers, then well, like you're shit out of luck. There's nothing that I can do about that part. Maybe. The picture is even less rosy for like the newer stuff, ES 2016 and 2017. It's still very much like a work in progress. It takes time for all the vendors to implement the stuff, but it gets better. And now that there's a release process that happens annually, everybody's sort of trying to hew to that schedule and try to like catch up to it. This is a good thing. This is exerting like downward pressure on all of the browser vendors. Fortunately, there's a project called Babel, which is a modular compiler, or technically a transpiler. I don't know if that's actually a word or if that's something the internet made up, but it targets ES5 and it has support for all of ES 2016. So you can optionally turn on transforms for each of the ES stages. Remember I said there's stage 0, 1, 2, 3, 4. You can actually turn on and be like, I would like all the features that are currently stage 2. And Babel will take those features and it will compile it down to a version of JavaScript that everybody can run. And if this sounds scary, remember that most of JavaScript's new features basically amount to syntactic sugar. And the ones that aren't can be simulated in all kinds of different ways. And it's pretty cool. You can actually read the output. It's not perfect. It looks a little bit like unobfuscated or unminified code when you read the output of Babel, but it's not completely opaque. You can actually read the code and understand what it does. So it's not that bad. So on the web, there's this term polyfill, to using like a bit of JavaScript to retrofit new functionality onto browsers that lack them. But this approach, Babel, kind of flips the model on its head. As time marches on and more of these compatibility tables turn green, you can switch off the parts of Babel that you don't need. Basically, you're compiling future JavaScript into current JavaScript. Babel isn't the only one in this category. Google also released a transpiler called, I'm probably going to say this wrong, Tresser, I'm not sure. Seems French. There's a Babel for CSS called PostCSS. So this sort of model is spreading to other places, like tomorrow's X today. So this isn't about transforming another language into JavaScript, like CoffeeScript or Google's Dart or Elm. It's really just about future JavaScript and getting it right now. So I like to call these polyfeatures. If the internet made up polyfills, then I made up polyfeatures, and I figure that's probably valid. Either way, Babel is rock solid. I've been using it in production for the last couple of years. And I get to use all of the cool shiny toys worry-free. Even the stage 0 transforms are fine to use, right? They're also fairly solid, with the caveat that if you're going to build on stage 0 features or stage 1, the earlier stage features, that those features might change out from underneath you at some point, and you'll have to rewrite some of your code to accommodate those changes. But the actual transforms that Babel ships are actually fairly stable. It isn't like, oh, it doesn't really work all the time. It works fine for the current version of what this idea looks like. This also kind of renders the question of JavaScript engines moot, because the output from Babel is ES5, which everybody speaks. So, let's talk a little bit about JavaScript, the syntax, all these cool features that I keep alluding to. What are they? What is it that makes modern JavaScript feel nice and fun and easy to code in? So, modules. Right? Anybody who's ever required a module in JavaScript that looks like, require. New Shiny reminds you of any other languages. Looks an awful lot like Python. It's still path-based in JavaScript. Like, there isn't this layer of indirection of Python path with like the dotted path name thing. No, it's actually you need to supply a valid path, and you can do things like, // to go up a directory and things like that. But at the end of the day, the engine is looking for things like, if I ask it for libmath, it's going to try and find a file called math.js inside a folder called lib that is relative to where I'm currently in terms of execution. There's one catch. You can't use import statements anywhere except the top of your file. If you need to conditionally import something, you still have to use require. This is actually, I just opened up some random file from a project and ripped out the header blocks. This is what it looks like in practice, and it doesn't actually look that bad. It doesn't I don't feel like my eyes are bleeding just from reading this code. So it's okay. Server-side, all of your installed packages are still directly accessible by name, so the stuff that's in the first block are things that I installed and have globally available to my project. Destructuring works a little bit differently compared to Python. For arrays, you won't get any errors if there's a mismatch in the length. So pay attention to that. It'll just give you undefined for things that are missing. Or it'll attach the relevant ones like this A equals 1, B equals 3 thing, and it'll literally skip over if you give it an extra comma. But there's a cool thing, you can destructure objects. Basically, you can think of it like dictionary destructuring, which Python doesn't have. So I wish Python had it. This is actually a pretty cool feature. I like this. Default arguments, something that we take for granted until you don't have them anymore, and then you're very sad. So now JavaScript has this as well. Template strings in JavaScript bring cleaner string construction. It's still relatively, there isn't the whole string formatting thing, particularly like Python 2.7 and up. is pretty nice. Here it's literally just you can put whatever expression you want inside this dollar curly parens. It also lets you do multi-line strings, so this backtick string format for interpolated strings is like triple quotes in Python. You can actually do this across lines. Inheritance. Who here feels like they really understand prototypal inheritance? You want to come on stage and explain it? Prototypal inheritance is like a really strange animal, especially when you're coming from a lifetime of object-oriented classical OO design. You write a function that talks about this and doesn't seem to return anything. And then you set some properties on the function, and then you invoke it all with this magical new keyword. This is way confusing, and I still, every time I run into something, I'm like, oh wait, does it work that way? And I run for the docs, and then I feel stupid, and I don't like having that experience. So this is actually the exact equivalent of the previous slide with a little less magic, but it's still the old sort of approach. But I find like this makes a lot more sense to me in terms of what the prototype is. Here, car is the prototype, and my car, you know, if you think of passing arguments to a constructor, it's just setting that property on top of things. And it explicitly points at its prototype with the magic under proto. And then when you invoke a method on that object, if it's not on that object, it'll walk up the prototype chain to find the first one that has a method like that. And that's prototypal inheritance in a nutshell. So great, that's nice. But new JavaScript has this sugary syntax for classes. And this is exactly the same thing again. And it works exactly how you expect. And the syntax is a lot easier to read. So no longer do you need to suffer with this whole prototype thing. But under the hood, it still functions exactly the same. We could be here until tomorrow covering a long list of cool stuff in ES 2015 and forward, but suffice it to say that from a strict language perspective, it's a whole different ballgame. It's really actually quite nice. It's somewhat irritating that some of the things don't have the same names as like the ones in Python, for example, like these convenience things like includes and entries and whatever they don't. So when I go back to Python or I actually write some Python once in a while, I get tripped up because I use the wrong method names. So yeah, that kind of sucks, but it's still nice, it's convenient. However, there are a bunch of features that aren't just syntactic sugar. Arrow functions are one of the big ones. So who here knows what this means in JavaScript? Also, a few people that might want to join me on stage. So there's 5 rules for this, but it boils down to who is asking for this? What's doing the invoking? This is very much a function of where it's being invoked. So one of the easiest bugs to write in JavaScript is thinking that this is the same this as the surrounding code that you see on the screen, which is not true. It might not be, depending on who's doing the calling, and that's a really shitty experience. So this matters a lot with callbacks, and there's a lot of callbacks, therefore it matters a lot in JavaScript. Because the invoker isn't under your control. Okay, here we have 2 code blocks, right? Set timeout is going to invoke this say name callback, right? 100 milliseconds later, right? Any guesses as to what each will say? I'm gonna give the core dev section here a collective like thumbs up for correctly inferring what this actually prints. The top one will print undefined because it's not the same this as the this that's around the this. And if you think that statement is messy, it's like that's JavaScript. But the bottom one with arrow functions, it supports a lexical this, meaning the code that you see on your screen right around it, the context that it had at the moment that you use the arrow function, that's the one that's captured and used for the arrow function. So this is a huge upgrade to your ability to understand the code that you're reading on the screen. If you see an arrow function, you know that the this that's inside it is the same this that's outside it. So this is like a huge upgrade. But it's not just for the sort of this legibility things. It's also nice purely because it's briefer. I don't need to use the function keyword, and in many cases, I don't even need to use the return keyword. And technically, I could do away with the parens as well. So long as you have an expression on the right side, you don't need to even say that it's returning something. It's just whatever is the value of that expression is the implied return value. So this is way useful in a lot of places, namely anywhere you would think of using a lambda. You want just a short little piece of code. This is a great way to express that with the terseness and brevity of a lambda. And it has some very particular applications in asynchrony. ES 2015 brings some legit changes to make asynchrony less painful. So this is the style idiomatic of JavaScript, right? This whole callback style. And if you look at Node's standard library, it's full of these kinds of functions. If I've got something asynchronous, I need to pass it some callback, and when it's done doing the asynchronous thing, it'll invoke that callback by convention. First, with the callback's signature needs to be error, then result. So when it's done doing its thing, if it's successful, it'll invoke the callback with null and the result, and if there's an error, then it'll invoke it with the error and null. And then you're stuck with this weird idiom where when you need to handle this thing, you need to write this if error, then handle the error, otherwise do the thing that you want to do, and you have to do this over 19 levels of nesting. So very rapidly it starts being illegible. And the fact that JavaScript mostly uses 2 spaces for indentation doesn't make up for this. This sucks for readability. So enter promises. Promises are great. At their most basic level, a promise is something to which you can attach as many callbacks as you like. Already, this is more legible than the whole if, error, then pattern. But the real power of promises is that you can keep attaching callbacks, as many as you like. If you want to centralize your error handling, no problem. Wrap your async work in a promise and hand that promise to your global error handler. That'll work just fine. And behind the scenes, promises are kind of a tamper-proof state machine, right? Promises are born unresolved. You don't yet know if they represent success or they represent failure. Promises which represent a success are called fulfilled, and the ones that are failures are rejected. Either way, once a promise is fulfilled or rejected, it's considered resolved, and it's locked into that state forever. You can't walk back from a resolved promise. Once a promise is resolved, that's it. So returning to our earlier example, at the moment that we're doing this catch, we don't need to know if the promise is resolved. It'll execute when the promise rejects, or it'll execute immediately if the promise already rejected. So you don't need to think as hard about what's going to be the state at the moment in time when this code is going to be running, and do I need to add more stuff to wait for the result? So yeah, that's the promise part of promises. Promises to call the thens upon fulfillment and the catches upon rejection. Doesn't matter where they are, doesn't matter when you attach them. So that's pretty nice. But that's not the only cool stuff you can do with promises. You can also chain them together. So each then can return a promise of its own. But there's a shortcut where if you return just a plain value from a then it's like returning a fulfilled promise. And if you throw an exception inside of then it's like a rejected promise. So the following then is executed immediately with the output of the previous then. And in fact, if all you're doing is calling some function that takes the result as a sole argument, then you don't even need much of the setup. You can just give it the function name. If you have some functions you wrote somewhere else and they take a value and they return a value, you can just give that to the then. You don't need to write another function there to handle it. So extra brevity. But what happens if an error gets thrown in one of these thens, right? Each one of these thens represents effectively another promise. Well, then it'll skip right over all of the subsequent thens and find the first catch it can find, and that's the one that it's going to invoke. Make sure to put a catch at the end of any of your promise chains, because if not, you will be silently swallowing errors. I've discovered this in production. That was not fun. But otherwise, this construct makes it much, much easier to think about all of the asynchronous things that are going on and how do I make a chain of them and do I need to think about when they're ready. So it's great, and the code does read better. But we're still responsible for creating and using these promise chains. Just like in async I/O, there's also async await coming down. I think it's currently stage 4, which means in theory next year we should have it in JavaScript proper. None of the browser engines support it well, except for I think like the Firefox nightlies or something like that. This is another form of syntactic sugar that leverages promises. Any function that you mark async must return a promise. And you can await anything that returns a promise, but instead of setting up a chain of handlers, you can use try-catch like you did in the good old synchronous days. You can only use await inside async functions, but when you do, your code looks almost linear. You don't need to think about the asynchrony. So this is actually pretty nice. So the core language itself is a lot better, but a lot of what makes JavaScript a nicer environment today compared to years past is the strides made on the tooling front. I've managed to get like 60 slides in before mentioning the elephant in the room, which is the dizzying variety of tooling and rate at which the tooling turns over. In the last year, there have been a number of funny, haha, but not really funny blog posts. JavaScript fatigue was one of them. How it feels to learn JavaScript in 2016 was another. Both are worthwhile reads. And there's some truth couched in the satire. It does suck that this is changing so rapidly. The crux of it is that the rate of change is mind-blowing, right? Week to week, the list of what you should be using changes. And the best practices from a few months ago are scorned as out of date. This is certainly my least favorite aspect of JavaScript, but it's important to put it into perspective. This is a younger, less mature community, but they're so excited that they're producing a prolific amount of code. And this is not something that we should say like, oh, that's terrible. This is something that we should say like, oh, that's amazing. All these people are pouring their heart and soul into something that it's making it go so fast that like the wheels are coming off of the bus. So yesterday, Andrew said that it takes a lot of tries to get a good API. I think that we have front row seats to that process with JavaScript. A lot of the stuff that's going on now are like refinements and patching all these weird edge cases in the language to make it a less hostile environment. None of that means that you must be constantly using the latest and greatest. Hacker News mentioning some project does not create a moral imperative for you to go and download and use that piece of software. Wait, let it bake for a little first. You don't need to be playing with the latest and greatest the day that it's released. And particularly in production contexts, every time you need to do NPM upgrades and updating your stuff can be painful. But you know what? You don't need to do it every day. Otherwise, you're going to spend every day on the upgrade treadmill. So schedule them a week apart. Schedule them a month apart. That's actually the solution that we settled on in our team. We literally have one day marked on every month. That's the NPM upgrade day. And it takes pretty much that long to actually go through the process of upgrading all the packages and finding all the things that aren't supposed to be broken but are. Yeah. This explosion is largely expressed right in this huge amount of packages on NPM. Some of these packages are tiny, doing one thing in like a handful of lines of code. JavaScript embraces extreme modularity as kind of a core value, which is a little weird to me, but okay, like different strokes for different folks. It's taking the Unix philosophy to its logical extreme, and once I sort of thought of it that way, I said, oh, okay, I can sort of see where that's coming from. It has its upsides, but the critique is that now you need to stitch together like 15 things in order to do the most basic task. Not to hate on Flask at all, but it feels in some ways a little bit like Flask versus Django, right? When I look at Flask, the first thing I need to do is install like 3 or 4 things to get Flask to do the stuff that Django's battery included sort of philosophy already took care of for me. So yeah, less batteries included and more like look at our humongous battery store. Ostensibly, all of this is made possible by semantic versioning, which is universally followed in the Node community. This is actually a point for them. They settled on this as like the scheme. Everybody uses it. It's pretty nice. Major version bumps indicate breaking changes. Minor and patch do not. In theory. In theory, this should make dependency upgrades easy, right? You know, if you avoid major version bumps, everything should continue to work, but it doesn't. I've been burned over and over again by minor version bumps breaking things, and this is because developers are human. We make changes to our code, and we can't always foresee exactly what those changes will affect. And the people on the other end of the wire are, you know, just like me. So I understand why it happens, but so far, the only strategy that I found is simply to do it less often, and then I will spend less time fixing it. Like, I can skip over a couple of point releases, and nothing is bad. Unless they have security issues, and then I unfortunately have to pay that tax over and over again. And there's the downsides of modular everything. Last March, there was a developer who rage quit the ecosystem and deleted all of his packages from NPM because of a legal tussle with a corporation. And among them was I kid you not, an 11-line module whose sole function in life was to left pad strings. Everybody heard about the left pad debacle? Yes. This is it. Like, these 11 lines broke the internet. The problem was that a bunch of popular projects had listed it as a dependency, maybe not even an explicit dependency, or like popular projects depended on something that depended on something that depended on something that eventually depended on left pad. And so when this developer got into this like completely unrelated legal tussle over a different package with a corporation, NPM, the corporation that administers the repository, ruled in favor of the corporation. And when I say ruled, it's not quite clear what process happened there. And the developer just unpublished their code as a matter of principle, including these 11 lines, and it broke everything for everyone. This case study is worth reading as a cautionary tale. Without getting into who was right and who was wrong, there are a lot of ways in which the story could have been averted at a lot of different stages in this discussion. And faced with breaking the internet, Laurie Voss, who was chair, I don't know if he still is, of the NPM board or organization, company, whatever, they unpublished the package in question without bumping the version number, and they handed the keys to a different developer. If this is not already making you feel like, very scared and uneasy on security grounds alone, then it should. It's scary. What if they handed it to a developer who was malicious? Did they vet this other developer? What if I've spent some time vetting the original developer and now all of a sudden, I've had the rug pulled out from under me? They didn't bump the version number. They didn't do any of those things. So that's kind of scary. And I don't know what to say about that kind of thing except thank God that we have Donald Stuft and because I can't speak for him to say, what he would have done, or just generally the Python packaging people that are involved in it. But I'm extremely, extremely grateful for having that as something that I can trust and rely on. And it's hard, thankless work that you only really think about when it breaks. By contrast, I need to give props to NPM the client, like the pip equivalent, for a fundamental choice that I do love. You have to explicitly ask it to install packages globally. Like, the default is it installs them locally, as if into a virtual env. In fact, it doesn't even have this whole virtual env thing because Node is file system based. It literally installs it into the current directory, like wherever you are when you execute the command. This is a great default. I don't know if we could ever pull this off in Python, but this is a great default. But otherwise, NPM has a number of other warts. It's slow. It's really slow. Every time I try to download stuff from NPM, and the caching story there was totally busted. It can be non-deterministic, meaning that two people installing from the same package.json, which is like requirements.txt, might end up with the same dependencies, but a slightly different on-disk layout. In theory, this should be okay, but it can be the source of some very mystifying bugs, that work for me but don't work for somebody else. So that's terrible. A collection of engineers from Facebook decided to actually fix this problem, and a couple of weeks ago, they just released an alternative NPM client that you can think of as sort of the pip to NPM's easy install. Called Yarn, and it solves this and a number of other user experience deficiencies. It pins package versions by default. Normally when you install things with NPM, it installs it with a default semantic versioning identifier that says like, don't bump the major version number. But as I've previously said, I don't trust even minor version number changes or really patches either. So, so I like to pin the exact dependency number version. Yarn does this by default unless you actually go out of the way to like type extra flags to say, no, I want something different. And it's fast. And you know, you can say, okay, how much do I care about it being fast? You know, how often do I really npm install on my local machine? That's not what fast is useful for. Fast is really useful for your CI. Like every time your CI build needs to download all of these packages, Yarn being like 5 times as fast as npm means that you get to skip over a lot of time and waiting. So, once you've gotten all of your dependencies installed, you still need to write your code, and that code should be beautiful, and it should look the same as everybody else's code, right? We have pep8 in Python, right? And we probably have something in JavaScript, right? No. There's no pep8 in JavaScript land. Unfortunately, there isn't one standard. Like many other things in JavaScript, there's like the XKCD version of standards, where it's like now I have like 17 standards or whatever. But there is a decent linter called ESLint. It has a lot of plugins, a lot of rule sets. It's on you to choose which rule sets you want to use. You can use the Airbnb style guide, or you can use that style guide, or whatever style guide. Pick one and use it. Me, personally, I found one called Standard.js, which is fairly popular. I like it mostly because it has 0 options. Like, it's literally like pep8 in the sense of, this is what it is. You don't have any say, like, you know, in theory, I could write a piece of software that will format stuff this way. So Standard.js feels a lot like pep8 to me. And it has one other feature that I like very, very much, in that it outlaws the semicolon. Relying on JavaScript's automatic semicolon insertion. Who here knows that JavaScript will insert semicolons for you if you don't do it yourself? Awesome. Who here knows what the rules are for that? It sounds scary, but it isn't. Like those ads you see on the internet, there's one weird trick, and if you know it, then it just works. And the rule is, never start a line with any of these 3 characters. So long as you don't start a line with any of these 3 characters, you never need to use a semicolon in JavaScript, ever. And this is particularly important if you're hopping back and forth between writing Python and writing JavaScript, because if you're writing semicolons into your Python, you're going to discover rapidly that it doesn't work. So yeah, that's a thing. But regardless, linters are a great thing if you're writing JavaScript. Pick one, set your editor up to use it so it complains at you. Set up like your git pre-commit hook so that it complains at you. Set up your CI so it complains at you. Consistency is a lovely, lovely thing, and there's no reason that you should give that up just because you're writing in a different language. So, on the spectrum of strong versus loose typing, JavaScript is its own animal. Coupled with the fact that exception handling is relatively limited in JavaScript, like you can't catch a specific error. I can't say like, I want to catch only like this kind of error. Nope, you can just catch an error and then deal with it. And you have a recipe for breeding a lot of bugs. There are 2 projects that graft static type checking onto JavaScript. Both are popular, and both catch common type safety errors. Like, hey, this could be null, and you're not handling that case. Just letting you know. But at compile time versus getting this error when it's already in production, which is terrible. So there's Flow, which is from Facebook, Flow type. It's pretty nice. It's the one that I've looked at the most. I haven't put either one of these into production yet. So all of this is sort of my speculative opinion. It's easier to gradually add flow annotations to your code base, and it's compatible with the Babel toolchain. Like it can literally be one of the transforms in your Babel compilation. The other is TypeScript. It's very popular also. It was released by Microsoft. It's used by a lot of libraries. Immutable.js is one. I've seen it all over the place. Anytime you find a file inside a project that ends in .d.ts, that means that somebody has exposed the TypeScript definitions for this library, and that's very helpful. It can also auto-generate documentation for you, which is pretty nice. But it has some functional overlap with Babel. The TypeScript engine can do some, I'm not quite sure exactly what degree, of ES 2015 transpilation for you, but it means that you can't have that in the same tool chain as Babel. So in the war of Babel versus TypeScript, I choose Babel and then Flow. But a lot of people choose TypeScript, and particularly if you're working on a library, a lot of people choose TypeScript for libraries because then you don't need to integrate with this build system that does whatever. Everybody loves a good REPL, right? Node ships with one. And Babel ships a wrapper that translates your statements on the fly, so you can write more modern JavaScript into your REPL. It works pretty much the way that you would expect it to work. Not much fancy there. But if you miss IPython Notebook / Jupyter, or whatever it's being called nowadays, there's a service called RunKit. It's like a hosted IPython Notebook, Jupyter, whatever, that has some extra fanciness, that has access to all of the packages on NPM, so you can just require whatever, there's no installation necessary. This is a highly useful sandbox. It's just oh, cool, it's actually doing what it's supposed to do. Okay, let's talk frameworks. The highest compliment that I can pay React is that it tastes a lot like Django. I've been using it for the past 2 years. We built out data.heroku.com with it. It's very undogmatic. A lot of attention given to backwards compatibility, both in terms of actually caring about not breaking things and documenting what the process is for backwards incompatibility changes. When you look at the release notes of React releases, they smell and taste an awful lot like Django's release notes. I find this comforting, like a warm security blanket. But most critically, it sports the clearest mental model I've ever seen for front-end development. You have React components, they receive state, and then they render themselves according to that state. So state in, whatever that state should be rendered at comes out. There's more than one way to do that, but by and large, that's what React does. Ember. I like Ember less for fairly plain reasons. Heroku's dashboard is an Ember app. Ember is incredibly popular, particularly for JavaScript developers that are coming over from the Rails world. It has a lot of the same sort of principles and ethos, the convention over configuration thing. And they have a vision that's super clear to them, and they're executing on it. They're constantly incorporating good ideas as they come up. This is made for a little bit of a bumpy road. If you actually use Ember and have used it for the past, I don't know, 1.5 to 2 years, then every once in a while they're like, hey, this is a pretty good idea, we should do that too, and then they write a whole new version of Ember that breaks half of what was there beforehand, and everybody is forced to upgrade their code. So it can be bumpy. But if you're coming from Rails, it has a lot of the same mental models as Rails. Like Rails people look at this and they're like, oh, I get it, here's my controller, here's my thing, here's my that. I looked at it and I was just like, why does this file have the same name as that? Does that mean that that's why this file knows about this file? I just didn't understand. It's all convention. But convention seemed very magical to me. I can't really speak to Angular very much because I haven't done very much with it. There's actually 2 versions here, version 1 and version 2. Version 2 is really, really different. If we talked about Python 2 and 3 earlier, if anybody has ever done the Python 3 thing worse than Python has, it's Angular. They broke literally everything in Python 2. No, you're saying no? Or you're saying yes? Yes, okay, excellent. Wholly incompatible with version 1, and it's led to this schism where a bunch of developers are really annoyed that they just wrote a whole code base in something that's deprecated. So yeah, it makes me feel kind of good about how we handled Python 2 versus Python 3. There's lots more. Reactive.js and Vue.js Elm, Polymer. Polymer is Google's thing that wraps standard like vanilla web components, which is like a standard, and was ostensibly going to be the future, but then React and Ember and all these things sort of came along and lapped these things. Vanilla web components are still nice, but they're not quite ready for prime time in a lot of browsers. So Polymer is Google's way of shipping web components with the polyfills necessary to make it work everywhere. They also released a bunch of their material design stuff together with Polymer, making it easy to sort of in a bootstrappy way, like build things that look fairly attractive fairly quickly. And I'm sure there's like 19 other ones that I haven't heard of because I'm just not that much of a cool kid anymore. But they exist, they're out there, and they're constantly showing up. But the big ones are the ones that I think we've sort of touched on them all. Okay, so now you have this mountain of tooling that's enabling you to write your software. You have some tools to let you write code from the future, and you have some tools to enforce consistent styles, and you have some tools that validate that your code does what you think it does. And of course, this is the web, so you have some more tooling that's not JavaScript related, stuff for processing your CSS and your markup, and hopefully you have some tooling for tests. Modularity invites a wealth of tooling, but then you actually need to run all of that tooling all the time. And you don't want to type like 15 commands to like run this tool, then that tool, then that tool, then that tool. So you want a better way to like orchestrate your three-ring circus. For a while, there was a succession of modular task runners that were the de facto way to stitch all of this tooling together, like run your development server and bundle everything up when it's time to deploy to production. Grunt was the first one, and it spawned this whole ecosystem of tasks. Tasks for compiling, tasks for minifying, tasks for copying, tasks for whatever. And Gulp came a little bit later, and it had a slightly different mental model. Sources, filters, and sinks. Sources were most often your files. Filters were anything that processed your files, and sinks is where they wrote the files out to. Sometimes they would write multiple things together into one file, for example, for concatenation. But it was sort of like breaking up tasks into like more functional components. These two are still around, and they're still somewhat popular, but they are being displaced by Webpack, which is the newer kid on the block, although not so new anymore. Version 2 is about to be released. And it's rapidly becoming the dominant tool, particularly in the React community, but not just. It knows how to work both with code and other static assets, images, everything, CSS. And it makes it easy to set up all kinds of things that you want, like hashed file names for easy cache busting, with far future expires headers. It knows how to traverse your files and figure out which ones are importing other ones. And if you actually go to the Webpack like page and see, like I think their old logo used to be like a network of files with like the connections between them. Literally, that's what Webpack knows about. The upcoming Webpack 2 even knows how to do something pretty cool, which is called tree shaking, by which it discards code that you're not using or assets that you're not using and actually excludes them from the bundle that you're shipping for production. Like it shakes the tree, and anything that's not firmly attached to your tree falls off. Hence tree shaking. It also supports bundle splitting, which is another great performance tool. You can say, okay, here's the parts of my code that involve my libraries, things that don't change very often, and I'd like to cache them for a longer time. And here's the part that includes my logic that I'm going to be shipping every day. And I don't need to invalidate the first bundle every time I do a deploy. So Webpack makes it easy for you to sort of split your code into pieces and deliver them as a couple of different files so that you can better leverage browsers' caches. So all of these are great, but it's this last feature that is maybe the number one reason why I love front-end development today more than ever before, and that is hot module replacement. This is literally the largest like type that would fit onto this slide. If you set it up correctly, Webpack plus hot module replacement enables this magical, you're going to have to imagine the Johnny Ive voice because I can't do that, a magical front-end development experience. This isn't live reloading. This isn't like I make some changes and then my browser automatically knows that it should refresh. That was a step forward, but this is something way better. This is literally swapping out your running code for new code while it's running. So say you're working on something that needs to be in a particular state. For example, form validation. Reloading blows that state away, right? You know, every time you make a change to that, you reload the page, and then you have to go do whatever you did to get the form into the state where you could see the thing that you're working on. Having to retrace your steps and recreate that state is a huge speed bump. I can't overstate how much I love this. I'm willing to pay almost any price to have it. I don't believe I will ever go back to working without it. And that's good, because configuring Webpack can be a real pain, but still totally worth it. This went a lot faster than I thought it would. 2 years ago, when I struck out on this road to sort of level up my JavaScript, I felt very lost. I knew that jQuery was over there, and D3 was over here, and people were building more and more ambitious things with JavaScript. Everything felt foreign to some degree. It still does. But there's a lot in JavaScript land where my first reaction is still to scratch my head. But there's a difference between feeling foreign and feeling both foreign and lost. There are entire areas of JavaScript that I haven't even discussed. Advancements in client-side APIs, things that enable us to build ever more refined web apps that don't feel like web apps. Adrian, wherever he is in the room, is super excited about surface workers. There's a ton being done to enable high-performance animations and things that sort of bring the native mobile feel to the web. Native apps have blazed this trail that sets expectations, but I still believe that the web is powerful like a river. Year by year, it nibbles away at the things that stop it from greatness. And hopefully, you no longer feel that JavaScript is something to be avoided or laughed at, but another place for you to level up your making, your maker foo. And that's it. Thank you. Oh, okay.
We've got about 3 minutes left on your talk slot, so it took longer than you felt it did.
Okay, so here, see, it says 13:57. I'm just like, it's been only 13 minutes? Sorry.
So I'm just going to be very picky about the questions, but there's a whole load of questions for you to go back and look at. You said earlier about the pace of change in the JavaScript community and everything moving really, really fast. Have you got any recommendations about how to keep up with that? Are there good conferences to go to? Are there good blogs to read?
There are. I'm going to say Reddit. I know that might not be the most popular thing to say, but Reddit's like our JavaScript is actually a fairly good source of news for things that are going on in the JavaScript community. I also subscribe to our React, which has a lot of like React-specific news. There's podcasts, there's a ton of conferences, there's JSConf and JSConf.eu, there's ReactConf, there's EnverConf, there's a million conferences to go to. I haven't been to any of them, so I can't tell you which of them are the good ones to go to. I will say very positively that a trend that I've observed in JavaScript conference land is that they also taste more and more like Python and Django conferences, particularly as relating to anything involving code of conduct and making everyone feel welcome. And I feel like that's a prerequisite for me being willing to stick my toe in that pool. So I'm happy about that, but I don't have specific conferences to recommend.
You said about the massive battery shop. Is there an idea that, can you imagine JavaScript starting to have more batteries, starting to have more of a standard library as we get to, ES9, 12
whatever
or something?
ESN. Maybe. My guess is that I don't think, look, I can't speak on their behalf. I'm not part of core anything in JavaScript. But my guess is that the answer will be no. Because as just a basic ethos, the ethos is very much one of like, no, go download it somewhere else, like NPM. So I don't think they're going to include more and more things that are not just like language features. But I do think that we're starting to see sort of the pendulum starting to swing the other way. If previously it was moving only towards a divergence, more and more packages trying the same problem from different angles, now we're starting to see a little bit of consolidation. Everybody's settling on this one as the one to do this, and this one is the one to do that. So that's a positive move because it makes it easier for you to find the one that's good.
And finally, how do ASM.js or WebAssembly fit into the big picture of JavaScript going forwards?
Have you all seen Gary Bernhardt's The Birth and Death of JavaScript? If you haven't, you should watch that, because I feel like that's probably the best answer to that question. It's interesting in the sense that ASM.js is a way to annotate your JavaScript in a fashion that permits the JavaScript, like the JIT, to efficiently JIT your code to the point where it's almost native in terms of speed of execution. So you can write things like games or I don't know, anything else that's going to be need something a little bit more powerful than the standard JavaScript interpreter. ASM.js is a way to maybe future write native applications in JavaScript, but it's not quite there yet. There's some motion on this. I see a lot of talk about WebAssembly, but I feel like it's not yet important enough for me to actually spend time learning it. Let me put it that way.
Thank you very much, Idan.
Thank you.
Good job, Idan.
Thank you.
For those of you who have met me and spoken to me, or actually quite a lot of the people in this room probably, we really, really like Postgres. I really like Postgres. I wrote a whole module in Django about Postgres. But Postgres is not the only database we have in Django. Django itself supports 4 different backends. We've got Postgres, MySQL, SQLite, and Oracle. That's far from all of the databases. There's a whole collection of other databases around. One of the better known ones would be SQL Server. And one of the implementations of a database backend for SQL Server is Django MS SQL. Maintaining a database backend is a daunting and complex task. We're well down in the ORM here. So I'm delighted to invite Michael Manfre to come and speak about what is a database backend, how do you make one work, and how much fun is it? Please welcome Michael.
Okay. So better. Okay, excellent. Okay, hello everyone. I'm honored to be here today. For the next hour, I'm going to be sharing a topic with you that I've been passionate about for several years. It's Django's database API and the custom database backends that use it. For those of you that don't know me, I'm Michael Manfre. I joined the Django team last year, and for the past 8 years, I've been maintaining Django MS SQL. As Mark stated, it's a custom database backend that allows Django to interact with Microsoft SQL Server. My introduction with Django started back in the spring of 2008. I was hired as a C# desktop application developer for SRC. I had almost no experience with Python. I'd never heard of Django until I was actually in the interview for SRC. SRC was a standard Windows shop. Basically what this means is that all of the servers, the desktops, everything that they use is running Windows because that's what they're comfortable with. There was no Linux servers of any kind. Shortly after being hired, they had this project of redoing their website. It was a pretty extensive website, interfacing with an existing database, had its standard businessy client-server application, lots and lots of stuff to it. The other developer on the staff, he was a fan of Django. He had been using it since before 1.0. He managed to convince them to use Django instead of VB.NET or some other Microsoft technology, because those were pretty much the way that they wanted to usher things. There were a few caveats to the agreement. The website had to connect to the existing SQL Server database, so they couldn't use any form of replication or any backend thing to just move the data along from one database to a different one. Because they had done that in the past, there was lots of issues. And the other issue is Django had to run on Windows because they were Windows shops, they did not like Linux. At that time, there was no suitable database backends for MS SQL. One or two existed, but they all had some issues that made them unusable at SRC. Out of this need, Django MS SQL was created. Most users of Django never really need to dig into the internals of Django. In 2008, Django was a lot less of an inclusive community than it is today. Windows and SQL Server were an extreme edge case. And my questions on IRC often were answered with, don't use Windows or use Postgres. To make things even more difficult, the database backend API is a private API. So if you ever hear it's private, it's internal with regards to Django, that means it's not supported, and to help make it sure it's not supported, like externally, they don't document it. This pretty much forced me to venture down deep into the code. I felt lost, confused. It was very frustrating. Despite the pain of this experience, I feel I came away with a much better understanding and appreciation than what most others get to just take for granted. For this talk, I've made a few assumptions. On this side is a query found in Django's test suite. Hopefully it makes sense to all of you. It's okay if you don't understand why it's adding the CEO's salary to the number of employees. I don't understand it either. And this could be something that one of you could fix during the sprints. There's lots of little things like this in the test suite. The test is still valid for what it's trying to do, but it's a little weird. I also created this talk with the assumption that you've all written raw SQL at some point. The SQL on this slide is generated by the query above it when using SQLite. If none of this slide makes sense to you, no worries. You should still be able to follow along with most of this talk. For those of you who have not seen James Bennett's tutorial, Django in Depth, I highly recommend it. The tutorial is based upon Django 1.8, and while some of the things have changed in Django, it's still worth watching a few times. In the first portion of his presentation, he gives a great overview of various portions of Django's ORM, how they work together, and he starts with the database backends, which is the lowest level, and then works up one level at a time. This talk is a more focused look at the bottom two most layers, the database backend API and the SQL compiler. I will also talk a little bit about expressions in the query class, but mostly in relation to how these are used and modified by a database backend. While guiding you through the depths of Django, I will share with you some of the common and interesting problems that backends have needed to solve. You'll also get to learn about a few of the database quirks. In talks about the low levels of Django, especially the ORM, it's often said that there are dragons. It's true, the code is kind of scary. It's okay though. They're quite friendly once you get to know them. So what does a database backend actually do? The simple answer, it's a bit of code that sits between the Django's ORM objects and the drivers for the database. It's kind of the glue that binds the two together. The database drivers typically consist of Python package that implements a PEP 249 database adapter that wraps the lower level system drivers. The system drivers could even be something like the requests package. For example, if you wanted to write a backend that worked against a REST API instead of a true, just actual database. Django MS SQL relies upon the ADO DB API adapter that wraps Microsoft DLLs of some various flavor. There's a few of them. And for those that are more familiar with Postgres, the adapter is PsychoPG2, which usually wraps libq at the system level. So Python PEP 249, this defines a standard for database adapters. This makes it so frameworks like Django have an easier time supporting all the different database backends out there, so they don't have to redo it for themselves, and there can be a lot more sharing. So it defines common interface for connections, cursors, exceptions. It even provides several different ways of putting placeholder values into SQL strings. Django uses the format param style, but there are a few other database backends that rely upon QMark. This will be referenced a little bit later. Django makes it very easy to interact with the database in a somewhat consistent way. This prevents users from needing to fully understand all the capabilities and limitations of the underlying database. This is good, but not all databases are created equal, and it's helpful to learn some of their differences. SQL is a standard with many reversions. Database servers like to extend the standard, and not all of them do it in the same way. From my experience, supporting slicing has been the most troublesome. Some other oddities relate to transactions, different data types and their precisions. Also, what exactly is null? Sometimes null equals null, sometimes not. Other times null equals an empty string. Also, how would you actually order null? These are the types of things that database backends need to understand on behalf of Django. Database backend is kind of like the power grid or some other critical infrastructure. When it works, great, everyone is happy, and the users forget that it's even there. The only direct interaction that most users have is when they're setting up their project. They'll install the necessary Python packages, and then they'll add its path the database's setting under engine. When a backend is loaded, the connection handler class imports a module named base under the path defined by engine. This imposes the first bit of package structure for database backends, and is how Django finds the database API classes that it implements. While researching for this talk, I discovered many instances of custom database backends that were all shapes and sizes. On this slide is the entire code from the backend Django Postgres read-only. It's essentially a one-line code extension for Django's built-in PsychoPG2 backend. All it does is it just changes the connection string to read-only. So creating a database backend can be very trivial. I can't imagine this took the developer more than a few minutes. Another example that's less trivial is Django SQL Server. The database backend is slightly more involved. It actually extends Django MS SQL, which is the one that I maintain. And basically what it does, it shims out the underlevel drivers from, instead of using ADO's drivers, it uses Python TDS because they wanted to be able to run this from Linux instead of just being forced to run it on Windows. He also managed to implement a couple of updates beyond what I've done, for example, select for update, and just a few other patches that I haven't just gotten around to implementing myself. So a database backend that extends another backend doesn't necessarily need to handle all the little quirks of the database. It gets to focus on just the specific things that it cares about. When writing a database backend from scratch, these are all the classes that need to be implemented. Django provides base implementations for each class. These base classes are essentially the backend API. These base classes are found under django.db.backends.base. The list is ordered with the top being the classes that must be overridden and tweaked first, and the bottom requires less changes or have less impact for most projects that would use the backend. For example, in Django MS SQL, I haven't implemented anything for database validation, and I didn't even do database client either. The database wrapper class must be importable from the backend's base module. The rest of the classes are accessed from the database wrapper instance. The database wrapper class is named perfectly for what it does. It wraps the underlying database and is the main code path for Django to access all the backend's functionality. In this class is the code for interpreting Django's database's settings, maintaining usable connections to the database, creating cursors that are used to run queries, turning database constraints on and off, and it's also responsible for handling transactions. One of the most trivial and important things in a database backend is the vendor string. This is a string that helps identify the database type. A lot of things in Django's ORM key off of the vendor string to do some bit of behavior for a type of database, without needing to know about every specific database backend that has been implemented in the entire community. All database backends that work against Microsoft SQL Server will typically use Microsoft. The Postgres ones will use PostgreSQL, for example. There are two documented uses of the vendor string. The first is to allow overriding an expressions as SQL method. I'll cover this later in the talk. The other is the required DB vendor model meta option. I first discovered this while searching through the code for this talk, and then discovered that it was actually publicly documented. This option is used by migrations in a multi-DB configuration. Basically what it does is it restricts the model's migrations to a specific database type. So if you had a model that has Postgres-specific fields on it, you don't want to try running migrations against SQL Server if you have multiple. There's 3 attributes on the database wrapper class that define the basic SQL syntax. Those are the model lookups, operators, and pattern strings. Operators defines the simple lookup operations, and pattern lookup operations when dealing with raw strings. This uses Python's %style string formatting to generate the SQL. Pattern escape is used to sanitize the string. This usually means escaping the SQL wildcard characters. For MS SQL, the database backend spares users from having to put triple nested replace calls in their queries. You're welcome. Pattern ops defines the pattern lookup SQL clauses when the right-hand side is an expression or something that is not a raw string. The percent character is a wildcard for the like operator, so pattern ops and pattern escape use string.format instead of percent style formatting, just to make it a little bit easier to read. The last important group of attributes on the database wrapper class that I'm going to talk about define how a model's fields are mapped to the database's columns. Data types and data type suffix are used to construct the SQL for the data type. They will be combined to create the appropriate SQL, so it's possible to find the data type plus the suffix in data types or split them apart, kind of like what I did for autofield and big autofield. One does one way, one does the other. Data type check constraints defines the SQL database check constraint for a field. When these strings go through string formatting, all of the _dict values for the field are provided to it. If a value needs to be quoted, for example, the column name, the named format string value can be prefixed with a QN underscore, and Django pretty much takes care of that magic for you. And there's a few methods that a backend needs to implement on its own. A database wrapper needs to implement on its own. It's for the connections and cursors, the transaction management, and for foreign keys constraints. The foreign key constraints in the base implementation are no ops, so you don't actually have to do anything with those. Whereas the ones for connections, cursors, and transaction management, those all raise not implemented exceptions, so you have to do something for those, even if it's just pass. Much like database wrapper wraps the database's connection, the cursor wrapper class wraps the database's cursor. Django provides a default implementation in Django DB backends utils. This wraps all the underlying Python cursors methods to catch and rethrow database exceptions using an exception that Django better understands. In that Python module are helper functions that are capable of converting Python types to and from database strings. For example, decimals and various date and time types. There's a few reasons why a database backend may need to implement its own cursor wrapper. For example, it might need to remap a database exceptions to something more appropriate. MySQL and Oracle need to do this in the built-in database backends. It might need to actually change the param style from format to QMark. This is something that SQLite and PyODBC need to do. And the cursor is actually instantiated from database wrappers makes_cursor method, which is used when you do a connection.cursor. It makes its way down to this, which actually constructs it. The database wrapper does all the work of cursor wrapper. The debug wrapper does all the work of cursor wrapper and adds timing metrics and logs all the queries that it sees. There are two ways of getting Django to use a debug cursor for whatever queries your code is doing. You can either set force debug cursor to true or settings.debug. Debug cursors are a great way of figuring out what a Django query looks like in SQL. Much like Emmerich, I use them often when I want to be certain I wrote the correct Django query. The database features class is where a backend gets to identify all the different sorts of features and behaviors it supports. For example, can it slice subqueries? Does it have various native data types? Or will Django need to convert to and from another type, usually a string? It is possible to poke the database to see what it can do. Django does issue certain queries against the database to automatically determine if it supports transactions and supports certain expressions. Many of the features are only used by the test suite to figure out which test it should skip or what assertions to make. When maintaining a backend, this use of features helps you follow a test-driven development style. The tests are already written and skipped until you're ready to try and emulate the feature yourself. When Django does a migration, it needs to generate a bunch of SQL statements to change the database's schema to match the new model definitions. Not all databases can do this the same way. The database schema editor class is part of the backend that knows how to do those changes for its database. For more details about migrations, see Andrew's talk from 2 years ago at Duth. The schema editor class provides many SQL template strings. These are modified by the database backend and define the expected syntax for the database when creating, destroying, or altering any schema object that Django understands. For example, tables, columns, indices, constraints, etc. For most DDL statements, the SQL templates provide enough flexibility to get things working. If the underlying database is different enough from what Django expects, things get a lot more complicated really quickly, and changes are required to the methods in this class. SQL Server and Oracle are databases that cannot rely solely upon the SQL templates and run into problems when doing field alterations. There's two approaches to overriding the base alter field implementation, which is where all this happens in that class. The built-in Oracle backend has taken the approach of, let's try to let the base schema editor handle all of it, and then it'll try to catch specific database errors and apply a workaround. And that workaround is basically create a new column, copy all the data from the existing column over, and then delete the old column, and then rename the new one back into place. This works. The big negative is that if the table is large, this could take a really long time. For SQL Server, I had to implement it differently because the time for the migration was too long for our database size. So I re-implemented the _alter field method with the various fixes required for the database. It fixes the issues without needing to do the fallback of the large data copy. The real negative to this, though, is that it takes a significant amount of maintenance effort after each Django release. Once again, this is a private API and not subject to the same backwards compatibility rules as the rest of Django. Even when it seems like there's no new ORM features with a release, code can and will be refactored at the lower levels. If possible, it's best to try to avoid overriding any of the methods of the database schema editor, except for quote value and prepare default. These two have to be implemented. Quote value returns a quoted version of a literal value so that it's safe to use in an SQL string. Some database adapters provide a method to do this for you, but others do not. For Oracle and SQL Server, they have implementations that look something like this. And prepare default typically just calls quote value. The big red comment up there saying it's not safe as a warning, don't ever use this from user code or anything that's provided with data from the user, because we put no guards for SQL injections in there. The code is safe to use with migrations because value that's passed in is only ever provided by developers that create the migrations. Database creation is responsible for creating, destroying, and cloning test databases. It's used by test server management command and the test runner. This class had a much larger role in the olden days when syncdb was still being used. Each of the create, clone, and destroy operations has two methods. The method without the underscore is called by Django. Those provide the database agnostic behaviors, such as the keepdb flag, managing database names when parallelizing the tests. The underscore prefix methods are the intended hook for database backends, and those are what needs to do all the backend specific stuff. Okay, by a show of hands, who has started a Django project by using inspectdb to define your models? That is actually more than I thought it would be. So for projects using SQL Server and Oracle, this is a lot more common. The introspection class is pretty much what knows how to look into the database and figure out all the various schema objects that it contains. InspectDB uses the queries and the reverse data type mapping to generate the model code. These models are not perfect and are not meant to be a starting point to save, they're only meant to be a starting point to save you a bit of typing. Despite its documented imperfections and the relatively low usage, introspection has been one of the main reasons people have opened tickets against Django MSSQL over the years. InspectDB it's kind of like a stepping stone that gets companies into using Django. It's like, hey, I get to save a lot of typing, so let me just go with this. The database client class is used by the DB shell management command. It does slightly more than saving you from typing out PSQL and then like the connection parameters or SQL command in the Microsoft world. I don't use it, never implemented it for Django MSSQL because SQL Management Studio is an amazing tool. I really wish there was something like that for like Postgres and the other database backends. Database validation is new with Django 1.10. It hooks the database backend into the checks framework. The backend can do checks for individual fields or the database as a whole. Currently, MySQL is the only database backend that's using this. The base class is the smallest of the backend classes. All of the code for the class is up on this slide. By default, it does no checks for anything, which is great because it's brand new and I didn't really notice that existed until I went digging into the code. The check method is called by the check database backends register check, and it does this for each of the configured databases. This method is where the database level checks should go. For example, MySQL uses this to warn you if your database doesn't have strict mode set because truncating data silently is not really a good thing. The check field method has a much longer call path. It basically works its way down from the model into the fields and then finally ends up in this check field method. Okay, the database operations class encapsulates all sorts of backend specific differences for the databases. It's basically like a dumping ground for things that didn't have a better fit in any of the other API classes. This class specifies where to find the SQL compiler used by the backend. Postgres is officially the favorite database of Django. Its operations class points to the built-in SQL compilers, so that's by default, Django wants an SQL that kind of looks like what Postgres wants. Most database backends have to actually implement their own SQL compilers and put the path in here. For Django MS SQL, most of my time working on this class was devoted to dates and times. Some of the methods helped to make sure Django has the correct SQL as the query worked its way down into the database. Database converters make sure Django was given the appropriate Python object on the way back out. Fun fact, MS SQL has datetime2, and a few other data types specifically for dates and times, and trying to figure out how and when things should be casted back and forth between the different versions is not trivial. Okay, the next section of my talk deals with portions of Django's ORM that are basically one level up above the backend API. This level includes the SQL compiler, expressions, and the query class. All of them have a method called asSQL that's used to render the SQL string. The query class is somewhat of a complex beast. It contains multiple lists of objects that together represent the database operation. For the sake of this talk, all you really need to know is that it represents the database operation. It has an asSQL method that generates the SQL, and an SQL compiler is constructed for each query. There are 5 SQL compilers, each meant to handle a different type of SQL statement. Django provides each of these compilers, and they implement most of the necessary logic for turning a query into an SQL string with a list of parameters. The string and parameters are important because of SQL injection. You want to keep those separate so that it can substitute them in later with placeholders. More on that later, though. There's a query class for each of the different type of SQL compiler. If you want to know what they are, you can look in django.db.models.sql.subqueries to find them. Most customizations done by a database backend will happen in the SQL compiler class. If no changes are needed for the others, the backend will still need to provide its own subclasses that inherit from the SQL compiler class that it created. On this slide are some of the reasons why a database backend might need a custom SQL compiler. For MS SQL, these bullet points are all of the big SQL tweaks that I've had to do over the years, with the biggest one being limit offset. So the dragon is sad because some databases think paging a query's results should be difficult. I don't know why. Limit offset has been around for many, many years, but some don't believe in that. So here's 2 ways that you can limit a query set. You have one where you just provide a limit. So it's like, give me everything from the beginning up until this point. And then you have one where it's like, OK, I have a starting point, and then just give me until my limit from there. For Postgres and MySQL, the yellow text is basically the SQL for making this happen. It's very simple. You have your query. There's a little bit of text that gets appended at the end. Pretty straightforward. Everyone should be able to understand this, even if you've never seen SQL before in your life. For SQL Server 2008, and the bottom also Oracle has that, it's a little bit more complex. As you can see, for even when you just say, like, OK, just give me like the first 5, you actually have to rip apart the SQL string, find a specific spot to put in, like, OK, I want the top 5. And then for when you actually want to say, I want the top 5, but I don't want the first one, you kind of have to do a whole lot of SQL mangling and magic. So the white text is the stuff that is provided to me by the base compiler. All the yellow stuff, that's what I have to do. And buried in there is a whole lot of field aliasing and adding additional columns for like the row number so I can do the where clause on that, and then stripping out all that extra stuff so that Django doesn't get confused by what I've done. Things got a lot better with SQL Server 2012. Basically, they added support for the SQL 2008 ISO standard, which finally added a limit offset syntax, which they went with offset fetch. I don't know why, but they did. But as you can see, it's somewhat similar to the limit offset. If nothing else, it's just some SQL that gets appended to the query, which makes it much easier to actually support and maintain. Yeah, so once I was able to drop support for SQL 2008, I ripped out probably about 300 to 400 lines of code that was just disgusting. My SQL compiler stopped feeling like a house of cards built on a trampoline. I just never wanted to look at that code. And every time I did, I'm like, okay, somebody opened an issue. Well, it only affects this one specific way, and they have a workaround. Here, just do this query instead. It'll be fine. Okay, expressions are a tree-like structure that knows how to turn itself into SQL statements by using an as-SQL method. All expressions inherit from a base expression, which is combinable. The combinable class provides the ability to combine two objects with a connector, and that connector can be some arithmetic operation or bitwise operator, for examples. Expressions are publicly documented and provide users with a lot of low-level control over SQL inquiries. Previously, this was pretty much the exclusive realm for the database backend. When expressions landed, there was a significant amount of work needed in Django MS SQL to get things working again. The effort was totally worth it. Many of the things that were previously needed, like some really wiry code and backend magic, like they became trivial with expressions. The SQL generation was contained in these nice little modular pieces that provided me a lot better access to the other parts of the query and things that I needed. So thank you, Josh. So this is the built-in length expression. It's a transform, which basically means that it's a function that will modify a field, and it's usable in a query by its lookup name. This is one of the expressions that is slightly different on SQL Server. So at the top, as you can see, it's like this is the substitution that I have to do in Django MS SQL. Instead of length, it just has len. And the override is monkey patch it in, and then just provide the new function name. There's other functions that are not exactly just as simple to fix. For example, substring. By default on Postgres, you have the SQL expression that you want to do the substring on, which can become a string eventually. And then you have the offset you want, and then an optional third parameter, which is how long you want it. If you don't specify the length of it, it'll just give you until the end of the string. Microsoft kind of felt that all three of those were really important. So you have to specify a length, and to do that, I basically have to modify the tree of the expression to include this new magical value that is just a really large number, because SQL Server will just say, hey, this is beyond the end of the string, I'll just stop at the end. And sometimes you can't actually even do any similar thing on the database backend because it doesn't have the same function implemented. For example, SQL Server does not have a greatest function. So what it has to do is it uses a template-based expression to provide essentially a subquery to do the same behaviors. Because max is an aggregate, and it takes the maximum value out of several rows, and greatest is not an aggregate, and it takes the maximum value out of a single row. So this is the way you kind of merge the two behaviors together for SQL Server. And you may have noticed that the as Microsoft decorator in the previous code snippets, the documented way of setting the as vendor method is to monkey patch it onto the expression. How to register these overrides was discussed, and monkey patching was agreed to be the most appropriate. For Django MS SQL, the vendor method is named as Microsoft because Microsoft is the vendor string. I really hope everyone has heard of SQL injections. For those who have not, this XKCD comic explains it really well. Long story short, you can't trust any data from a user if you want to be safe. SQL is strings, and most projects need to store strings. Special care is needed to make sure user-provided strings are not executed. When using query sets, Django in the database backend will protect you from SQL injections. All tables and column names are quoted. Values are not directly added to the generated SQL strings. They're provided to the underlying database cursor as a separate list of parameters that are safely escaped by the database driver. If you use raw or custom SQL with a database cursor, you're on your own to make sure you avoid all the SQL injection attacks. By design, database backends work with a lot of SQL and need to be certain that anything that we add into the SQL, it constructs it safe. So for recap, the top bit, don't ever do that in your code, please. Okay, there's been a lot of information so far, and we're almost to the Q&A. When you create and maintain a database backend, testing is the most important piece. While maintaining Django MS SQL, I discovered early on that without good test coverage, it was not possible to have any confidence that some feature or query would work properly with each deploy. There's a lot of things that can subtly change, causing the backend to break. When the backend breaks, it doesn't always raise an exception. Sometimes the queries work just enough to make it seem like nothing's broken, but the results are wrong. This is much worse than a noisy exception because it can lead to data corruption. New versions of Django and new versions of the database server are the least likely to catch you or your users of your database backend off guard. Most companies are not likely to upgrade to the latest and greatest version immediately after it's been released. Many Windows companies still follow the adage, wait until the service pack. All databases should explicitly list the major versions of Django and the versions of the database it officially supports. Not all users will read the README file, which can lead to extra support tickets. To help minimize those, I encourage you, if you're going to do a database backend, to put these checks in there just to catch those cases, because people will ask, hey, why doesn't this work? And it's usually some really disgusting, obscure traceback that has nothing related to any of their code. It's usually deep in the internals of the ORM. The best way to test a database backend is against Django's test suite. It has test coverage for all the features Django supports. These tests are usually written by someone other than yourself, which is great. And they're also merged whenever that new functionality or bug was actually added into Django. Another benefit is that it means that I can subconsciously write a test or I can't subconsciously write a test and have it match the implementation that I just did. To run the test suite against a custom database backend, all you need to do is create a settings file. Make sure it's in the Python path, and then pass it to the run test PY file. Around the time of Django 1.4, I set the goal of making Django MS SQL pass the entire Django test suite. I soon realized that I needed a few asterisks for that goal. I realized that I needed to keep local branches with changes to this test suite specific for Django MS SQL. Some of these changes were waiting for the pull request that I submitted to merge into Django. Others were shortcuts or assumptions to improve performance specifically for SQL Server. SQL Server has this now known bug where it does some really expensive things when you disable and re-enable constraints, which is something that happens when you load fixtures, to the point where at one point it would take me 8 hours to do a full run of the test suite, because all this time was just building and tearing down and validating the information, which was essentially a no-op. But Microsoft is aware of it now, and they're working on a fix, and the friendly core devs have found a solution to minimize the impact of that. So life got much better, and now only takes about a half hour. Some of the tests also have some hard-coded SQL in them, which just was not compatible with MS SQL. And some of them also had assertion values that were different than what Django MS SQL expected. By design, some tests, they would just never pass with Django MS SQL. And they weren't really worth the effort of keeping a local commit and updating that with all the new versions of Django that came out. For Django MS SQL, I extended database creation to monkey patch these known failing tests and basically flagged them as expected failures for specific versions of Django. A few of these tests were due to a quirk in SQL Server's datetime data type. Its precision is roughly 3 milliseconds. So it would round times to .000, .003, and .007. Yeah, that was a fun thing to learn. Many of Django's tests had hard-coded test values with a precision that didn't perfectly line up with these for some weird reason. So I discovered those, yay. Other tests, they would fail because I would either get too many results or not enough results back because the values stored would basically get moved to one side or the other of the filter when it did this rounding cutoff. So despite the awesomeness that's Django's test suite, a database backend's still going to pretty much have to maintain its own test suite to cover all these little quirky behaviors to make sure things are doing what they should be doing. Not all databases are created equally, so you can't test them the same way. For every database backend, there are certain tests that should not be run. In the Django test suite, there are two main ways of conditionally running tests for a database backend. The first is by checking for the vendor string. This should only be done when absolutely necessary. Because when you use the vendor string, it prevents other database backends from benefiting from the code coverage. So if the vendor string is not something like, okay, this is a quirk specific for like MySQL and it impacts no other database whatsoever, it's best to, like that's the time when you want to use vendor string. Any other time you kind of want to have a feature because back in the days of Django 1.4, the use of the vendor string was very prolific in the test suite. There were several tests that I've had to fix on my local branches. Many of these changes were related to like field introspection because it just said, okay, this is Postgres. Postgres is expecting this data type. MySQL expects this one. When in reality, other database backends would be able to leverage that same test anyway. So to make it easier for doing database feature level checks, Django provides 3 decorators that Anna discussed in her talk yesterday. All of them are importable from Django.test. So what many people want to know about database backends are the non-relational backends, like Django non-rel. The one question asked is like, are they really even database backends? Because they replace not only the connection portion to the database, they actually have to modify large portions of the ORM as well. And they kind of provide their own database API for the specific non-rel or NoSQL databases. So the ORM's main job is to turn some relational query into SQL. Non-rel databases are not relational and don't use SQL. So I mean, they don't really kind of line up. And because they have to replace large portions of the ORM, it's basically, long story short, it's complicated and a lot of work. If you want to do it, have fun. I can't really help you. So like me, most people only start working on database backends because they don't have a choice. The code is big and scary at first, but my hope is that I've made it a little bit more approachable, and I encourage you all to dig into the code from time to time. It doesn't take long to feel comfortable. You might even make a backend maintainer like me very happy by sending a pull request or two, please. And thank you. That's all I have for my talk today.
Thank you very much, Michael. So the database backend is internal-ish. Is there any sort of documentation other than the video of this talk for someone who's trying to do something like that?
Fortunately, nowadays the code itself is actually very well documented for the database backends. Like all the methods that you have to implement, all the attributes, they very well define what it is that they expect to happen, and in some cases even why that it exists the way it does. So I mean that became a good starting point later down the line for new versions of Django, for like Django 1.8, 1.9. So when like migrations landed and then expressions, the documentation in there was basically what I had to go off of. Plus by that point, the community, like the core devs, were like much more, I guess I just beat them down in the fact that I'm not going away. So they just like, okay, we'll actually answer his questions. He's asking the right things. He's not just like, oh, I kind of want to do this weird thing. So it just helps if you have intelligent questions and persistence.
Yeah, so the code is actually quite readable, although there's not formal documentation of everything in the Django docs. The code is reasonably well.
Yeah, I mean, there has been discussions in the core team about should we actually document it while still trying to keep it as a private API, and then it's still up in the air, so whether or not that should happen.
there are issues with private documentation that if we, at the moment, the deal is if we document something, we can't backwards and incompatibly change it, which is good for backend database maintainers.
But things like expressions
not
would
good
not
for
have happened if they had to maintain the same backwards compatibility.
It would have been impossible to do them. Are there any plans to add the MS SQL backend to core?
So adding it to the GitHub Django will not happen for MS SQL. I'm actually strongly opposed to that. I'm a firm believer that a lot of the database backends should actually get moved out of core. And then become kind of like, there should be some that are like just officially blessed by the Django team itself. They will support them, they will test them, but whether or not SQL Server becomes that, it would be nice. It's not really necessary as long as it's actively maintained.
So there's potential to become something like channels where it's not built into Django itself, but
Yes.
it's an official project.
Yes. Unfortunately, Microsoft has actually become a lot more involved with open source, and they've been putting a lot of effort towards trying to be better citizens in the open source community. So last winter, they flew myself and a couple other database backend people and Tim out there to basically have like a couple hack days and put us in front of their engineers like, hey, how can we make your lives easier? So I mean, they're contributing to some extent engineering support to make the drivers better on all the different OSs. They're also potentially going to contribute money to make sure that these backends are maintained in a more active fashion. So
if you have an interest in maintaining these sort of things, come and talk to us. There are potential ways to improve it. As I mentioned at the start of the talk, quite a number of the core team are very fond of Postgres. In your opinion, what does MS SQL do better? Why would, if one had to choose from any database, what are the reasons why you would go for MS SQL?
So some of the nicest things about SQL Server are the tooling around it. So SQL Management Studio, I can't praise that enough. They did an amazing job on making an easy-to-use interface for accessing and running SQL and just kind of seeing what's going on the server. With regards to the database itself, some of the things are a little quirky, but it's pretty good, and it has a lot of the functionality that you'd expect, and things just kind of work. I mean, it has the quirks that make it run a little bit slower in certain instances, especially when you're tearing down a database and trying to build it back up. But for the most part, it's just as performant. It does good selection for which indices it's going to use. And there's a really wide community over just supporting it because there's thousands and thousands of companies that are using this. And there's any question that you'd ever have about the SQL that you'd use for it has already been, if not on Microsoft's knowledge base, is on Stack Overflow or some other resource.
And things like the Django MS SQL backend and the Oracle backend that's still in core at the moment, the existence of those allows people who are stuck in a more corporate kind of IT system to start using Django without having to rip it out and go.
Yes, I mean, like basically as I said before, when I was hired by Semiconductor Research Corporation, they didn't really have any incentive or desire to branch out from, we have Windows servers, we know how to administrate them, we're good, we're going to stick with that. So I mean, if it wasn't for the ability of Django to have this backend API that could actually communicate with SQL Server, I probably would not be on this stage today. I don't know if I would have actually got into the Django community at all. So.
And so there's a couple of questions around kind of expressions and the syntax. When you're writing your backend, you now have some things that live in the backend and some things that are your own expressions and some things that monkey patch into existing expressions, and the SQL's quite distributed. Do you think there's a plan to kind of move in a particular direction, or how do you feel about that?
I mean, I kind of like it the way it is, because you have these little things that give end users a lot of control. In the past, when these types of like aggregates or whatever need to be implemented by somebody, I would get a ticket open like, hey, you never actually implemented this. Can you add it to the SQL compiler? And that never really came as like a pull request. It always came as a, hey, I want this. Can you do it? And a lot of the times, because I was working on this database backend because I had to, if it wasn't something that my employer needed, it basically went to the very bottom of the list of things that I can do. That was the extra like, 8 to 12 hours a day I would do beyond my job on just maintaining this.
There's an extra problem you run into when you've got an expression. It's what I call a ninth party problem. You've got a third party database backend and a third party expression, and you want to make the two of them talk to each other. At the moment, we deal with this through the monkey patching approach, so that me and my user code can monkey patch that thing to know how to talk to that database with Django over here somewhere. Do you think we would be able to use the single dispatch function from Python 3 to solve a similar problem?
I'm not sure. Potentially, I'd have to dig into it and think about it a little bit more. Can't really answer on the spot with that one.
Cool. And a final question. Where did that crazy row number syntax come from?
I don't know. I don't know who invented that or why they decided to use that.
Because Oracle does it.
I mean, Oracle does it too, so it must have been in one of the earlier SQL standards, possibly SQL 92. But the whole concept of like, hey, like paging through a list of results, that's something that pretty much every application, either in the business world or on websites, will need to do at some point in time. So I can't imagine why they had it so difficult, or why they. I guess, at least in the Microsoft world, a lot of the things tend to use stored procedures where you can make use of server-side cursors a lot more, so they didn't run into the problem as much.
Thank you very much, Michael. Break time. So I will see you all in 40 minutes. general have been funded. The migrations work, contrib.postgres, multiple template engines and channels have been funded through various means. The DSF also employs a full-time Django fellow, contracts a full-time Django fellow, which keeps all the community things moving along and means that we actually have releases that happen when we say they're going to happen. Money is no longer a dirty word completely in open source. The trend is continued in the wider Django community as well. Tom Christie is now working full-time on Django REST framework, and lots of other languages are doing similar things. Earlier this year, with the support of the Ford Foundation, our next speaker published a 142-page report into the state of funding in open source. If you haven't read it, it is great. Long, but great. I am delighted to welcome Nadia Eghbal to talk about open source funding.
Can I not? I don't want it. I don't want it.
You haven't offlined it.
Yeah, I wanted to.
Yeah, you're going to need your way around.
Okay, just pray nobody texts me.
Go on. We'll get there. Wi-Fi,
So close.
Talk amongst yourselves. Yeah, let's go for the reliable option.
Ethernet.
This is what you learn, that if there's one presenter that you don't do a proper tech check for, it'll be the one that goes wrong. Hooray!
Hey, great. Hi, I'm Nadia. Really excited to be here. This conference has a special place in my heart because it marks a little over a year ago that I started diving into the world of open source and funding. And I know this because Russell, who was president of the Django Software Foundation at the time, was one of the first people I ever talked to about any of this stuff. And he mentioned this conference, and I was like, oh, cool, it's in Amsterdam. Sounds really awesome. Maybe I'll attend next year. And was secretly thinking, I have no clue what I'm going to be doing next year. So it's really awesome that I actually made it here and that you've invited me here. So I was asked to talk about open source and funding. Normally when I talk about this stuff, it's more around documenting the problem and the need, which is mostly what I did in that report. But a year into this journey, I get kind of bored about talking about the same things. So I thought we would spend this time talking about solutions. So that's what I wanted to write about when I was writing this talk. And when I sat down to write it, I realized this is actually a really hard talk to do because it required documenting all these very vague feelings that I had about this space. And specifically that I think when we talk about open source and funding, it tends to be around a specific project like Django. And this makes sense if you have a particular affinity to a project. But for me, coming in as an outsider to open source, I've been trying to think about how we do this for not just one project, but like 100 projects or 1,000 projects, and how do we do it all at the same time? And so this requires thinking about it in more of like a system building kind of way, which is a lot more challenging because you have to do all these things up front that don't seem to really obviously relate to money. And all that stuff is actually the hard part. And if you get all of that in place, then the money part is actually quite easy, which is why I titled this talk, Funding Open Source the Hard Way. So that's what I'm going to talk about. Before I get to all that, just starting with sort of like the problem, I think no matter how you feel about open source and funding, everyone can agree that you don't do it for the money.
nobody really got rich making off their open source project. Case in point, Django's projected revenue for this year is somewhere around 200,000. Instagram's projected revenue is somewhere around 3.2 billion. And this is actually not a real chart, obviously, because Instagram's revenue is 16,000 times that of Django's, and I couldn't even put it on this slide. And so if you look at that, you're sort of like, all right, clearly, if I were a venture capitalist, for example, and I looked at this, I would kind of look at the project on the left, and I would go, I don't know how that project's doing. I don't know if I want to look at that one. But the joke would be on me, right? Because Django is one of many open source projects that power Instagram. And they don't just power Instagram, they power a lot of other really big, really profitable companies. So my takeaway from looking at this is you can't use revenue to talk about open source's success. And so we find ourselves in this dilemma because on the one hand, you can say, open source is an incredible force for quality and community precisely because it hasn't been defined in market terms. Because if we were going to use market terms like revenue, most open source projects would never have stood a chance. And that's really cool on one side. But we have to balance that with the other side, where we say, as an industry, it's frightening how much of the infrastructure that we rely on is maintained by complete volunteers. And so we have to find somewhere in between where we're saying, this isn't about trying to turn open source into a billion-dollar business, or even say that it should be a business at all. But on the other hand, $0 in the system is also a bad thing. And at this point, you might be saying, well, I know that there's some funding in the system. I know some people make money doing open source work. What's wrong with the options right now? To which I would say, I think the problem is actually in how we're defining the problem. It's not about whether there's money in the system, but it's about whether there's access to money. And so what I mean by that, this got cut off. If you look at some of these examples here, if you are looking to buy a home, you go to a bank. If you're looking to start a business, you can go get venture capital. If you're a university, you have an endowment. Open source doesn't have that equivalent. Right now, it's all just like very ad hoc. So when we talk about open source and funding, it's stuff like crowdfunding, or bounties, or tipping. And these things are not really sustainable. They're about finding cash on hand in the moment. But if you're, for the next couple of projects, like where do they go to find that money? So the problem that I'm trying to solve, at least, is trying to figure out how open source can have access to institutional capital, not just these one-off crowdfunding campaigns. And if you're wondering, what can we do with all that money if we did have access to institutional capital the same way that other sectors do? There's two sides of it for me. One is about being able to take more risks, and the other side is more about maintenance. And so on the risk-taking side, right now, to be able to participate significantly in open source and make ongoing contributions, you need to have a high level of risk tolerance. That means that people who have debts or families, caretaking obligations, a lot of people simply don't have the time to do this when it's completely volunteered. And that means a lot of really good ideas might go unheard of. So venture capital would be the example of a sector where having that type of capital means that startup founders, people with ideas, can take really big risks. And the equivalent is not true right now in open source. A lot of these situations just require people to get lucky. So as an example of that, Ryan Dahl is the author of Node.js and has a pretty interesting origin story where he sort of just had this idea for where the world was going. And he decided to quit his job and work on the first iteration of Node.js for 6 months, unpaid. And after he got to this point, he decided to present the idea at JSConf in Europe. And afterwards, it was sort of just opening up to bids. And a lot of companies came up to him afterwards, and they were really excited about the idea, and they were trying to convince him to come over to their company. But when he kind of dug into the details, a lot of them were saying, I want to do this, can you do this as 20% time? Or hopefully we can build it into our product somehow and we can sell it. And he said that that just didn't feel right because it's an open source project, and that kind of wasn't the point. And Joyent was the only company that reached out to Ryan Dahl and said, hey, we don't really know where this is going. We don't really know how this ties into our business. But just come here, work on it full time, and we'll figure something out. And it was because Joint gave him that opportunity that we have Node right now. But like inherent in that story is that there are all these risks that he had to take. He was working unpaid on the idea for 6 months. A lot of people can't afford to do something like that. A lot of people are not just going to get lucky where he found one company that was willing to take a chance on him. And we're probably missing out on a lot of other really great ideas like Node that we just don't even know about. And if you look at other open source projects, surprise, surprise, a lot of them are started by employees, including Django. And that's not an accident. It's because when you're an employee at a company, you can build out some sort of like different or risky idea. And if you fail, it's okay, you still have your day job. So that's the risk side of it. The other side of it is being able to invest back into existing projects. And this is another defining characteristic and problem of open source right now, where you have a lot of fragmentation, people constantly starting new projects instead of investing back into old ones. Existing projects where they could use more money to make it better and keep up with the times, but that money is not available to them. Even this weekend, I've been hearing people saying Django is boring, and not being sure whether Django being boring is a good thing or a bad thing. And there's sort of like that fear about being boring because you don't know whether that means everyone's going to go use something else, because that's the way things kind of work right now. And so being able to have access to money is actually really important for maintenance purposes. And so the corollary being with in government, in the US, nearly half of the state budget goes towards maintenance of roads and not construction. And this is actually a third of what's needed to properly maintain roads, so it's not even enough. But the point being that if you did build a road, you didn't have to worry about, will I have access to money to be able to maintain this in the future? Or do we have to tear out the whole road and build a new one because that's all we have money for? So that part is really important. As an example of how this has worked really well, one of my favorite examples is actually the Django Fellowship, where someone is being paid full-time to do all the unglamorous maintenance tasks, things like maintaining a roadmap, or closing old issues, or reviewing other people's code, stuff that you can't just expect a casual contributor to do in their spare time. And it had a really measurable effect on Django's releases coming out on schedule. So if all this sounds good to you, now we get to the hard part, which is how do we actually get money into the open source ecosystem? This is sort of like how I think about the open source ecosystem. At the top, you have people who are producing software. They put out an open source project. Then you have users who could be individuals or companies that are using the project. And because open source is zero cost, they're able to have these outsized social and financial outcomes. And theoretically, those extra resources should be in part going back to the producers. So we're really talking about the resources part of this. And I kind of want to point out this isn't without historical precedent of this being a cycle that works. If you think about modern nonprofits, at least in the US, I don't know how it works outside of the US, but in the US, modern nonprofits as we know it have only been around for about 100 years. And they came about as a direct result of the Industrial Revolution. So you had all these people who became really wealthy because they had managed to optimize the production. And you had all these wealthy people, and then the public started criticizing them and saying, hey, you made a ton of money off of the backs of average citizens. Why don't you put some of that back into the rest of society? And it was because of that pressure that you had Andrew Carnegie and these other really prominent philanthropists saying, hey, they're right, we should be putting money back into the system, and that's why we have a nonprofit sector today. Before that, it just didn't really exist. And so what all that says to me is that the money is already out there, so that part has actually been solved, and that's a good thing. The resources are out there. It's figuring out where to direct it that's hard. And that's not just about building a business case or making the right pitch to a company, but it's actually how do you distribute those funds back into an entire system? It's actually really hard. And so the worst question that I get in my job right now is a company saying, I have a bunch of money, which project should I give it to? And at first it sounds like the best question in the world because this is all I ever really wanted. But if you actually think about, personally, how do you answer that question? You might see where the problem is. Because, at least for me, I started answering this question by saying, oh yeah, I know a ton of projects that you should give money to. Then I started thinking, well, why should this company care about those projects? How do I know those are the most important projects to give to? And so without having clear metrics, without having clear vocabulary to talk about funding needs, this is actually a really tough question to answer without being super subjective and super biased. So in order to get to that point, where we can say, here's where you should be spending your money, we have to figure out a bunch of things. And so this is my personal to-do list on how to properly fund open source. Requires thinking about who actually needs the money. So this is about metrics and analytics. Figuring out, of the projects that need money, what do they actually need money for? How do we actually fund them when you've connected a funder in a project? How does that money get dispersed? And then finally, who's in charge of funding them? Who's responsible for this? And I think when we talk about funding open source, we tend to focus on the fourth one, which is let's just figure out who has the most money and then ask them for money. But really, it's steps 1 through 3 that are really important because it's actually pretty hard for a funder to figure out how to give projects money. So I'm going to just kind of go through these. The question about who needs money is a metrics question. Almost every company that has said, I have a bunch of money, which projects do I give it to? Their next question is, have you come up with some sort of ranking or listing for projects that I can look at so I can figure out which projects are really in need? And every time I have to say, no, that doesn't exist, unfortunately. There is no methodology for ranking projects in need. And in fact, we don't even really have metrics for projects usage at all. And that's really unfortunate because a project needs, if they want to raise money or build a business case for themselves, they have to have hard numbers. An example of how this has not worked really well is the Yorba Foundation when they applied for tax-exempt status from the IRS. And the Yorba Foundation was this foundation that was formed around to support an open source project. And they applied to the IRS to be a nonprofit. And the IRS said no. And they said no for a lot of reasons. But one of the reasons why they said no was they said, companies could be using your open source project, people could be using your open source project. How do we really know that you're in the public benefit and this isn't just a commercial thing? And the Yorba Foundation replied to that by saying, well, we're like a tree, where a tree could shade a cafe or it could shade your average passerby. Open source kind of covers everything. And while that's a really nice metaphor, it doesn't really help build a concrete case. It would have been so much better if they could have said, we reach 20 million people and these 20 nonprofits, and therefore we're serving the public benefit. So numbers are really important. There are 2 types of metrics that I'm interested in. One is around the actual ecosystem. So how do projects all relate to each other? Who's using what? I think that Libraries.io is probably doing the best job of measuring this stuff. But yeah, it's all around dependencies. And an example of how this has worked in a project's favor is Heartbleed, which was this security bug that was found in OpenSSL. And it was, I think, the most widely publicized security bug ever in mainstream media. And if you remember the headlines from Heartbleed, they would say things like, 2/3 of the internet are in danger from this security risk, or 2/3 of the internet is being supported by 2 guys named Steve. It was really great headlines, and the media loved it. But the reason that OpenSSL was able to calculate that 2/3 of the internet depended on them was because they said they knew that Apache used them and they knew that Nginx used them, and they knew that those 2 things together equal 2/3 of market share. Therefore, 2/3 of the internet depends on OpenSSL. That's how it was calculated. But it was because they knew what the dependencies were that they were able to make that case. And it actually worked out really well for them in terms of getting funding. The other side is project level metrics. So within each individual project, how do you know how many people are using you? What does contribution activity look like? When we talk about healthy projects, what does that actually mean? And how do you track that in an objective way? I'm not going to go through all of these, but these are just some examples of metrics that I think are really important to projects. So if you're in the earliest stages of starting an open source project, you're probably interested in, like, are people using my project at all? And if they are, where are they coming from? As you hit the growth phase, you might be thinking about, well, now I'm starting to get some outside contributors. I want to make sure that that continues. So I want to track who's contributing to my project and how many of them are. And when you hit the mature stage, you probably are interested in both of these things. So you're looking at, is user growth continuing? Because if it flattens, that's a problem. And are there still like first-time contributors coming to my project? Because if not, then it risks getting stale. And as maintainers, are we responding to new contributors? Are we responding to new issues being opened? Are we doing a good job of like managing the community? The punchline for all this is that, unfortunately, it's really hard for projects to track this information right now. And it's not projects' fault. It's because like platforms like GitHub or your package manager or whatever don't do a great job of sharing these metrics back out or making it easy for projects to implement their own tracking. That's something that I'm personally interested in working on in my role right now. Second part is, what do they actually need money for? So if you imagine, you figured out which projects are in need, what do they actually need funding for? And this might be really obvious for people within open source, but it's not obvious to people outside of it, so it's just important to be able to convey that. Again, returning to just the idea of different project stages, you can see that like at different stages, you need money for completely different things. So in the earliest stages, it might be something like, I just need dedicated time to write code. This is like the Ryan Dahl and Joyant kind of story. It's totally fine to fund one person, spend all their time kind of proving out a concept. But as you kind of go towards like a more mature stage, you're probably looking for things like, I want to fund major new features or really boring maintenance tasks. As far as I understand, that's why this conference exists, and that's why like conferences like PyCon exist. It's to help pay for like core contributors to get together and work on these things. You're probably looking at things like community management, reviewing other people's code. You might hire people to do fundraising full-time. But depending on what type of project you are and where you're at, you have very different things that you need. And so this is something that works really well in startups right now, where you have like seed stage funding, which is completely different from Series D funding. And not only are you funding different things at those stages, but they're actually completely different funders. So you have venture firms that are focused on like seed stage funding and venture firms that are focused on like growth stage funding, and they're completely different because their needs are different. The third thing is thinking about if you have a funder and you have a project, how does that money actually get dispersed to the project? And so the question here is, should funders give to people or should they give to the projects? This is a hard question. There are pros and cons for both sides. If you're funding a project, it might be a lot more transparent that you're funding a project versus an individual. That money will live on if someone leaves the project. But on the other hand, it's like a ton of extra legal paperwork. If you're funding individuals, I think it actually can work really well because it respects the idea that like someone can come and contribute for a while and then they can leave and that's okay for a project. But it also leads to people who can market themselves really well, getting the most funding. It leads to these risky situations where if someone loses their funding individually, then the project is at risk. It's really important to figure this out though, because for other sectors, these kinds of things are already like really clearly defined in legal terms. So for like startups, no startup will be anything besides a Delaware C Corp if they want to get vendor funding. That's just like a known thing. If you're a nonprofit, you have to be a 501c3 in the US. Otherwise, your funder doesn't get a tax write-off. And so these things are actually like legally defined of like, here is how you give money to a specific project. Open source doesn't have that at all. I don't think that it needs to have like some sort of magical new legal entity that's created for open source. But we have to get really clear on when do you want to fund an individual, when do you want to fund a project, and what's required legally to get that in place. And so if we go down the project route, right now I think it's really important to focus on centralizing those efforts as much as possible. So not starting a whole new foundation every time you have a project that needs money, but trying to kind of join up with similar projects. So you can say, like, at the ecosystem level, you have like Ruby Together, JavaScript Foundation are examples of foundations that do this for their specific ecosystem. You can get even more generalized and say Software Freedom Conservancy or Open Collective are examples of fiscal sponsors where like the projects are not really related to each other, but they can apply to have this foundation sponsor them so they can accept donations. And they can go like super centralized, like the Linux Foundation, which not only serves as a fiscal sponsor for all these different projects, but also provides services like accounting and marketing and fundraising. And I think right now that makes sense because there isn't a whole lot of money in the room yet. So the problem is from like a company side, they don't want to fund like 20 different projects that are sort of related to each other. They kind of just want to give it to one place. And so it makes sense to centralize your efforts as much as possible. I think somewhere later down the line, it kind of you can imagine they're having like a lot of different organizations, but right now it's just like we're not really in that position. This is the area that I'm more interested in for the time being, is building up opportunities for individual grants. None of these existed 5 years ago. The options I put up here, 3 of them didn't exist 2 years ago. So like this area is actually like changing pretty quickly. Of organizations that are offering funding for people to work on projects as individuals. I think it just kind of makes sense right now because there's a lot less paperwork involved. You can fund contractors. The other reason why I think funding individuals right now makes sense is because we still can't answer this question of how do projects become financially sustainable. And this isn't like, say, the nonprofit sector where you can just, there's so much money out there, you can just like continue to find a foundation to give you money forever. We don't really have that luxury right now, so we have to figure out like how does a project actually live on in the long term. And if we don't really know that, funding individuals right now kind of makes sense because it can be sort of like this closed project that can be finished and then you move on to the next type of grant. This is a really hard question, and this is actually a question that even outside of open source, like internet-related philanthropy in general, they're really struggling to answer this question because almost by definition, if you're an internet business, you can make money. If you're something internet related that's not a business, then there isn't really a path to revenue. So what happens after the grant expires or runs out? So last question is the magical one of who are all these mysterious funders that should be giving us money? To which I would ask, who cares the most about protecting the open source commons? And I specifically say commons here because you have corporate open source, which effectively has its own sponsor. Something like Go, for example, originated from Google, is probably not going anywhere. They basically have a patron already. But who cares about like community-built open source, like Django, for example? Companies are probably the most obvious answer here. Smaller companies, or I guess like really any type of company, needs to know that these like zero-cost free resources exist if they want to start a new company. So it's really important to protect that commons. Bigger companies worry about their competitors having some sort of advantage over them if they release software, if they release their own version of open source software. Downside is that every one company is unfortunately beholden to their own business goals. So figuring out the company side of things requires getting companies to work together, which is a lot harder. But I think there's probably a situation where companies can be really good for some things, an individual company can be good for some things, and companies working together as a group are good for other things. Just to kind of think through a couple other possible funders, government is sort of like where we tend to turn to protect the public good. So government takes care of things like transportation or education or healthcare, depending what your government is. So some of that is good. The downside is that government has not traditionally really been a leader in technology. They tend to be sort of lagging, and so they might not really be that compatible with the rapid iteration that comes with open source software. The other big problem with government is that a lot of projects are not confined to one country or one government. And so you have the question of like, does the US government fund a contributor in Australia? Does that make sense? The other issue is around like security. So I've heard about projects where government has said, we will give you funding if you put in this convenient backdoor, or if you give us privileged access to security disclosures. And so like all of that poses a lot of ethical questions. Academia, similarly, I think is really great at thinking about, thinking about the long term. They have these endowments. They're not stressed about finding a business model or commercializing opportunities. But again, because they go at this really slow pace, they might not be super compatible with open source. I'm actually not super concerned about this last question because I think finding the right funder is like the last part of it. I think there could be some sort of combination where you have like government or academia funding maintenance and companies funding innovation, or we figure out how to get companies to work together. But I think without having all that earlier stuff in place, this part doesn't really matter yet. I like to, in my head, I sort of compare it to an open source project where if you imagine a contributor coming to your project, and if you haven't documented to them how they should be contributing, what they should be doing, why they should be there, that person's probably going to leave and you'll never have even heard of them. And so it's a similar sort of thing right now where if we don't have this stuff like clearly documented to a funder of why they should be doing it and how they should be doing it, they're kind of just going to leave right now. And I think that's kind of what's happening. That being said, I do think we're at the beginning of something pretty exciting. I'm going to kind of wrap up with a blast through this history lesson here. But if you kind of think through all the different phases of open source since it started in, let's say, the 70s or 80s, each phase is sort of like marked a different point in time. So in the beginning, it was about trying to get producers to contribute to open source projects in the first place and saying this is a valuable use of your time. And then we got to saying, all right, we have these interesting open source projects. How do we convince users that this is safe or secure or reliable enough to put into a commercial application? And then after that, it was saying, is there any real advantage to using open source versus closed source software? The answer was yes, and not necessarily for the reason that a lot of people thought, but it was because it was zero cost. And if open source costs nothing to use, then starting a company is really, really cheap. And now you have these really outsized financial outcomes. So now there's all this money floating around. And so we're really just in that last phase, which is saying, we got all the money, like we've proven out that open source is super useful to people and they want to use it and it's financially beneficial and people want to contribute to it. So everything else has been figured out. We just kind of got to get the last part in. I think this is actually a totally solvable problem. History supports it from all these other sectors. It's just a matter of figuring out how to get that whole machine working before we start putting financial resources into it. That's all I got.
I'm going to see your internet because it's
I'm done.
Okay, so we have a bunch of questions. The internet has been a little on the wobbly side, so apologies if anyone's been trying to ask a question and hasn't yet. So you said there were a bunch of people who'd come and said to you that, hi, I've got some money, who do I fund? What sort of scale are we talking about there? Are we talking about people with a few $1,000s, millions of dollars, billions of dollars?
Why do you want to know?
What are we missing out on?
It's actually been funny. Like, there's been a very wide range of things. There's been individual people. There's also been very, very large companies. And you can hear the opportunity shrinking, which is like the most painful thing for me to hear. They start with this really big idea of like, oh yeah, we want to like fund open source. That's a great idea. And then they ask the question about like, well, do you have a ranking of projects? And it's like, well, no. And then they're like, so what do they want money for? And you're like, well, a bunch of things. And then they're like, is anyone else doing this? And it's like, no. And then you kind of hear it shrinking and shrinking and shrinking, and then it's like something very small, which is unfortunate, which is why I feel really strongly about like, we got to figure out, be able to answer all those questions. And it's actually quite impossible right now.
So, to solve one of those problems, you were saying a lot about like usage metrics and being able to justify how we do things. Like we with Django have struggled for that for ages. It's like Andrew was saying earlier, he'd love to know that channels works at scale, and he has no idea who's using channels in production. Brew tried to solve this to some extent at some point by adding analytics in, and they got a huge amount of backlash from the community at the time. Have you got any ideas about how we can do that? Do we just suck it up and get people to register, or how can we do it?
Homebrew actually did this pretty successfully as far as I can tell. This happened maybe 6 months ago. They decided to start using Google Analytics, and they got the backlash as expected. But they made it so that anyone can opt out if they want to. They made it really clear that they're not tracking any sort of like individual level data. It's just this stuff in aggregate. I think it's one of those things where you have to say, all right, people might be unhappy for a little bit, but they'll get over it, just like a lot of new product features that people like to complain about. But I do think it's really, really important to have. I think that whole discussion on Homebrew is like documented on GitHub, if you ever want to check it out. But yeah, I think part of it is just like being really firm while also being clear that there's like a commitment to respecting privacy.
And obviously that will work well for, hey, I'm a Django-sized project. I've got this huge user base that I know must exist somewhere. I just need to know how big it is. What sort of metrics can you use if you're a startup project, if you're a smaller thing that you're trying to bootstrap yourself?
That part is a lot harder. I think that's honestly on GitHub, for example, or package managers, or let's say, to be able to provide that information back. Right now, it's just really hard to get. I would say in the short term, being able to at least document stories of people who use your project, especially if they're companies, is really useful. So even putting a call out and saying, like, hey, if you use this and you have a testimonial you want to add, just like let us know. At least anecdotes can help build a story around usage.
So sticking with those sort of startup level projects, what have you met funders who are specifically interested in working with those kind of projects? What is motivating them to throw money into a mystery black hole?
I don't think that the funders that I've talked to at least have not been, I think they don't know what they want yet. They know that the idea sounds shiny and cool to support open source, and I think that's really an awesome start to say, at least recognizing that this is an important space. I think they're still looking for a lot of direction of like, how do I know which projects are important? Can I go to sleep at night knowing that I put my money towards the most important thing? And I think that's where things get a little bit squirmy. So, yeah.
I mean, it's quite easy to put your money into a startup business that doesn't work as well. So
right.
Some people just like the risk, I guess.
It's true.
Do you think there's a place for some sort of open source funding platform or some company to step in and create such a platform that would take money from patrons, distribute it according to, some sort of metrics and what the company's interested in, or maybe to help bootstrap new projects through this communal fund?
Yeah, the closest thing to that exists right now is Open Collective. I would highly recommend that if anyone's interested. So they make it really easy to set up, being able to take money without having to go through all the legal paperwork. So they have like a ton of open source projects on their platform. And then they also have a general fund that people can donate to, and then they distribute that money to other projects. It's still new and growing, but they seem to be doing something really well.
What are the risks of the more institutional money, aside from the small number of donors, and if those donors dry up? Is there still kind of a strong tendency that lots of donors and lots of smaller donors, lots of medium-sized companies and smaller companies is a good idea? Or should we be focusing effort more on hitting the big boys with a big amount of money?
Is this for like a specific project foundation or?
Just in general.
In general. I think on the foundation level, think about diversifying, it makes sense. So Ruby Together, for example, has actually limited the amount of money that any one company can give because they don't want to be in the situation where one giant company pulls out and then suddenly they have no money left. So they've been thinking a lot about risk diversification. I think it kind of also just depends, again, on the stage of project. So if you know you're going to have money to work on something for a year and that's all you really need, that's different from getting hired by a company to work on an idea into perpetuity, and you don't know when that's going to end, then that's almost certainly guaranteed to be a situation that's not going to end well.
There's a few questions around sort of, for want of a better word, forcing the issue. So, we need funding. Should the licensing reflect that you need to push funding back in? Should we have like more GPL-style licensing or that kind of thing that creates an obligation on users to start doing this, basically going down the sort of like legal brute force route? Do you think that's a good idea, or should we be sticking more to the philanthropic direction?
I think all experiments are good right now, so I don't want to discourage anyone else's ideas. If you're asking for my personal opinion, GPL and Copyleft has been trying to do this, and the enforcement side has actually been really legally murky and not clear of like, can you enforce when someone is using GPL in a way that it wasn't meant to be used? So I don't really know that this is a license question. I think it's really much more of a cultural question. And I think I'm biased in that direction just because I think people are interesting. But like, I think this is more of like people even having an awareness that something is an issue and then being motivated to change it works better than kind of like the stick of enforcement.
So if we're trying to build that sort of culture where we've got the Instagram scale companies or the Facebook style scale companies or whatever pushing money back into open source that they're using, how can we go about trying to create that culture?
I think
kind of a talk.
Yeah, that's kind of the point. I mean, being able to like share stories out, I think is just like really important. I think it was just sort of like humanizing what's going on behind the scenes of open source projects. A lot of people just see it as, they land on a project, they grab the code and they leave, and they don't always know what else is happening. Or if they have a problem, that's the first time they'll start digging around and saying, oh, where can I like open an issue and complain about something? They just don't have the same context. That's something that has just really struck me from the beginning of like, you can have people who are software developers or people who work in software all day long who just have no idea what's going on inside open source. So I think like a big part of it right now is just around like being able to like build those bridges as much as possible, share stories out, like have it like front and center on your like projects page of like, here is my face or whatever, and like, this is like, I work on this project, and just trying to like bring the human side to it as much as possible.
When you've been talking to people who are wanting to run these projects, or wanting to fund projects, has it always been that people are looking to do the stuff that's most relevant to them? Is it very much so like, I use this project, therefore I want to fund that project? Or I want to build this thing that uses this, therefore I'll fund that? Or is there actually quite a lot of just like general ecosystem support that goes on?
Yeah, I think when it starts, it tends to be the general ecosystem idea of, I want to have this sort of goodwill in the community and I want to support open source. And then when you get down to, well, then you should do this, then it's like, well, actually, I really want to support the projects that I use, which again kind of makes sense if you're a company. I can't fault them for that either. So yeah, I think a lot of it ends up being very self-interested, and that's kind of like where the problem lies.
Cool. So apologies to anyone who's been trying to ask questions with the dodgy internet. Nadia will continue the conversation in the Slack channel. Thank you very much.
Thank you.
How appropriate. So we're running slightly ahead of schedule, but we're going to press on. When non-technical people come up to me, or even people who I work with and say, oh, I kind of do the open source thing. I work on this thing called Django. And what's Django? What does it do? Over the last few years, the easiest way I've found of explaining it is, oh, it's the web framework that powers Instagram. It's a big brand name, everybody knows about it. Yeah, there's lots of other things that use Django as well, but everybody's known of Instagram. It tends to get a big wow moment. It's like, wow, really? That's great. And we haven't had much contact with Instagram for a while, until recently when one of our friendly core team got employed by Instagram to work there. And after some internal wrangling, I am delighted to welcome Carl Meyer to tell us all about Django at Instagram.
Thank you, Mark. I feel like as the last talk of the day, I should start by, I feel like I need to say that this conference, every detail of this conference just exudes care and thoughtfulness, and it's been amazing. So thank you to the organizers. Okay. So yes, Instagram. You may recognize us from Nadia's talk. I'm Carl Meyer. I've been a Django core team member for about 6 years and an Instagram employee for about 6 months. This is me on Instagram. I'm going to talk today some about how Django was part of Instagram's growth and how we still use Django today and how we make Python and Django work for us at scale. I know this is the 5th hour-long deep dive talk of the day, so I've tried to do a layered slide deck. For those of you who are completely asleep, there are an adequate number of cat photos, so I hope that wherever you are in your day and your sort of mental process, there will be something here that you can appreciate. So what's Instagram? We are officially about an app for capturing and sharing the world's moments. This means, of course, cat photos. Lots and lots of cat photos. Every day, Instagrammers upload about 95 million photos and videos to Instagram. This means in less than 2 weeks, we get enough photos that if you printed them out and lined them up side by side, you would reach the moon. And these are not just any cat photos, these are truly excellent cat photos. People really like these cat photos. Roughly 4.2 billion times every day, someone likes a photo or a video on Instagram. All in all, our data store currently stores 2.3 trillion likes. That's roughly 1 like for every person on Earth for every day of the year. I could go on with these analogies. It's kind of fun coming up with them. Lots of zeros. The point is, we don't just have cat photos, we have cat photos at web scale. And every single one of those 95 million photos and videos and 4.2 billion likes every day goes through this guy. But of course, 4 billion daily likes is way too much to expect just one jazz guitarist to handle all alone. So we have, I'm not supposed to give exact numbers, but tens of thousands of Djangos, servers running Django. Although internally, we don't call them servers, we don't call them the web tier, we call them the Djangos. Feel free to join me in visualizing this as a fleet of tens of thousands of mustachioed jazz guitarists. Before we get too deep into the current state of things at Instagram, I want to step back and do a quick run through Instagram's history. Starting back in October 2010, when Instagram began, coincidentally, the same month that I joined the Django core team. I'm not sure what that says about my life choices versus some other life choices, but anyway, October 2010, when we had not tens of thousands of Djangos, but I think just one. I talked to Mike Krieger, the co-founder and CTO of Instagram, about the early experience using Django. His first comment was that it was super easy to get started with. Didn't require a lot of decisions, didn't require a lot of setup, made testing easy. All of these things allowed Kevin and Mike to build the first version of Instagram in about 2 weeks, and in only a couple months get to their first 1 million users. During those first few months, they of course hit some of their first scaling pain points with Django, probably things that many of you have also encountered, like for instance, 404s or 500 errors, sending an individual email for every single error. If I'm not mistaken, this is an archival photo from the early days of Django at the Lawrence Journal World. Maybe Jacob or Adrian can explain why Simon was so excited about the emails. Anyway, apparently at one point, Mike and Kevin were literally getting an email for every browser request that came in to Instagram.com because they had a missing fav icon. So every request generated a 404, and every 404 generated an email. Right around this time, in fall 2010, is when Russ committed logging support to Django. Although the default behavior of Django is still to send an email for every error, at least it's now much easier to configure. So I think we can wave our hands a little bit and call this one fixed. Thank you, Russ. While I'm on this slide, I should also mention the easy testing that Mike referenced a couple of slides back. As of the Django 1.3 timeframe, that was also Russ's work. So thanks, Russ, for that as well. Also, like many of us, I think, Kevin and Mike had to hack around the admin, wanting to do a count star of every row in a very large table in order to provide pagination. in 2010, they had to hack around this with monkey patches. Today, in Django 1.8, we now have a meta option to disable this, so I think we can also call this fixed. Of course, managing static files was a pain. I think it still is, but around this time is when Yannis contributed contrib.static files to Django, which improved the situation quite a lot. So thank you, Yannis, for that. Like many of us again, Instagram had trouble with Django's transaction management, which used to be pretty bad. It would wrap reads in unnecessary transactions. It would do extra round trips to the database. It would leave Postgres connections hanging in an idle in transaction state. For those of you who use Postgres, you may remember that. But of course, since Django 1.6, this one is also fixed, thanks to Amrik. By June, July 2011, Instagram had about 5 million users. At this point, all of these 5 million users, all of their data was stored in PostgreSQL and accessed via the Django ORM. They did use vertical partitioning by model to allow storage in multiple databases. So there was a database for users, one for media, one for likes, one for comments, etc. This kind of vertical partitioning by model is actually very easy to implement using the Django ORM's multi-DB support and routers. And that's exactly how it was done. This isn't the exact code, but it's the moral equivalent, updated a little bit for some API changes in modern Django. But it's quite easy to establish a mapping of model to database name. I think in Instagram's case, there was also some cases where it was an entire app mapped to a database. But you can easily return the correct database from the DB for read, DB for write methods, and then only allow relations between models on the same database. Of course, you have to do some fake foreign keys. You can no longer have referential integrity between models on different databases, but it's not that hard to implement. So it made sense as a first step for scaling the ORM for Instagram. Shout out to Alex Gaynor for implementing MultiDB. And once again to Russ for mentoring that project. So the Django ORM was managing 5 million users just fine, but at a certain point it became clear that the vertical partitioning wasn't going to scale. There were just too many likes to store in one database. So I'm going to start saying we. It's a little weird because I joined Instagram 6 months ago, so none of this involved me, but it's simpler if I can just say we. So we picked a pretty typical horizontal sharding scheme to deal with this problem. So you take all of those many likes, too many for one Postgres server, and you split them up into a whole bunch of logical shards. In our case, we split them up. We started with likes, and we split them up according to the user ID of the user whose media, whose photo or video had been liked. So we split them into, I have 10 here for illustration, but actually several thousand logical shards. And we map these to Postgres schemas. If you're not familiar with Postgres, a schema in Postgres is not like the SQL schema of the table. It's more like a namespace that can contain tables within it. So each logical shard corresponded to a Postgres schema. And you can, of course, have multiple Postgres schemas on a single physical server. So this allowed a mapping from logical shards to physical servers that meant that the number of physical servers could grow over time as traffic grew. Without having to rebucket the data. It just required updating the mapping from a logical shard to a physical server. So horizontal sharding like this is a little harder to implement inside the Django ORM. Today, there are a couple third-party apps, reusable apps, libraries, that will implement something like this using some complex model-based classes and manager-based classes. In 2011, those didn't exist. In fact, some of them are based on some of Instagram's work that was publicized in blog posts. So that wasn't available as an option. Also, Instagram wanted a solution where they could take a set of IDs that might correspond to objects contained in multiple different shards, fan those out with asynchronous queries, get results back, put them all together into one result set for the application. And that seemed especially difficult to squeeze into the ORM at the time. So rather than using the Django ORM, Mike sat down and wrote his own minimalist sharded ORM, committing the first version of it with the only appropriate commit message. Work in progress. This ORM was really a fairly light wrapper around raw SQL. It included a lot of code that looked like this. find the right shard, get a connection to the shard, put together some raw SQL, and send it off to the database. This new storage layer was not the end of the Django ORM at Instagram. Initially, it was only used for likes. It took over 2 years for all of user data to slowly be migrated from the Django ORM into the new sharded system. Even today, we actually still use the Django ORM for some of our internal admin tools. But you could say that this commit in 2011 was the beginning of the end for the Django ORM at Instagram. Also, just kind of an interesting side note, Instagram engineers at the time came up with a scheme for sharded unique IDs that's been much replicated since. One of the issues with sharding, of course, is that you can no longer rely on a simple database sequence or auto number in MySQL to generate your object IDs, because obviously each individual database is going to have its own sequence or its own of IDs, and so you'll have clashes between them. So the scheme that Instagram settled on was beginning with a timestamp, then a unique ID for the shard, and then a unique sequence ID tacked onto that. And this gives you unique IDs that are also preserve the property that if you order objects by their ID, you get a chronological ordering, which was important to Instagram. And this also can be implemented in Postgres as a stored procedure, and so you can use it as a default for the ID field in your table, just like you would an ordinary sequence. The new sharded ORM worked very well, but it did have its problems. Among those problems was Justin Bieber. Justin Bieber was an early adopter of Instagram, and so the new sharding scheme grouped everything by user. So all of a user's media, and all of the likes on their media, and all of the comments on their media were all stored in the same shard. This made sense for the data access patterns, but I think you can guess what happens next. So the Biebs posts a photo. Everyone in the world roughly stampedes to like and comment on that photo, and you have a very hot Postgres database on your hands. So for a while there are still war stories told today about how for quite a while, every new Biebergram constituted a genuine ops emergency, and memorizing Justin Bieber's user ID was actually a condition of employment at Instagram, because you needed to be able to do things very quickly. So this problem was eventually solved, not with any radical changes, but just by a lot of remapping of logical shards to physical servers to make sure that at the very least, Justin Bieber did not share a physical database server with any other popular account, and also some read caching techniques. Anyway, by the following April, Instagram had passed 40 million users, April 2012, and that's also when we were acquired by Facebook. So up till this point, Instagram had been hosted on Amazon Web Services. Once we were acquired by Facebook, there began an effort to move off of Amazon Web Services and onto Facebook infrastructure, which we did. By early 2014, everything had been moved into a Facebook data center. And then a month or two after that, Facebook conducted one of their regular disaster recovery exercises and cut the network to that data center. So everything had to be moved from that data center to a different Facebook data center. And nobody really wanted to repeat that experience a third time. And of course, we also wanted Instagram to be itself disaster ready in case something would take out a data center. So that began the effort to move Instagram to a multi-region or multi-data center architecture. One of the big challenges of this move was caching. So previously, in a single data center architecture, like many Django apps, Instagram's Django application managed caching manually. So a request comes in for some data, we go see if it's in memcached. If it is, great. If it's not, we have to go to the database, we get it back from the database, we put it in memcached, we send it back to the user. A write comes in, we have to go invalidate the cache, then we send it to the database, etc. Moving to a multi-data center architecture, we can use Postgres replication to take care of syncing up the main data store between the centers. But we also have to figure out how to sync up the caches. If we just leave independent caches, what happens is, well, of course, we do need a cache in each region because for latency reasons, you can't go across data center to talk to memcache. But if we just have separate memcache in each region, if Pat posts a photo in data center A, and then Jan posts a comment on that photo over in data center B. Over in A, memcache still has cache that there are no comments on this photo, and so Jan isn't going to see that comment for quite some time. That's a problem. So the solution we eventually came up with for this involved using PGQ, which is an implementation of a queue inside Postgres, to actually keep a queue of cache invalidation events inside Postgres. And then that would get synced as part of Postgres replication, and then a separate cache invalidator process in each data center would read from that queue and invalidate the appropriate cache entries in each data center. The point of all this really is just to say that this stuff is hard. And while we were busy trying to figure out how to solve these problems for our Instagram architecture, in the meantime, Facebook had built Tau. Tau is, now here I have to read from my notes, an eventually consistent distributed graph object store and write-through cache. It's built on top of MySQL and Memcached, and it had already been proven by Facebook at more than 10 times Instagram's scale. I won't get into a lot of deep details here on the design of Tau because it's a little far afield from the topic of Django. If you're interested in the design of big data stores, there's a white paper and a blog post. If you search for Facebook Tau, you'll certainly find those. Effectively, Tau takes all of this complexity. The complexity doesn't go away, but it wraps it up into a service that somebody else maintains. So it's not our problem anymore. So effectively, with Tau, the picture from Instagram's perspective could look like this. We just ask for the data we need and send the data we need to write to Tau, and all the caching, all of the multi-region stuff, all the sharding stuff, all of that is just handled invisibly for us. I'll talk just briefly about what the data model looks like for Tau. It's a graph store. So for a typical Instagram case, let's say Jan follows Pat. So we have two nodes, Pat and Jan, and edges between them, follows and followed by. Then Pat posts a photo, and so we have another node for the photo and edges posted by and posted between Pat and the photo. A comment, another node and a couple more edges, and then Pat likes the comment, and we get a couple more edges there. That's really all there is to Tau's data model, and the operations that are exposed, as is typically the case with data stores that have to operate at very large scale, are very few. You can basically count them on one hand. You can get a node by ID, you can get a range of nodes by creation timestamp, you can ask for all of the outgoing edges from a node, and you can get the edges between any two given nodes. And that's effectively all that you can do. As it happens, this data model fits Instagram's needs pretty well. So in 2015, we began the process of migrating Instagram from Postgres over to Tau. And I think just about a month ago, we decommissioned our last Postgres SQL cluster. This cat is here in honor of Postgres to express my personal sadness. But many people at Instagram loved Postgres, and we're very sad to see it go. But on the other hand, Instagram's data access code is very much simpler now. Nobody was really sad to see all of that hairy caching and sharding code go. So in June of this year, we hit 500 million monthly active people on Instagram. Shortly after I joined, I'm sure it's not a coincidence. So this summer, we finally decided that it was time to fix the fact that we were still running on a heavily patched Django 1.3. So our approach to this problem was completely wrong. If you visit the Django documentation, it will tell you that if you want to upgrade Django, you should go version by version, so 1.3 to 1.4 to 1.5, and at each step, you should carefully read the release notes and check your app for where you're doing something that needs to be updated. And that's a great process. I've done it before. If we had done that, I'm not sure we ever would have actually gotten around to the upgrade. So instead, this is what we did. We went straight from 1.3 to 1.8, just installed it, and then ran the tests. And look, some of them failed. So we fixed things. And then, so rinse and repeat, basically, for several months. Obviously, also, this is far too risky and large a change to either land in master in one go or to deploy all in one go. That'd be far too risky. So rather than being able to simply convert the entire code base to Django 1.8 compatibility, we had to convert the code base to simultaneous compatibility with both Django 1.3 and 1.8. So as you can imagine, that led to some pretty ugly version conditionals and compatibility code, and in some cases, entire 30-line methods copy-pasted, and here's the Django 1.3 version, and here's the Django 1.8 version. So it was not pretty, but it worked. And once we had the entire test suite passing, ran it some on development servers to flush out anything that wasn't caught by the test suite, pushed it to some pre-release boxes, and then started rolling it out cluster by cluster, watching carefully for regressions, performance regressions, or errors, or anything like that. And once we were confident that it was working and we had it rolled out everywhere, I got the very satisfying task of going through in one big diff and ripping out all of the Django 1.3 compatibility hacks. So now we are entirely on 1.8, and we couldn't go back to 1.3 if we wanted to, which we don't. So we only really had 2 performance regressions to speak of with Django 1.8 compared to 1.3. Does anyone want to guess where in Django we might have experienced a performance issue going from 1.3 to 1.8? We don't use the ORM anymore. I think if we did still use the ORM, this whole process would have been more challenging. Swappable model? Replaceable templates? Oh, no, not really. We actually already use Jinja, so there wasn't a lot of difficulty there. Actually, the 2 issues that we ran into both related to internationalization. The first one, somewhere between 1.3 and 1.8, I'm not sure exactly in which version, but somewhere the feature of internationalized URLs was added. So you can actually have URLs that change depending on the active language. It's a very cool feature, but as a side effect of that feature, Django now will compile every URL regex in your project once per active language rather than just once, period. We have a lot of URLs and also a lot of active languages. And so even though this is something that only happens at startup, our uWSGI processes restart often enough that this was a serious issue for us. It's also something that I think we were able to fix it pretty easily with a monkey patch, and I think Django could be smarter here, particularly in the case where you don't actually use the internationalized URLs feature. So I plan to look at this at the sprints. Similarly, somewhere along there, Django gained the ability to load translations from any installed app instead of just from one directory, which is, again, a great feature, especially for reusable apps that want to ship translations. But for us, we don't keep any translations in our installed apps, and we have over 100 installed apps. And it turns out that the way it currently works, for every installed app, even if there's no locale directory there, Django will ask getText to load the translations, and getText will create a null translations object and do a bunch of work that really there's no point in doing. So again, that was a problem for us, and again, I think it could be fixed, and I plan to look at it in the sprints. The third monkey patch that we still carry is actually not a new one in 1.8. It's something we carried over from 1.3. So Django's lazy settings implementation means that every time you access settings.foo, it actually goes through a Python getattr function call because it's dynamically going down to a wrapped object to get the actual value. It turns out that at scale, Python function calls are pretty slow compared to attribute accesses. And so this was a problem. So this is the silliness that we do to take care of that. At startup, we loop through every setting, and we force it into the dictionary of the outer wrapper settings object, so that every future access of a setting will just pull it directly from that object's dict as a normal attribute access instead of going through the whole lazy setting thing. This probably breaks the override settings decorator, which we don't use. We just use mock.patch, so that's not an issue for us. So this probably maybe breaks other things too, so I can't really recommend it, but it was very effective for us. We had some views that accessed a setting in a hot loop where we saw 10% CPU instruction gain just from doing this thing. I think this would be a little trickier, but I think it's also probably fixable in Django. The whole settings implementation is a little bit complex for what it actually does. So the conclusion of all that is with a few monkey patches, we're now on Django 1.8, and we experienced effectively 0 performance regression from 1.3 to 1.8. So that's, I think, a credit to the Django team, really. Again, if we used the ORM, that might have been a different story. I don't know. So that brings us up to the present. And let's take a quick look at what the Instagram stack looks like today. If a request comes into Instagram, the first thing it'll hit is Proxygen, which is a Facebook-developed open source HTTP load balancer and proxy server. And it'll actually go through several layers of Proxygen, first at the edge routing, then the data center, then the cluster. Eventually, it'll hit a Django, which, as I mentioned, we run under uWSGI. And then Django will talk to a number of different backend services. Tau is the primary data store. We use Cassandra. Used to be Redis. We migrated at one point from Redis to Cassandra. But Cassandra is where we store counters, scene state, various other things that fit the Cassandra data model well. Everstore is a Facebook large blob store or file store where all the actual media goes. And then we do also put tasks into RabbitMQ for Celery for delayed execution. So we've already looked a bit at how we scaled the backend data store. So I'm going to talk a little bit now about how we work on performance of Python and Django today. First thing to know about performance is that the word doesn't actually mean anything. Or more accurately, it doesn't mean anything useful until you can attach it to a specific metric that you're trying to optimize. So what do we want to optimize? We would like to have more happy Instagrammers posting cat photos, and we would like to do it with fewer servers running Django. As Adrian can tell you, jazz guitarists don't come cheap, so we need to be efficient there. This suggests some possible metrics, for instance, cats per jazz guitarist. Unfortunately, both cats and jazz guitarists have a tendency to wander off when you're trying to measure them. So instead, we measure users per server. So the numerator here is straightforward. What we measure is active last minute in our peak minute of daily traffic, how many users were active. The denominator is a little trickier. Obviously, we trivially know how many Django servers we have in production, but that's not a responsive or useful metric. I mean, if I push a change that makes everything 10% more efficient, we're still going to have the same number of servers in production. What we really want to know is not how many servers we actually used to serve our peak minute traffic. We want to know what's the minimum number of servers we could have theoretically gotten away with, given our current efficiency, if the servers were fully utilized. So we determine this experimentally in production using the Linux perf tool. This is some C code showing basic usage of perf. Perf is a tool that allows you to access hardware counters on Linux, one of which is a CPU instructions counter. So using this, we actually wrap this in C types so we can access it from Python, and then we instrument our Django uWSGI workers with this so that we can measure how many CPU instructions are used by Django to serve a request. And then what we do is, in production, we take a server, or actually a set of servers, and we, using our load balancer, we push more and more traffic in their direction just until they start to fall over, and then stop. And we have some metrics where we can tell when a server is under stress and about to start failing requests, so we stop before it gets to that point. But you can see here a traffic chart, or actually a CPU load chart, showing in green a typical server in our fleet, which will have sort of a curve of the daily peak traffic. And then in yellow, one of these servers that's under our load testing, where we keep the CPU usage pegged as high as we can go without falling over. What's interesting about this is, although we're measuring CPU instructions, it's not actually, that doesn't mean that we only care about CPU instructions on the server, because a server may fall over for a different reason. It may fall over, depending on how we've got things balanced, it may start to fall over because it runs out of uWSGI workers because we don't have enough memory to run more uWSGI workers. And so we get too many requests, they're too slow to process, and there's no uWSGI workers on the server free to handle more requests. So that yellow line is not necessarily at like 100% CPU utilization. There's a number of possible bottlenecks that we could hit, but regardless of which bottleneck we actually hit, this gives us not a hypothetical or extrapolated or theoretical, but an actual experimentally determined measure of how many CPU instructions per second we can expect one of our Django servers to use in actually serving requests to users. And then, of course, we can also determine how many CPU instructions per second our entire fleet uses and divide that by our number of users to get CPU instructions per second per server over CPU instructions per second per user. And this is what we actually measure. This is our top-line metric for all our efficiency work. Now, of course, this is what we measure, but we can simplify it arithmetically, get rid of the common CPU instructions per second factor, do a little inverse flipping, and get back to exactly what we wanted to measure, which is how many Instagram users can we serve with a fully utilized server. You might wonder why we choose CPU instructions per second as the sort of arbitrary, like, common factor here, as opposed to something like requests per second or CPU time or other things that are commonly measured. One reason is that saying a server is a simplification. We actually run a number of different generations of CPU hardware in production with different capabilities, and CPU instructions per second is a metric that we're able to normalize across all those generations of hardware. The other reason is just it's a very fine-grained metric. Requests per second is much more coarse-grained. Not all requests are created equal. So CPU instructions per second gives us more fine-grained gradations there. We call this metric app weight. As you can see here from the green box, when I took this screenshot towards the end of October, we were at 18% improvement in app weight from the beginning of 2016. So this is our primary focus, is optimizing this metric. Personally, I think app weight is kind of a weird name because, like, it sounds like more app weight would, like, weigh down your servers and you'd want less app weight. Actually, higher is better for this metric because we're measuring users we can handle per server, so we want more, not less. So up is good. If I could name it, I'd call it Django power, because it's like measuring the power of one Django. But I don't get to name things. I don't think I've been there long enough. So one cool thing about this metric is that effectively it measures the definition of scalability, right? Because scalability means something a web service is scalable if, as your traffic grows, your hardware needs scale linearly or sublinearly with your user growth, right? If your hardware needs go up superlinearly with your user growth, that's the definition of not being scalable. And that's exactly what app weight measures. If app weight is constant, that means that our hardware needs and our user growth will track linearly. If we improve app weight, our hardware needs will actually be sublinear with our user growth. Yeah. We also do continuous deployment at Instagram. If I make a change to the Django codebase and commit it, within about 10 minutes, it will be deployed to all of our tens of thousands of jazz guitarists and serving 4.2 billion likes per day. We do an average of 30 to 50 deploys per day. Each one usually contains somewhere between 1 and 3 commits. So with engineers pushing this many deploys per day, how do we keep app weight under control? So with a large team, the key is not only to have good metrics that you can measure, but also to make them visible to engineers whose primary concern is pushing cool features. So they need to have good visibility into the efficiency metrics. Our primary performance data set is something we call DynoStats, which we gather from a normal Django middleware. It's a little more complex, but looks very much like this. We sample a fairly small percentage of production requests. We have enough requests that we don't need to measure all of them. We can sample and get good data. If DynoStats is enabled for a particular request, we measure a number of things at the start of the request: the CPU instruction counter, wall time, CPU time, the RSS memory usage of the process, a number of other things. And then as the response goes out, we collect all that, check all those counters again to get the change, and send that off to Scribe, which is Facebook's data and statistics pipeline project, also open source, you can look it up. We send that off along with a bunch of request metadata like the URL path, the view, the HTTP response code, anything you can imagine about the request gets sent off along with that data. So that allows us then in our data analysis system to slice and dice that data in all kinds of different ways. Here we see CPU instructions by view over time, and we can see very clearly where a regression happened. So if a regression like that happens, we'll get an alert. If a regression either in CPU instructions or wall time. And so how do we find the source of the regression once we get an alert? So the most obvious is to look for a code rollout that matches up in the timeline. Usually that allows us to narrow it down to 1 or 2 commits. And that's if we're lucky. Now, we push a lot of code that's hidden behind feature gates. And so often the regression doesn't actually jump up nice and neat like that. And often it doesn't correspond with the code rollout because it actually corresponds with somebody turning up a feature gate slowly to expose the code path to more and more users. So we also can show those feature gate changes on our timeline and try to match them up with the regression. If we can't immediately find an obvious cause using one of those techniques, we dig deeper using a tool that probably many of you have used, cProfile, from the standard library. So in the past, when I've used cProfile, I've typically run it in a controlled environment on my development server or my laptop or whatever. But for us, getting realistic data anywhere other than production is pretty hard. So we sample cProfile in production as well. Again, we do it using a middleware, which is very similar. We sample an even smaller percentage of requests because cProfile has more of an impact. When you instrument with cProfile, it does slow things down. So we don't want to do it on a lot of requests, but we do it on enough to get the data we need. And we just create a cProfile profiler object, attach it to the request, enable it, and then on the way out, we disable it, generate the statistics, and send them off to Scribe. And that allows us to then generate tables like this, among many other things. I had to cut off the leftmost column with the function names here to get it on the slide in a readable way, but each row in this table is a function in our code base, and we can do time-based comparisons. So like if we know when a regression happened roughly, we can say compare the time before that to the time after that. And in this particular case, we can see that one function is now using 70% more CPU instructions than it did previously. So that allows us to very quickly narrow down to exactly what the source of the regression is and where to look to fix it. So this is a key tool, and we use it daily. We also pipe cProfile data into gprof2dot, which will generate graphs like this, which show the hot paths. So again, we can see quickly where we need to focus optimization efforts. And as yet another step in the aim to make this data visible to every engineer, not just those of us who are focused on efficiency, in Fabricator, which is our code review tool and code browser, also open source, some of you may use it. If you hover over any function, you get a pop-up hover card, which will tell you what percentage of our global CPU that function consumes, exactly how many servers would, in theory, be needed solely in order to power that function, how many views, or which views use this function, which other functions call this function, and you can also drill down to see what does this function call that's using the most CPU. So again, the goal to make this data very visible to every engineer. One interesting thing about cProfile that I didn't learn until I went to Instagram is that you may have noticed, or if you've used cProfile before, you may have noticed that I keep talking about CPU instructions. Normally, that's not what cProfile measures. cProfile, by default, measures CPU time. But you can actually pass any function you want into cProfile, any function that returns a number, and cProfile will measure that. It will consider that the clock. So we don't use the default cProfile timer at all. We use 2 different timers, one that uses perf, as I showed before, to get CPU instructions, and another one that actually has no relationship to time, but actually measures RSS memory at the beginning and end of each function call. So you can use cProfile to measure anything, not even if it's not time-related at all. Another interesting side note about cProfile, it doesn't record the whole call stack. What it records is caller-callee pairs. So if you have, say, 2 functions A and B that call functions X and Y, cProfile can tell you that of all the calls to Y, 10% came from A and 90% from B, which is great. That's very useful information. But if X and Y are both decorated with some common decorator that wraps them, cProfile ends up seeing a picture like this instead. And all we can find out now is that 100% of the calls to Y came from cached property.get, for example. So we lose that useful caller-callee information. It would be nice if there was a feature in cProfile to deal with this. There isn't, so we actually run a custom fork where we've hacked up the C code to tell it to ignore certain common wrappers and just essentially pretend that step in the call stack doesn't exist. So we essentially trick cProfile into seeing this picture again. If the wrapper, the decorator wrapper, used a significant amount of CPU itself, this would give us misleading data because we're essentially rolling up all of the wrapper's CPU instructions into the caller function. But in general, these kinds of decorators don't tend to use a lot of CPU internally. So it's not particularly misleading, and it gives us better caller-callee associations. All right, enough on cProfile. So what do we do when we find an efficiency regression? We've narrowed it down to the source, and we need to fix it. I had a ruder version of this one, but I took it out. Many of the cases are simply silly things that should be fixed, like an n-cubed algorithm somewhere, or concatenating a bunch of strings in a tight loop, or fairly obvious things that once you see them, you go, oh yeah, that's pretty clear how we can fix that. A close relative of the first one is not doing useless work. And these two together account for the vast majority of our performance regressions. Recently, we fixed a case where we realized that we were fetching a set of media, photos and videos, and fetching all of the comments on every one in order to be used in a view that didn't actually show the comments at all. So there are sometimes obvious cases where you just don't do useless work and you can gain a lot of efficiency. Getting into slightly more difficult areas, we do a lot of caching, not only in memcache, but also just in process, and often just for the duration of one request. If there's something that would otherwise be accessed multiple times, and we can cache it and just do it once. Getting even more in depth sometimes. How many of you in here have used Python? Okay, quite a few, that's cool. It tends to get used a lot in the scientific community, not quite as much in the web community, but it's actually very easy to use and extremely handy. It'll take a Python file, and often with no changes, although you can get additional speedups by adding some type annotations, it will compile it to C code and then run it as native code, often much faster. And so when we have a hotspot in our code that we can't find any more optimizations at the Python level, we'll just change the extension to PYX. Our build chain will automatically compile that using Python, and we can see big gains from that. And of course, sometimes handwritten C can outperform what Python is able to do, and so we do sometimes take an extremely hot spot and just rewrite it in C and call it as a C extension. Stepping back to Django. As we heard yesterday, one phrase that's sometimes used in describing Django's design aims is this tightly integrated, loosely coupled. It's also occasionally been the subject of mockery by those who didn't think we were achieving it, or that it was contradictory. But I think that the success of Instagram with Django is really a case study in the success of this very design goal. Or a similar one, a phrase that comes often paraphrased, it originally comes from Perl creator Larry Wall, is make the easy things easy and the hard things possible. As we heard earlier, Django is tightly integrated out of the box. All the pieces work together. You don't have to figure a lot of things out or make a lot of decisions. And that tight integration, that making the easy things easy, allowed Instagram to get up off the ground very quickly. But when we had to start replacing components, we outgrew the ORM after 5 million users or so. We were able to switch to our own homegrown ORM and later to Tau while continuing to use the rest of Django. There's a lot of Django that still is used every day at Instagram. Among other things, we still use contrib.sessions. We still use contrib.auth. Their pluggable backends have allowed those applications to scale with us from 1 user to 500 million, along with many other things. So long story short, Instagram has been very happy with our choice of Django. And on that note, as a follow-up to Nadia's excellent talk, I'm happy to be able to announce that Instagram is joining the Django Software Foundation as a corporate member at the gold level to help support the Django open source community. We've also now, just in the last few weeks, we've gotten a contributor license agreement, a corporate CLA, in place, which will allow Instagram and Facebook employees to contribute to Django as part of our jobs. As we... So as we at Instagram build towards our next 500 million users, we are counting on Python and Django to get us there. We have no plans to switch to Rust or anything else that comes along. We're planning to stick with Python and Django, and we want to do our part to help keep the community strong. Looking a little bit more towards our future, some things we want to look at in the next year. We intend to be on Python 3 sooner rather than later. In fact, this was a big motivation for getting to Django 1.8 in the first place, is that we wanted to be on a Django version that would support Python 3. We'll probably do this upgrade just as badly as we did the first one, but hopefully also as effectively. Like many people, we want to do more with async, and specifically async I/O. We actually already use async I/O, the Python 2 backport called Troilus, to do fan out of backend data requests from the web server. But we know that we're wasting a lot of web server capacity by using synchronous UWSGI workers to serve all requests. And so we want to explore async web serving. There's a lot of question marks there about how or if we can do that with Django, but I think it's possible, and stay tuned for maybe a future talk in that area. One project I'm personally working on right now is traffic replay. So the idea that we can record production traffic, production requests, store them, and then set up test servers and replay those requests against the test servers. For instance, we can have a control server and then a server with some diff applied and actually collect some performance data from realistic traffic before we ever launch it into production. So again, maybe a future talk on how we manage that. I will be very surprised if this hasn't already shown up in the Slack channel as a question. It did. Thank you. I knew I could count on all of you. We have looked at PyPy in the past, several years ago before I was there. Apparently there were issues with memory usage, and also we do use a lot of C extensions, not only for performance, but also simply because there are C libraries that we need to be able to make use of. And not all C extensions written for CPython work well with PyPy's garbage collection without some modifications or improvements. So we had some troubles with some of that stuff the first time we tried PyPy. PyPy has come a long way, so it's something we'd like to look at again. Again, a lot of question marks there about both for memory reasons and for C extension reasons, whether we'll be able to get it working well for us, but it's something we want to look into. Alternatively, if that doesn't work out, there is some work going on right now by Brett Cannon, I think Dino Wieland, to integrate into CPython itself the hooks necessary for a just-in-time compiler. That's probably a long way out still, but if that happens, that could be huge for us. Lastly, I've been saying we all along for all kinds of things that I had nothing to do with. I'm just here talking about them, so I wanted to take a slide to acknowledge at least the team that I work with, the efficiency and reliability team at Instagram, and all the awesome work that they've done, and many other teams that I didn't have room to fit on this slide. A lot of the stuff I talked about here, there's more depth on it at the Instagram engineering blog, engineering.instagram.com. Feel free to check that out. We are hiring if anybody's looking for employment with Python and Django. And if you want to follow up with me on anything, I'd be happy to chat here or afterwards. Thank you. You need the network, which is not
after my power cable.
Oh.
Feed my laptop. Excellent. So unsurprisingly, we have an extensive number of questions, quite a lot of them around the scaling problems that you have and the other ones. I'm going to start with the most important question. Are there more photos of cats or more photos of dogs?
I'll have to get back to you on that. I need to see if we're authorized to release that data. I mean, obviously, we all know that by heart, but I mean, it's a little bit sensitive.
So let's start with, so you mentioned a bunch of things that you were using, a bunch of profiling tools, internal things, monitoring tools, and so on. within your Instagram engineering blog or something, do you have somewhere where you list all of these that are open source or which bits are open source? I probably had about 10 questions which were, is this thing open source? Is this thing open source, or are you going to?
We do have some posts like that in the backlog of our engineering blog, but I don't think we have anything recent or up to date that kind of lists out everything. So that's probably something that we should look at in terms of an updated blog post and kind of the full stack and the pieces and what's open source. So yeah, I'll put that on my to-do list to talk to somebody about getting that done.
And similarly with sort of monitoring tools and so on as well, do you use, when you're dealing with your errors, are you now all using like Facebook Stack?
Yeah, we're using an internal Facebook stack for monitoring and alerting. And I'm not, I know Scribe, which is sort of the pipeline that gets the data off the individual servers and into the data analysis system. That's open source. I'm not sure off the top of my head which other pieces of the data analysis and alerting stack are open source. Some of them may be, but I'd need to look into it.
All the talk of these enormous scaling problems certainly makes for some entertainment. How much of it do you think is actually relevant to normal size projects, and which of the things should we be considering using ourselves? Is it worth us looking at doing this CA profile extension? Should we be looking at using Tau for a sort of moderate to moderate size website?
Yeah, I think a lot of it is not relevant to most websites. I think Django does a very good job of hitting the 80% use case and focusing on that. And very few web applications ever make it to the level of needing to worry about these concerns. So I think it's appropriate for Django not to, certainly not to make things more difficult for the projects just starting out in order to make it easier for very large scale projects. But that said, certainly some of these things, some of the profiling stuff could potentially be useful even to mid-sized projects, and could be, I don't know how much of it belongs in core. We could maybe have some better hooks in core for detailed performance monitoring of what's going on within Django. That's definitely been discussed before in connection with the Django debug toolbar.
And also with Opbeat and all these other services that provide that sort of tooling and all.
And they're all monkey patching.
Yep.
So yeah, I think there's some things that could be done in core there. I think the bulk of the work could be external packages. It doesn't really involve changes in core.
Do you think that some of your developers or whatever may be able to contribute some documentation about how, here's a collection of moderate size scaling pitfalls that you probably shouldn't do that are quite specific to Django?
Yeah, possibly. We could look into that. Yep. There'd certainly be other people who are more familiar with that stage of the growth than I am personally, but yep.
So moving slightly, last question on the performance per se. Do you use any sort of staging environment, or is it more in a sort of roll it out to small parts of the ecosystem and hope?
Yeah, at this scale, it's pretty hard to have a useful staging environment without making it an impractical size. So no, not really.
Running 100,000 staging Djangos is a relatively expensive operation.
So, what we tend to do more is roll things out to production, gated, and then turn them up very slowly and carefully.
Mm-hmm. So sort of internally, I guess Django, Instagram's a sort of project where predominantly I imagine a high proportion of traffic comes over the API rather than the web directly. Does that kind of influence the choice of technologies and choice of engineering that you're doing much? Do you distribute things carefully and have the API servers run their own thing and you've got separate services to do other things? Or is it kind of more monolithic?
It's all the same service. I don't think we're doing anything particularly interesting in that regard compared to most other Django projects. We have a lot of views that return JSON is what it boils down to. Yep.
And with that monolithic architecture then, is it just, somewhere on your laptop is a checkout of Instagram and everyone's got access to everything and pretty much anyone can work where they feel like, or what's your sort of internal structure?
Well, in case anyone was thinking of making off with my laptop, I don't actually. We tend to do our work on development VMs. over the network. But yeah, no, I mean, one of the cool things about working at Facebook and Instagram is that it's a very open culture inside the company, and so there's a lot of freedom for a developer to go poking around in the things that interest them, and beyond that, actually work on whatever interests them. I mean, there's a very strong culture of development being driven by engineers, and managers are there to support the engineers. So if you think that something needs to be done or would have a big impact, you're supposed to go ahead and go do it and not ask for permission, and then see if it does.
Roughly how big is this code base? Significant lines of code or something? Do we have some sort of idea how big we are?
I don't have numbers on that. I'd need to look into it.
Cool. Your internal Tau base...
It feels big to me compared to my past experiences, but it's about as precise as I can get without research. Sorry.
Your internal usage of Tau and so on, do you use something now that's like a Django ORM, or do you just deal with sort of lower level objects for speed reasons, some name tuples, dictionaries, and so on?
So there is a Python client for Tau, which has been developed very much sort of by the Tau engineers at Facebook, but in very close collaboration with Instagram engineers, because there is other Python at Facebook, but we are by far the biggest user of Tau from Python. And it's different from the Django ORM. I would say one of the key differences that maybe relates to some things Imric talked about yesterday is that it's, compared to the Django ORM, it's much more explicit about when you are going to the network, going to the data store, versus when you're just constructing some objects. So there's certainly nothing like, look, accessing this attribute on an object magically does another query. Some of those pitfalls you just can't afford. But I mean, other than that sort of thing, yeah, it's similar to the Django ORM in that you have objects representing your nodes.
With the gating of features, do you do that within Django? Is it all at routing level?
Yeah, that's done within Django. We have a system that actually uses Zookeeper to push out sort of configuration information regularly to all the web servers, and then features are gated by checking configuration values that are pushed out that way.
With your actual Djangos themselves, what operating system are they running on, and what's your UWSGI setup? Are you using processes, threads, gevent? What are the limits on what you're doing? Is it CPU? Is it I/O? Memory?
Obviously, we're running on Linux. Actually, I don't personally know more than that. I mean, I'm not on the ops team, so I need to check on details there. We're not using gevent or any kind of monkey patching async. Like I said, we're using async IO on the back end for some fan-out data store queries. But the UWSGI workers are just regular synchronous UWSGI workers. What was the other part of the question?
No, that was pretty much it.
Okay, yeah.
I think, hopefully. Sorry? Oh, yes.
Oh,
what's the
bottleneck?
The limits that you point,
Yeah, interestingly, that actually varies some with different hardware generations, which I think is a very rough signal that we're more or less finding the right balance. But we do have some hardware generations where we are actually memory constrained and some others where we aren't.
Obviously it's still a while ago, so you may not know all the details. When you're going through this migration from single details to vertical sharding, or vertical sharding to horizontal sharding, and so on, was the process, do you use any particular tools for the process, or is it all kind of manual configuration and hope?
So for the migration from one data store to another?
From migration to like multiple, migrating from one massive shard to lots of little shards, from your vertical sharding to your horizontal sharding.
Yeah, well, I mean, obviously I wasn't around for a lot of that, so the slides got pretty close to the extent of my knowledge about some of the historical stuff. I mean, I was around for the latter half of the transition from the horizontally sharded ORM to Tau, and I mean, that was done, again, really no magic, just a lot of like elbow grease. I mean, like, it was sort of like all of these things when you're working at a large scale, it was a slow and iterative process where it's like you take one one type of data at a time and one view at a time, and you often have the data stored in both places with some background jobs running to make sure things are not getting out of sync, and then eventually you cut it the whole way over and you can get rid of the old data store, and then you just keep iterating on that with one type of data after another until you're done.
You were saying about moving towards Python 3. Do you have any estimates for the timescale? How far along are you?
I don't have estimates, but I'm sure you will all find out when we're there.
A couple of things looking forward. I mean, obviously, we are.
You should know better than to ask a software developer for estimates on stage. Good grief, Mark.
I will point out that Arm asked that question. So looking a bit more towards the future, obviously, as the DSF, we are delighted to welcome Instagram as a corporate member. Someone has asked exactly how much the contribution on the gold is. You said gold level sponsoring. That might not mean anything to most people in this room.
So gold level, I believe, is 25,000 per year and up. Yep.
Within that context, are you intending to stay on 1.8 for a while? Are you wanting a longer LTS on 1.8? Are you wanting to move upwards to the next LTS when it comes out?
That's a great question. I don't think we totally know the answer yet. I mean, the move from 1.3 to 1.8 was a lot of work, and I don't think people are really eager to put in that kind of work again. I'm hopeful that the next time around will be easier. I think it's very unlikely that we'll go version to version. I think we probably will try to go LTS to LTS. But we'll have to see. I mean, Python 3 was a big carrot because of async and because of type annotations. We really wanted to be on Python 3, and so we needed to upgrade Django to get there. So that was a really important carrot for getting us onto Django 1.8. And at this point, I'm not sure what the carrot will be for the next Django upgrade. And so there may be some temptation. I mean, the work of backporting security patches can actually look tempting relative to the work of upgrading. So I think there's some uncertainty there at this point.
Do you feel the channels or other projects that we're looking at, do you think channels is going to be useful for your asynchronous efforts, or are you thinking you're going to be at a much lower level than that?
Is it Andrew here? Hi, Andrew. I actually discussed that very question with Andrew over breakfast this morning. I think that channels is really solving different problems than the ones that we have. I mean, we do WebSockets or real-time communication, but we already have a whole separate system set up for that integrates with Facebook infrastructure and uses totally different technologies, and it's pretty unlikely that we're going to want to push all that back into Django. And that's really the primary problem that channels solves. I mean, the problem we have is wanting to make the entire web request from client all the way to backend data stores and back all async, which would allow our workers to serve many more requests concurrently. And that's not a problem that channels in its current design even tries to solve, because it keeps all of the Django view logic in a synchronous worker process. So yeah, I think channels is very cool, but it's solving different problems than the ones that we have.
And final question, what surprised you most about everything when you joined Instagram?
I mean, this is going to sound like a little bit saccharine, but honestly, like just how nice my team was. I mean, like I had never in my career worked for a big Silicon Valley company. Like I ran my own company in the Midwest for 8 years, and I was a little bit apprehensive about what it would mean to work at a big Silicon Valley firm. But like my coworkers have been awesome. I mean, yeah, in every way. So very smart and very easy to work with, and just a really fun and collaborative work environment.
Excellent. Well, thank you very much, Carl, and thank you very much, Instagram.
Thank you.
Thanks, Carl. Great talk.
Thank you.
Okay, so that concludes the main set of talks. And so we now move into how do we make things better time. So, in order to do that, we will be having sprints tomorrow and on Sunday. And to help introduce you all to sprints, who's been to a Django sprint before? Okay, maybe it's easier to ask the opposite question. Who's never been to a Django sprint before? That's still quite a lot of you, so hopefully this will be really, really useful for you, but I hope everyone else will stick around as well, because we'll be able to go through a few things that we're trying to do. So I'm delighted to welcome our Django fellow, Tim Graham, who's going to give you a bit of an overview. A couple of other people might get involved at times as well. So we're going to talk through how does Django work, how do we contribute to Django, and what are we going to do for the next 2 days. Please welcome Tim.
Can you put the speaker notes on?
I can try that and see what happens. Speaker notes. There we go. That looks promising, doesn't it?
Yep.
Oh, the mouse is gone. Excellent.
Thanks, Mark. Hello, everyone. My name's Tim, and I'd like to give you a brief overview of the Django contributing process. I hope you'll get something out of the talk, even if you don't plan to attend the sprints or even contribute to Django. I'll start by describing my own Django story a little bit. Maybe it'll inspire you if getting involved in open source is something that you're interested in doing more of. Just a quick note that I live in Philadelphia, so depending on where you live, if you want to get in touch with me on IRC, just be aware of the time difference. I started contributing to Django in 2009, and for about 4 years, I contributed only documentation patches. So this is the first patch of mine that I could find in the commit history, and as you can see, just a few lines of documentation. After about 8 months of submitting documentation patches, I got an invitation to join the Django team as a documentation committer. Here's an excerpt I found from the Django team mailing list where the team was discussing possible candidates for the team. My track alias at the time was Timo, which is a nickname that came out of middle school Spanish class. And here we see Russ asking if anyone knows who this Timo guy is, and Giannis spills the beans. So as far as the perception that the Django team is an exclusive group of friends, here's some evidence that you could be invited to join the team even if no one knows who you are. So how did I go from being a documentation contributor to being the Django fellow? Around June 2013, I had some free time at work as the startup I worked at was winding down after an acquisition. I wanted to get more involved in Django development, so I started reviewing and merging pull requests. Then after some months, my job ended and I continued working on Django while I took some time off to think about what to do next. The idea of the Django Fellowship had been floating around for some time, so I guess I showed its merit enough to inspire the DSF board to make a final push and start a 3-month pilot program. The pilot started in October 2014, and the program was renewed on a fundraising permitting basis shortly thereafter. It's been a bit over 2 years now that I've been contracted to work full-time on shepherding Django's development. So here's a quick overview of some of the tasks that I do. The first task is monitoring the security email box for reports of security issues. I also write patches for security issues from time to time. The next responsibility is about ensuring timely releases. As Mark and Nadia talked about, before the fellowship started, releases were, let's say, unpredictable. Now we have a major release every 8 months, and Django 1.8 through 1.10 have all been released on schedule. We also have monthly bug fix releases to correct bugs in new features and regressions in the latest stable version of Django. The majority of my time is spent reviewing and merging pull requests from all of you. Before the fellowship, we had a big problem in that most people enjoy writing code, but fewer people like to review it. Contributors would give give up when their contributions went unreviewed for months. Giving timely reviews keeps contributors enthusiastic. On the topic of regular releases, this is a nice graphic from djangoproject.com/download that shows Django's lifecycle. Right now, you can see Django 1.10 has been released and is receiving bug fixes, while 1.8 and 1.9 are receiving security fixes. Development in the master branch continues toward Django 1.11, the next LTS, and we'll create the stable branch for 1.11 around the alpha feature freeze in January. After that, master will target Django 2.0, which will drop support for Python 2.7 and support Python 3.5 and later only. Show of hands, is anyone going to miss Python 2? No. A few people. I can say that I will not personally miss it. So just a quick plug, if you like regular releases with lots of features and bug fixes, I'd be grateful for your support of the DSF. We're making good progress towards our goal for this year, but we still have a ways to go, and this goal does much more than just pay me. For companies, you can consider becoming a corporate member. As Carl mentioned, we also have lower tiers besides the $25,000 gold membership, but that will be the second one besides JetBrains. That'll be great. As I scroll through the other corporate members, you can see if your company is there. If not, maybe you want to ask why not. And I'll also talk about some of the other things the DSF does. The DSF organizes and funds development sprints so that Django's developers can meet in person, often bringing someone from the team to mentor new contributors in a sprint. They also provide financial assistance to community development and outreach programs such as Django Girls. And finally, the DSF also provides financial assistance to individuals so that they can attend conferences and events like this one. All right, that wraps up the talk about the DSF. Now I'd like to take a quick survey. How many people have written a patch for Django? That's pretty good, maybe half to 2/3. How many people have reviewed a patch? Maybe a quarter. So a theme for this presentation is going to be to encourage all of you to do more review, even if it's not as fun as writing code. All right, here is code.djangoproject.com. It's a nicely styled deployment of Track, a bug tracker written in Python, sadly not Django. But tickets for Django and its documentation use this tracker. Tickets for other projects under the Django GitHub organization, such as channels, will use the GitHub tracker, or GitHub issues. Here is dashboard.djangoproject.com. It collects and computes different metrics from Track. This is a useful starting point because Track's view can be more difficult to navigate, we'll say. For example, this is a screenshot from the dashboard that shows number of open tickets by triage stage. We can use the dashboard when triaging tickets. What does triage mean? The original use of the word triage came from the process of determining the priority of patients coming in for medical treatment based on the severity of their condition. The same ideas, albeit less dramatically, applies to software development, where a bug report or feature request is our patient. This is what a patient or ticket looks like. I'll highlight a few of the fields. Component means what area of Django does this affect. It's useful if you're looking for a ticket to work on. With around 1,000 open tickets, it can be overwhelming to choose. So I often suggest to new contributors to pick an area like forms, models, or a specific contrib app to help narrow down the choices. Severity will be normal or a release blocker. Release blocker could be a regression from an older version of Django that we want to try to fix before the next bug fix release. It could also be an important bug in a new feature in the latest stable release that should be fixed in a bug fix release. And then normal severity is everything else. Next is the owner field. When you start working on a ticket, you should claim it so that someone else doesn't also work on it. If a ticket looks interesting, Don't let the fact that it's claimed discourage you. Take a look and see when it was claimed. If it's been weeks or months without any updates from the author, it's probably fine to take ownership. Next, version describes the version in which the bug was discovered. If someone reports a bug in an older version of Django, we'll want to confirm that the issue still exists on Django's master branch. For bugs, for example, it's great to write a test case for Django's test suite. If you're reporting a bug and can provide a test case, you'll save the triager some work. Next is triage stage. A ticket has several stages. This is a graphic from the contributing documentation that shows how a ticket can move through various stages. I won't explain it in detail now, but the important point to note is that anyone is permitted to triage tickets, not just members of the Django team. Under the description, each ticket has an according to the ticket's flags box that describes the next steps to move a ticket forward. This box is something that I added a couple of days ago, so if you find something confusing here or have an idea for an improvement, the code lives in the code.djangoproject.com repo under the Django GitHub org. Under the hood, some JavaScript in a file called trackhacks.js parses the tickets fields and creates this box's content. As Marcus said in his review of this feature, this quote, "This is a really great piece of JS, which is really suitable for track hacks." You can contribute your own track hacks if you wish. Next, we'll talk about creating your patch. The first step, assuming you're working on a code patch and not just documentation, for example, is to be able to run the Django test suite. If you search for Django contributing tests and click on the unit tests link, that will lead you to this page where you can find instructions for getting a copy of Django and running the tests. Another option that eases running Django's tests, especially on databases besides SQLite, is the Django box virtual machine. Depending on the ticket you're working on, you might need this. You can also run tests against the database installed on your machine, but some configuration might be necessary. If you have problems or questions about Django box, this is your man, Josh Smeaton. Sitting over here. He's done the work to update the box to work with recent changes in Django. If you have any trouble, please bother him and not me. Your patch should always target the master branch. Fixes for regressions may be backported to one of the stable branches, but the committer will take care of that. You can read about the details of our commit message format in the patch review checklist, which I'll talk about later. But please do your best to follow the format as it applies to whatever you're working on. After you've created a pull request, update the ticket so that it appears in the patches needing review queue on dashboard.djangoproject.com. The has patch checkbox should be checked, and needs documentation, needs tests, and patch needs improvement unchecked. Add a link to the pull request in the comment when you update the flags. Hopefully the ticket next steps box that I talked about earlier will guide you. Here's a slide that I love, created by Loic when he gave a similar presentation a couple of years ago. I hope receiving a review from me isn't really this dramatic, but you can talk to him to find out more. Anyway, my review is probably coming at some point, but it's really helpful if someone else also reviews the patch. I'm not an oracle that can spot every problem or suggest every improvement to a patch. The goal of the sprint should be for you to find a friend to review your pull requests and mark it ready for check-in if all looks good. During the sprints, I'll be walking around giving advice and won't have much time to review pull requests myself. Once we have a pull request, then we need to review it and merge it. The first question to start is where to start if you want to review patches. When I go to review patches, I look at the patches needing review box on dashboard.djangoproject. Make sure the flags on your ticket are set correctly. You did create a ticket, didn't you? Trivial patches such as typos or minor cosmetic cleanups don't require a ticket, but anything non-trivial requires a ticket to help track the pull request. Once again, the Django docs are great when it comes to SEO. Simply searching patch review checklist, no Django necessary, will turn up the documentation you want. Here are the first paragraphs of what the checklist looks like, and I'll briefly mention a few parts of it now. Just like Python and much of the ecosystem, We use restructured text and Sphinx for documentation. You'll want to make sure the docs build without any errors. Sphinx has a spelling plugin to find incorrectly spelled words. Patches that add new features, make backwards incompatible changes, or start a deprecation should include appropriate release notes. As we heard earlier, you can ask Loic if you need any advice in that second area. Documentation also has added, changed, and deprecated annotations that look like this, and that render like this, so that, for example, third-party library authors can see what's changed recently if they're supporting an older version of Django. As an aside, we have a process to translate Django's documentation into any language. Has anyone contributed to that that's here? A few people, cool. It's time for the annual leaderboard check of this project. As last year, the French are in the lead. This is thanks almost single-handedly to Claude Perrault, one of the members of the team, so hats off to him. For enforcing some basic coding style, we use Flake 8. iSort is used for automatically sorting imports, so we don't have to think about that. Tests are required for all patches, unless you can prove that it's infeasible or impractical to write one. We have several servers that provide our continuous integration infrastructure. The web UI for our Jenkins cluster is accessible at djangoci.com. Each job has a matrix that includes the supported database and Python versions. There's also a coverage report, so a possible sprint task could be reviewing this report and writing tests for untested code. The current reports only use a few selected Python database combinations, but we're working on a combined coverage report that will aggregate across all the database, backend, and Python versions. Pull requests, or commits and pull requests, are typically in a single squashed commit unless the commits are truly independent. If you're a new contributor, please sign the contributor license agreement and add yourself to the author's file in your patch. Let's look at a pull request. When creating a pull request, you can put some additional details in the description, and it's helpful to include a link to the ticket in the description. For huge patches or when making a lot of follow-up changes, separate commits that address review comments are helpful. Otherwise, if the patch is small or if only minor changes are needed, feel free to simply amend the original commit and force push to your branch. To prevent abuse from spammers, first-time contributors need to be added to the Jenkins whitelist to allow the tests to automatically be run on their pull requests. Jenkins pulls for these trigger comments every 5 minutes, and you'll see a link to Jenkins when the build starts. Here's Jenkins running the tests on a pull request. If everything goes well, you'll see the green check marks. If you get a red X, then click the details to the right of the corresponding status to find the results. Here are some test failures as reported by Jenkins. You can click on each one to get the details of the failure. When the commit is merged, the ticket should automatically be closed if you follow the commit message guidelines. Sometimes people will ask, what can I do if no one reviews my patch? This is less of a problem as long as the fellowship program continues. However, I'm not an expert in every area, and your use case may be something that I'm not familiar with. I might be able to give a style review, but someone else might be able to do a better review of the design and logic in better detail. If you find a friend to review your patch and mark you ready for check-in, that's motivating for me. I'm more inclined to review a patch, even if it's out of my comfort zone, if I see that there's more than one person interested in the patch. It's good to keep in mind the saying, never attribute to malice what you can attribute to busyness. Hang out in the Django Dev IRC channel and observe the conversation there. Most of the time it's quiet, but once in a while there'll be a really interesting conversation. Keep in mind time zones when pinging someone. The Django developers mailing list on Google Groups is another place to watch if you want to get engaged in Django development. For large patches that need design decisions, get feedback and sign off on general design there before starting to code. One more reminder, anyone can review patches and mark them ready for check-in. Here's how you do that. Here are a few tips about what to expect in the sprints this weekend. First, a sprint is a good time to learn the basics of contributing. For example, if you have trouble running the test suite, it's often easier to debug these problems in a face-to-face setting. Second, it's a good idea to bounce ideas off some of the senior members of the Django team who have a lot of experience. Keep in mind that once you're on the Jenkins whitelist for pull request building, each time you push to your pull request, it kicks off a new build, which takes about 10 minutes. So if you do checks such as running code linters and running the tests on at least on SQLite on your local machine before creating a pull request, that will help you avoid small fix-up commits. Don't expect your patch to be merged in one day, especially during the sprints. Find a friend to review it and mark it ready for check-in. I'll take a look when I get home. Of course, next week is pretty much the craziest week, since there will likely be tens of new pull requests as a result of these sprints. Be patient, and if things go well, hopefully we can merge most patches started this weekend by the 111 feature freeze deadline in mid-January. Now we're going to talk about a few ideas of things to work on in the sprints. First, I'd like to invite Jacob to talk about his ideas.
Stuff. This is somewhat last minute, so I just have some notes here. So Tim talked a lot about sort of what I guess I could characterize as making small changes to Django, like submitting patches and getting smaller things in. So I thought it would be a good idea to talk a little bit about making large changes to Django. Like, let's say you wanted to build and wait for Django to do WebSockets and asynchronous programming. How might one go about doing that? So the thing is, and the reason I want to talk about that is it's getting harder and harder to contribute to Django. Django is old and boring, and the low-hanging fruit has kind of been picked at this point. There's not a lot of things left that still need to, a lot of major changes that still need to be done that aren't really hard. You know, for example, we all kind of acknowledge that settings is suboptimal, but actually fixing that is going to be a monstrously complicated task. So it's getting much harder for people new to the community to contribute to Django. It's unlikely that anyone who hasn't been working on Django for many years would be able to take on a task like that. And likewise, something like channels is rather large and speculative, and it's also unlikely that someone would be able to show up and get that committed to core. I mean, if Andrew can't get it committed to core, like, how should we expect someone new to the community to do so? So the core team met before the conference started yesterday, and this was one of the things that we talked about, and we want to be doing big things and weird things and forward-looking things and experimenting with new stuff, but Django is old and crusty, and putting new things in is hard. So I want to lay out kind of a couple of paths for how to do big stuff. Those two paths are DEPS, the Django enhancement process proposal, DEPS Django enhancement proposal, the DEP process, yes, and then sort of a new path, an emerging path. Yes, actually, no, DEP process is good. It's introducing new technical debt. It's warm up here. Okay, so, and the second path, which I'll kind of call the sort of the path from outside, and I'll come to that one later. So DEPs. So DEPs are based on Python's PEPs, which is the process they created for making new changes to the core Python language. And like that, DEPs are for core changes to Django. You need to change Django's APIs. You want to change settings. That would be a good example. Or you want to add composite primary key support. You need to change core APIs to Django. It's going to be possibly an invasive change, possibly a backwards incompatible change. This is the process you would go through. There are also process and policy DEPs. I'm working on a policy DEP about dependencies. So that's an example of something that's not actually going to change code, but it's going to change how we do things in the project. That's another sort of reason you might want to write a DEP. DEPs are also sort of intended for ideas that are fairly well formed and where there's emerging consensus or at least a couple of 3 interesting ideas. DEPs are not good for things that could be done entirely outside the core, things that are like super speculative. and brand new ideas that haven't really had a chance to form. You know, proposing adding support for some super new JavaScript front-end framework that you think is the future probably isn't going to get a lot of traction because of the rate of change in that community. But at the same time, that's why we have this path from outside thing, because we don't want to discourage that kind of work, but it's not quite right for a DEP. So DEPs basically look like this. You discuss with people. Here would be a great place to start discussing it. At some point, you're going to need to find what we call a shepherd. That's someone from the core team who's going to possibly merge your code, although these days it's more likely that Tim will merge your code. But definitely will be the person who will sort of be your champion on the core team, who will make sure that enough people are paying attention to what you're doing, who will give you advice. You can think of this person as a mentor, or a combination of a mentor and a cheerleader. Without a shepherd, things won't move forward. You don't technically need a shepherd to write a DEP, but you will need one to really make any traction at any point. So you probably want to make sure you can find someone on the core team who's excited about your idea before you waste your time writing the DEP. So you write a DEP. If you look in the github.com/Django/deps, DEP0 tells you how to do this. You may want to write an implementation, depending on the complexity. If it's, if you need to write code to figure out what to propose, that's probably fine. It doesn't need to be complete or full or done. A sort of a prototype can be fine. And you don't have to write code, but if you're proposing something rather interesting or complex or weird, having some code that people can check out would be useful. You'll submit the DEP to the repository. There'll be some discussion. Bringing it to Django Dev is a good idea. You're looking for rough consensus. It doesn't necessarily mean you're looking for everyone to agree, but you're looking for a general tone of, yeah, this is a good idea. You'll probably get some feedback. You'll probably need to make some changes. There'll be an iterative process there. Once you and your shepherd think, okay, we've got this nailed, you submit it to the technical board for a ruling. The technical board is probably going to default to saying no. It's easier not to make it. If you don't make a change, you can always then make that change later, but making a change and then backing it out is a lot more of a risky behavior. So you want to be pretty sure that you're going to get a yes before you submit it to the board. Has the technical board ever said no on a DEP yet? Yeah, I don't think the board has actually said no yet. Like, the board will almost never sort of go against what they perceive as a consensus in the community. And then you get to write some code, you and or your group and your team. I highly suggest, if you're taking on something complicated, that you find more than one person to work on this. Save yourself from burnout, have some friends, people to bounce ideas off of, etc. You finish, you merge your code, it's shipped as part of Django. Okay, so that's been the traditional path of like how you would get new things into Django. But as I've said before, like, that's not good for speculative stuff. That's pretty hard. I mean, that process may have sounded like a lot of steps and a lot of time and a lot of, I said consensus a lot. You need a lot of people to agree with you. So what happens if you want to do something that's kind of wild, that is weird, that maybe is kind of controversial? What was that? You want to rewrite forms. You want to build a new admin. You want to write a new way of doing APIs. You want to make Django run on a mobile phone. Russ is here somewhere. So there's a path that's starting to emerge. We don't have a good name for this, but there's a path that's starting to emerge for this kind of work. I'm calling it the sort of the from the outside path, the outside in path maybe. This is good for things that don't require sort of changes to core APIs, or maybe that require monkey patching. That's kind of like, you can sometimes think about separating, a small patch to add a hook that you need, and then doing the weird thing as an outside package. It's a good example of something that's done that. GeoDjango is actually a fairly good example as a thing that started out as an external package with a bunch of monkey patches against Django, and then over time those monkey patches became hooks and first-party features, and then eventually GeoDjango got merged into Django itself. Yeah, Django security is another example of a thing that did that. So this path is less defined. We really sort of first started talking about it yesterday. So it's not entirely clear exactly how this is going to work, but all the pieces are there. The idea is you build your thing, whatever it is, how weird and speculative, and really I want to encourage you to do weird and speculative stuff. The whole purpose, the reason we want to sort of pave this path is so that we can support trying out new things. Write the code. Please use a license that's compatible with Django. I hate that that has to be a thing, but if you do something amazing and it's GPL licensed, it's probably never going to end up as an official part of Django. So it probably needs to be lawyers. So you write your thing, you get it out there, you get people using it, you get traction, just like any external third-party package. Again, we're a lot more likely to consider sort of a small patch to support some new feature than we are a big change, right? So if you have monkey patches, it's probably fine to demonstrate what the hooks that Django might need to add, but maybe try to get those, merged the way that Tim was talking about. At some point, if you're successful, your thing it'll be obvious that your thing is becoming a de facto standard. It was for a while there were a lot of migration frameworks for Django, and at a certain point it became fairly clear that everyone was using South. If your project gets to that point, we now have a thing called an official project, which is basically something that's part of Django the team and Django the community, but not exactly part of the code base. There is an official project's dep, which lays out the process for becoming it. Basically, the idea is instead of github.com/u/whatever, it's github.com/Django/whatever, and it comes with more support from the core team, probably things like access to our CI servers if you need it, kind of more sort of official support from the project. Channels is the first one of these. We came up with this idea because we had this thing, channels, that we felt was a really important part of the future of Django and was widely supported by the core team, but not quite ready to be part of Django itself. And so official projects was the way of making channels part of Django the ecosystem and part of Django the sort of project, but not part of Django the code base yet or ever. It's not clear. If something's an official project, why does it actually have to be merged into the code base? That's still something we're trying to figure out. If you want something to be a dep, basically, it's an official project, you'll need to have a maintenance team, and you'll need to have a shepherd, just like for deps. And then basically at that point, the process is fairly similar to a dep. You ask for a review by the technical board. If you get a thumbs up, it gets moved into github.com/Django. And you presumably get that additional support and help from the rest of the core team. Again, this is fairly new, and so we don't know exactly, this is going to change over the years as we figure out how this works. Once it's there, the path from sort of everyone is using this thing, now let's actually ship it with Django by default, starts to get a little more clear. We haven't crossed that bridge with anything yet. We'll see what happens with channels if we decide. There's an argument to be made. I will make the argument that packaging in Python is good now, and so shipping with core versus installed with pip alongside Django is sort of becoming a fairly meaningless distinction. What's the difference between pip install Django and getting channels automatically, and pip install Django channels and getting both of them? But we will see. Maybe there is a value towards merging things and keeping them, all in the same package. We will answer these questions later. And I am being given the wrap it up signal, so I will wrap it up. I'll be around at the sprints tomorrow, but not Sunday, and if you want to talk about this more, please find me.
That's fun. If Tim can come back up, we've got a couple of questions. Starting off one actually for Jacob, but I can possibly answer. What's an example of a license that's compatible for Django recommendations. I mean, what I do in my project is I copy and paste the Django license, change the bit that says Django Software Foundation and put my name, and that'll do.
Yeah, BSD, Django uses the BSD license, so if you don't have a good reason to use another license, use the BSD license. I'm not a lawyer, and I'm not going to try to get into license compatibility at this point. So if you, for some reason, can't use the BSD license, you probably need to talk to a lawyer.
Okay, so a couple of questions, possibly for Tim or just in general. Why do we use our custom Jenkins setup rather than using a platform like Travis CI that would in theory be easier?
At least one reason is Oracle.
That's a good reason. Are there strict requirements for the pull request formatting still as necessary now, given that it's easy for you to change it with the squash and merge feature?
It's great if you can try to follow the guidelines, but I can make minor edits as needed. So.
Great. Would Django consider accepting, it's possibly a question for more people than just Tim, but would we consider accepting pull requests that add failing tests with the expected failure decorator if we can't find a patch, just to sort of keep that documentation in there that we know this is a failing problem, and should that situation change in the future that we'd be aware that it might fix a particular ticket or something?
Yeah, I've seen a few tickets where they have been fixed in the meantime, and then I commit the patch or the test that's usually attached to the ticket. I guess my fear is if we start putting these tests into the code now, they might not be correct. You know what I mean? So
yeah, it might, and it also might grow quite large quite quickly. There's
right.
a large surface area of tests that don't work.
It's sometimes we refactor the tests, so if we also have to refactor expected failing tests, we might refactor them incorrectly. So
this question is followed by this person's going to go and hide from the question. Would Django consider moving from track to GitHub issues? I think I actually briefly had this discussion. If we don't have 4 figures of issues all the time, maybe, but we've still got well over 1,000 open issues, and tracks filtering and slicing and dicing of the issues gives us a lot more flexibility to find what we're looking for.
Another blocker is that we like the community to be able to triage issues, and right now GitHub only allows collaborators on the repository to make changes to issues in terms of closing and things like that.
Yeah. Excellent. And thank you very much to both Tim and Jacob, and happy sprinting. Okay, I shall try to keep this brief. We have a few things to wrap up the conference. What? So the sprints tomorrow are at Impact Hub. They will start from 10, 9, something. Check the website, I can't remember. 10, excellent, thank you. I have an organized team. I have one brief announcement which may be of interest to you. Approximately 1 hour ago, ticket sales for DjangoCon Europe 2017 opened. Woo! It will be in Florence in April. The call for proposals has been open for a while. I've put in 2. I've probably got another 2 proposals I could do, but you don't want a conference full of me talking, so everybody else should put some proposals in too. Jacopo, I have seen, is around. He's going to be one of the lead organizers. He's waving his hand over there. So if you have any questions about DjangoCon Europe, that's the person to ask. There are still a few spaces for some of the dinners, I believe. If anybody's interested to do that, please go and sign up for them. There is a limit to the size, or is it all gone? All dead? Excellent. Well, I'm looking forward to seeing you then. The conference doesn't happen without the huge amount of support. Particular thanks to the Dutch Django Association and to Yuri Becker, the treasurer, for handling all the financial side of things. I'd like to thank Sonoma for their very generous support, and also all of the other sponsors that we have. I'm going to make a special mention of Mirami for their spectacular shirts. I know there have been some conversations about putting these on general sale to support the DSF, which would be wonderful. Many, many, many sponsors. Thank you very much. And finally, thank you to Sentry in advance for the social evening tonight. It will be at 8:30 at a place whose name I still can't pronounce. It's on the other side of the water somewhere. Plek. I don't know. I'll get Eric to say it later. Food? Yes. There isn't. Eat before. There will be some minor nibbles maybe at the party, but there won't be dinner, so go out for dinner first. Thank you, Ola. Once again, thank you to all of the Potato Nauts, or whatever your proper name is, potatoes, people from Potato, who built all of these wonderful sparkly things, most of which are still lit up. It took a huge amount of effort and a lot of firmware coding on the train on the way here in order to get them to work as well as they do, so thank you very much for those. I'd like to say an enormous thank you to all of our speakers. Preparing an hour-long deep technical talk or a deep talk is an extremely large undertaking. I've been working with these people a bit over the last few months. They've all been fantastic to work with. Most of them got their slides in early. But I think all the talks have been absolutely fantastic, and I hope you all agree with me. So can we just have a final round of applause for all the sponsors? Speakers. If the lovely people standing over there and sitting down here would like to come up onto the stage. Most of the time, you see me standing on stage here at this conference. If I was the only person running this conference, I can assure you it would be a total and utter disaster. All of these wonderful people do lots and lots of different things, sort of dealing with sponsors, helping with the financial aid program, helping with all of the things on the ground with the venues, dealing with producing all of these beautiful things as well as these beautiful things, getting badges, t-shirts, helping me with remembering speaker gifts, which I'm atrocious at, dealing with code of conduct issues, all of the many, many, many things that go into running this conference. Generally speaking, we've been pretty chilled this year, which is a testament to how well we work together and how wonderful everybody is and how much we can trust each other. So I would like to say an enormous thank you to all of these wonderful people, and I would like you to join me. Okay, you can go away now. I'd like to say a huge thank to all of the people who've helped on-site in the course of the thing. We've had a number of people just step up and help out with bits and pieces where they're necessary. Thank you very much to the technical team upstairs and to Cheryl and Hillary for their wonderful help with that. There's a lot of work, and to John for the recordings and the live streaming. It's been really cool to have questions coming in from people all around the world watching the live streaming and be able to answer them on stage. So thank you very much to all of the other people who aren't organizing, who work behind the stages on the day. You've all been fantastic as well. And a final apology to Cheryl and Hillary for how fast I speak. And finally, thank you to all of you. It would be a pretty rubbish conference if nobody came. You've all been wonderful. I hope you've all had lots of fun, and I'm looking forward to going out for dinner with you, sprinting with you, doing more stuff with you over the couple of days. And we will then see you all this evening at the party. Before you go anywhere, we're going to do a big group photo. Somewhere up in the rafters is Bartek. Yeah! Which reminds me, Bartek is our wonderful photographer. Okay, so if you can come out a little bit if you're over the overhang, if you're a little bit right round the edges, if you can move up and round a little bit into the gaps. Core team, that's you, move. And then hopefully Bartek will signal in our